Maybe wait a few minutes.
Yeah, that's what I'm saying. Just a show of hands, how many people in here presented a poster? If you had a poster, raise your hand. Yesterday. Got 2 here, 2 there, 1 at the back, 1 there. Okay, so is that about 20%? Try to give them deal with throughout the day.
Just a few. I think people late. I just don't want to hold out the entire day. Person. First person. Okay, okay, can we? Fine. Yeah.
Better start with you. We'll do the poster. All right, so in the interest of keeping the ball rolling, we're going to start with the presentations right away, and we'll do the poster award after the first presentation instead. That way we can start the day just a little bit late rather than very late. All right, so it's my pleasure to present Dennis Swativakis. He's an IEEE Fellow and ACM Distinguished Member. He's a Chancellor Professor and Graduate Director in the Computer Science Department at William & Mary. He currently serves as Guest Editor-in-Chief for the AI-SC Continuous Special Section for TOSM and is a PC co-chair for FSC 2025, one of the biggest conferences in software engineering. And he's a recipient of multiple ACM SIGSOFT Distinguished Paper Awards and the NSF Career Award in 2013. So, Dennis, take it away.
Hello, can you hear me? I'm super excited to be here today. Thank you very much for the invitation. In fact, this is not my first time at the College Polytechnic. I've been here almost 15 years ago. Golden times of manual feature engineering versus science of automated feature discovery kind of age we live in right now. I remember those times when Giulio Antonio, Jan Geil, Fulks, believe it or not, was a PhD student back then. So we had really, really good time productive discussions. So today I'm going to talk about one of the biggest challenges, in my opinion, that we're facing these days. And I think Ahmed mentioned it yesterday in the panel and talked that debugging and testing these foundational models is becoming a big issue. And this is actually a very challenging thing to do. So what we're trying to do in this work is provide some sort of foundation to be able to do that. So let me start just with a reminder that we as a research community are very, very fond of aggregated metrics. Okay? And this is just a fact. If you don't believe me, take any recent 200 papers on the foundational models, and you'll see that all those models are pretty much evaluated using aggregated metrics, right? This is obviously useful because it can tell us whether a certain model classifier is better than the other in terms of aggregated view. Like in this particular case, we have a classifier which is doing a pretty good job in terms of classifying women and men faces, and it has accuracy of 90%. And this is obviously an aggregated view of performance of this model. But actually, when we drill down into classes of various classes of images here, we actually know that it's not doing so well. For example, on classifying women faces with darker skin color, here we have pretty high error and also lighter skin tone. So, obviously, we were able to get this insight only by using this segregated metrics, right? Decomposing into various classes and actually seeing where this classifier fails or excels. So this is actually well known as Simpson's paradox, and obviously this is very, very important for us, right? Because these days we talked a lot about fairness yesterday, privacy, support, and so on. Understanding when these models do well and when do well is actually very important. Obviously, the same thing can be said about source code, the software context, right? If we have a large language model which generates code, let's say some condition generated code. Here we also have aggregated accuracy of 80%. So the model is doing a pretty good job in terms of auto-completing code, right? But actually, when we drill down into how well it's doing across various classes, and let's say in this case we're able to differentiate between generating getter setters or snippets of functional programming or for statements of cycles, we see that the performance of the model actually varies. For whatever reason, you can see that it's doing much better in terms of generating getters and setters, and it's actually not doing that well in terms of generating snippets for functional programming languages, right? So again, we can do that only if we use segregated methods. And also what we note is that obviously these are confounders, right, that allow us to decompose performance into these meaningful clusters to better understand performance of the model. So one thing which I wanted to point out is that these aggregated metrics are great. We've been using them. We've been comparing these models, but they offer only partial understanding of the inference process, right? And obviously that's not enough for us, especially as we try to debug or test these models. We need much better in-depth understanding how these models are doing and why sometimes they're generating suggestions that they are generating. So let's look into the situation from practitioner's point of view, right? Again, we have ChatGPT with our foundation model here, and we're trying to autocomplete this particular code function. So that's our prompt, right? And this is the result of the code completion process. And as you can see, and quickly read this snippet of code, it has done a pretty good job. It generated exactly the code that we wanted, right? So we're doing well here. But now we have some sort of system behind it that tries to explain why it generated that code that we are seeing on the screen, right? And in the first case, I have two explanations or possible quote-unquote explanations. In the first case, the model is basically telling us, well, I generated the code because I used or I relied on these kind of features in the prompt, right? And as you look into those features that the model highlighted, you're like, I don't see why the model generated the code that generated based on those features. So I don't think I can really trust this model because basically it's telling me it's using some sort of features that I don't understand why they were used in production of that code. Whereas the second case, right, it's highlighting some keywords that are indeed relevant to the code that generated. So in the second case, you probably would have much better confidence, right, in this model and in the explanation that the model is showing you. So model understanding obviously facilitates debugging. And there are many uses of interpretability because obviously model understanding is very critical these days. I believe it's going to be even more critical as foundational models embed themselves into every aspect of our lives, right? Eventually, we're gonna start dealing with some critical failures, right? And at some point, we're gonna be asking these questions more frequently, right? Right now, I believe we're in this phase where things are great and we're just adopting them all over the place without sufficient accountability. So interpretability facilitates debugging, it facilitates detecting bias. It provides resources for practitioners who are negatively affected by predictions. It helps us to vet models to determine if they're suitable for deployment. And it also helps us to assess if and when to trust model predictions when making decisions. So obviously interpretability is not a new concept, right? In fact, there are two classes of interpretability here. You can see intrinsic methods and, for example, in the golden age of canonical machine learning techniques, as we've been using them in software engineering for decades, interpretability was not an issue, right? Because interpretability was given to us by default, right? If you were using some rule-based methods, you could always get an explanation why the model got to that particular decision, because you could basically look into the logs and see which rules were applied to generate that decision, right? So in our context, obviously, this was not the case as we're dealing with foundational models. So our particular approach to interpretability that I'll be talking about today is actually known as post-hoc method. And we're going to be using, and of course, there are many different post-hoc methods that we could be using here, but we are focusing on causal interpretability, and I'll explain why in just a moment. So what is causal interpretability? This is a post-hoc global approach by which neural code models are interpreted or explained from a causal assumption encoded in a structural causal graph, right? So imagine that we are facing with the question that we want to get a really good answer for. And the question that we're trying to answer is, if I have bugs, let's say you have prompts and your prompts have code, okay? And let's say you have a question whether bugs in the code and the prompts affect accuracy of the code generation by the model. Okay, that's a question that you really want to answer, okay, and you want to get a reliable answer for. So essentially, we again can formulate a structured causal model. In this case, our treatment will be some prompts with code without bugs, and some prompts with code with bugs. Okay, and then we have an outcome which we're going to be measuring using some accuracy metric, aggregated, segregated, to be discussed later. And what we're trying to do here, we're trying to measure this causal effect. Okay, whether indeed the presence of bugs in the prompt impacts accuracy. So again, this is simplified structural causal model because we also have some other things that impact confounders with impact, and we'll discuss it later. But essentially, what we're trying to do here, we're trying to provide software engineering-based causal explanations, right? Whether bugginess in the prompt impacts the accuracy of code model generation. So this is one way to interpret performance of the model at the global level. So here again, we have a bit more complete view of the structural causal model, because here we have also code features, right? And that's important to point out. There are many things that could be impacting this potential relationship, right? So the size of your prompt, the cyclomatic complexity of the code in your prompt, many other things, right? So in fact, you can compute and see how these things actually potentially impact this relationship, right? So our approach essentially consists of multiple inputs. So we take inputs of the model, outputs of the model, some details of the unit part, and interpretive layer basically helps us to get some insights into model performance. And I'll basically talk about different things that we can do with this approach and kind of answers we can answer and what we can achieve with this. So second observation is that causal inference helps us to control for confounding bias by offering an explanation or interpretation to models output. So in this case, the causal explanation will be buggy code in the prompts is negatively affecting models accuracy. Okay, so again, This is just an example, and we will actually get the real answer to this question with data later in the presentation. So essentially what we're trying to do in this work, we're trying to bridge these two areas. And obviously we talked a lot about deep learning for software engineering yesterday, right? But there is this other big area, which is causal inference, which has been used in many other areas of science. And what we're trying to do is really try to bridge these two together, right? And see how effectively we can bring causal inference to help us to interpret what these models actually able to learn from the training data and help explain it back to the developer in terms of the concepts that they understand. Okay? And what I mean by those concepts, I'll explain using examples a bit later. So again, let's just very quickly go through a bit more background here. Again, this is just an example of yet another model. We have a prompt here, and this model is generating code, and all is great. We're using one of these metrics like code blue, accuracy, perplexity, cross entropy, so forth and so on. And this is our canonical evaluation. We are counting perfect predictions, or so we're using Lens's time distance, so forth and so on, right? So we're doing all these things to get this global performance of the model, which is great. But the developer is still asking you this question: is this the snippet that you just generated reliable? Can I use it? And of course, there are many questions which have been raised in the research literature recently. Especially, you might have seen that paper where GitHub Copilot is generating security vulnerabilities, things like that. And I don't know if you noticed that, but there is actually a leak here. So it's actually generating private key, and it should not be generating private key in this particular code. But Code Blue did not notice that, okay? But developer did notice that, and developer is not happy about this generated code. So what is interpretability? Interpretability is a research field that makes machine learning systems and the decision-making process understandable to human beings. And causality, in fact, it was introduced by J.J. Pearl. Basically, it could be boiled down to this definition where T is the cause of Y if Y listens to T, okay? And the causal inference is a process of estimating causal effect from observational data, okay? So again, we have this causal structured graph, right? Which basically tells us the story behind the data that we have, okay? And we are the ones who wrote the story, right? We are the ones who define the treatments. We are the ones who identify the confounders. We are the ones who identify the metrics for measuring the outcomes, right? And we're trying to measure this causal effect between T and Y. It should be pointed out that obviously using just language models, we again, using observational data, we use statistical learning, we're learning these models, and then we end up with observational distributions that we can use for different purposes. What's the main difference between probabilistic inference and causal inference? Here you can see that this is what we've been doing for software engineering for a very long time. This is the process at the bottom, right? So we have some observational data, then we have some statistical learning, then we learn this probability model, which then we can use for probabilistic reasoning, right? And then we have this observational distribution and we're doing that with probabilistic reasoning. So causal inference subsumes all that, but it actually provides a little bit more, because we have here causal learning, right? And then which enables us to do causal reasoning, but we also have interventional distributions because of all the interventions and treatments that we do. So causal inference subsumes probabilistic inference. Again, getting back to our example, developer is finally noticing, right? We have a data leak here, right? Private key is generated because obviously we have it somewhere in the training data, right? And developer is asking the question, why? Okay. So what causal inference can help us in this respect? Well, it can help us to generate queries like that. In this case, we can ask the question, how is the generated code Y related to code concepts or tokens in prompt T? Okay. And in order to do that, we can actually use mathematical language, that comes with causal inference technique, which basically is going to represent this query as a mathematical query. So when it comes to causal inference, there are three ladders of causation according to that problem. The first level, this is what again we're doing in software engineering for decades. This is association, right? We're dealing here with observational distributions, and we're answering which allow us to answer questions with respect to example questions like how is a generated code Y related to code concepts in prompt T? Okay, so these are observational distributions, and these are associations that we're able to capture. In this work, we primarily work at second level. We're dealing here with directional distributions, and we're able to answer questions like, if we remove URLs from the prompt T, will the LLM generate API keys, or in this particular data leakage, right? So here we can formulate interventions, like we can actually start removing things from the prompt and measuring whether it has effect on the outcome. And there is a third level of causation, which is called counterfactuals, and it involves counterfactual distributions, and we can ask even much more advanced questions along the lines: would the LLM generate API keys if URLs had been removed from the training sites? Okay, so the rest of the talk primarily focus on the second level, okay, where we're going to be dealing with interventions and interventional distributions. So in our work, we build this framework, which we call DoCode, which is a causal interpretability method that aims to make deep learning for software engineering systems, in particular, neural code models, and the decision-making process more understandable for developers and practitioners. So again, this is DoCode in the nutshell. So it takes inputs of the model, outputs of the model, and some details of the inner parts, and it provides various causal explanations, okay? By measuring the causal effect between treatments and outcomes in the presence of confound. DoCode pipeline is a fairly involved engineering effort, which at a very high level consists of 4 stages. I'll go into details just into stage 1, and then I'll point you to the paper to look up details for the remaining stages. There is a lot of math involved and from causal theory in all the 4 parts. So what is the first step? The first step is to encode causal assumptions in a graph. And this is our first part, modeling. So you as an analyst are actually responsible to quote unquote write the story behind the data that hopefully you understand very well. And in this case, you can see that we have structural causal model, right? We have our treatments here. And again, I'm using this examples of buggy, non-buggy code in the prompts and how it impacts the accuracy of the generated code. We have some confounders here, like size of the code, size of the snippet, schematic complexity, number of API calls, whatever confounders you have in mind that may potentially be impacting the accuracy of generation process. Obviously, we have some exogenous variables, some noise, which could be impacting pretty much everything in this process. It could be impacting treatments, it could be impacting the confounders. There may be other things which are impacting this relationship that we're not aware of, right? And even outcome, the way we measure, as we already discussed, the accuracy performance can also have an impact on this relationship, right? Different metrics that you can use may have impact on that as well. So when it comes to particular examples, I already showed you one example of the binary treatment, right? This is buggy code versus non-buggy code in the front. But there may literally dozens and dozens of various treatments that you can formulate depending on the task that you're addressing or solving, right? Could be, for example, impact of comments in the prompts, or, and again, this is just another example of binary treatment. Or could be more sophisticated linear treatment, like types of clones, for example, in the prompt, like type 2, type 3, type 4, and the impact on whatever you're trying to measure. Potential outcome, again, these are the metrics that we are using, lowest accuracy token. I would like to point out that Again, we could use using global metrics like cross entropy accuracy, but we could also be using some local metrics if we're interested really to understand the performance of the model for that particular case or for that particular feature. Like in this case, one of the approaches that we've designed based on this framework relies on syntax decomposition for potential outcomes. So basically what you can see here is a prompt and then the code, which was generated for this prompt, right? And then we represent this generated code as an abstract syntax tree, okay? And then here we're showing you probabilities of how, again, these are loggers, but here we're showing you probabilities of how well the model was able to predict that particular syntactic concept in this particular case, okay? So once you aggregate, for example, performance of this model across many prompts, you would get an interesting global view saying that, well, your model is doing very well when dealing with parameters, and it's actually not doing really well when it comes to certain types of identifiers, for example. So you're getting much more pertinent and useful information about your model or what your model was able to learn from the training data. And it's actually actionable, right? Because you can say now I'm actually at training data that includes these particular syntactic features because I do know that my model is not doing that well in that particular respect. So we actually have done a really interesting experiment because when we first started working here, our assumption was, well, why these models are doing so well, right? And our original assumption was, well, these models are doing so well because they quote unquote understand these syntactic structures, right? So they can probably autocomplete the code really well because they have some understanding based on training data, which again may or may not necessarily be the case because in this experiment we actually randomly masked the code and we masked the code based on AST node types, okay? And the outcome here was really, really surprising to us, okay? Basically what we found is, and this was done on Bloomberg, basically we found that these models tend to complete meeting AST maze tokens with acceptable accuracy. However, the reported performance suffers from high variability, making the prediction process less confident as compared to completing randomly masked tokens. Okay, so this was really, really surprising. That the models, we didn't find evidence that they were able to really pick up those syntactic features. And again, you can find more details in our recently published senior paper. So what about confounders? Well, confounders are many, and these are some of the things that we know from empirical software engineering that, in fact, very well things that we're trying to measure. There are dozens of papers with a lot of wisdom in our community, right? Cyclomatic complexity, lines of code, number of variables, number of modifiers, number of returns, try catchers, so forth and so on. So these are all the things that we could be measuring, and we could be capturing in code-related features that can potentially be impacting this relationship that we're trying to measure. So let me show you another cool experiment that we've done with ChatGPT, and here, basically, the treatments are, again, we're trying to answer this canonical prompt engineering question: what kind of prompts you should be writing to generate better code. So in this case, you can see our treatment T0 is basically just short prompt, okay, which does not contain much information, just short description of the code that you want to do. And then we have T1 prompt that includes a little bit more context. Sometimes it's some code, and then we have advanced prompt 2 that includes multiple instructions. It includes not signatures, some code, maybe even some book strings. And obviously, in the context of this experiment, we computed and measured various confounders that could be potentially impacting this relationships, right? So this is the code that we generated, and these are various potential outcomes that we computed aggregated metrics for code blue and Levenstein distance. And as you can see, basically, just based on these metrics, for example, if you're just looking into code blue, right, you don't really see too much difference when you're looking at aggregated metrics. You're like, well, I don't see how this additional information in the prompts actually helps us to generate better code, right? Well, once you start using causal inference process in this case, you actually can see that you get completely different causal effect, right? So here you can see that elemental context description, the prompt, has negative causal effect on the output, right? So this is a T1 as compared to T0. However, prompt with doc strings and signatures, this is our T2 versus T0, has a positive impact on the performance with average treatment effect of almost 3%. Okay, so here you can see that if we're using for computing, if you're using level time distance as a method for the outcome, we do get positive average treatment or causal effect for between T2 and T0, which clearly shows us that more information in the prompt has positive impact on the accuracy of the generated code, which was not the case when we were just using associations and using just one of those aggregate methods. And again, if you're interested in more details, you can find them in our paper. So the next steps behind the framework are a little bit hairy. So they involve formulating causal estimates and expressions. In this case, we again have these observational distributions, and we need to go to interventional distributions. This involves some math behind it, which is known as graph surgery, to obtain these interventional distributions. Next, we are computing causal effect using estimation methods. So again, we need to go from interventional distribution from one sample to average treatment effect across snippets and expected value potential outcome. There are many different ways how we could be estimating these quantities from data, even using machine learning itself. And finally, we need to make sure that the relationship that we established is reliable. Okay, so we have some refutation methods at our disposal, like for example, adding unobserved common cause, like in this case, or adding random common cause of placebo effect, or doing data subset validation to ensure that indeed this causal effect that we're measuring is reliable. So now let me show you some case studies of how we actually applied it in the context of different software engineering tasks to answer different software engineering questions, and how this approach helps us to get better insights into what these models actually generate and why. So again, we evaluated the code in the context of different software engineering tasks like program repair, common generation, or semantic preserving transformations. Even we used it to evaluate some of the internals or configurations of the model where we vary various other parameters. Again, for each of the tasks that you're addressing, you need to define your specific causal structured causal graph, right? Like this would be a causal graph for program repair, right? Where we have our own controls, right? This is for node type masking experiment where we have a steep node masking versus random, for example, masking. And you basically need to define this graph for each problem that you're tackling. So in our experiments, again, we run it across different tasks, across different models. This is actually one interesting answer that I promised you at the beginning of the presentation. To what extent the prediction performance of a given neural code model is affected by the presence of bugs in the prompt, right? So if we compute associations, again, across all these different three different types of models, RNNs, GRUs, and GPT-4s, you can see that we actually obtain pretty significant correlations. So according to this association-based analysis, we're going to say, well, yeah, it looks like in this data that we're analyzing, bugs in the prompts do impact the accuracy of the generated code. Okay? However, when we actually do causal interventions, we actually see that this is not necessarily the case, right? This clearly shows us that causation is not correlation, because in this case, average treatment effect is actually pretty negative, fairly low. Okay? So in this experiment, we confidently answered the question that the presence or absence of buggy code does not seem to appear to causally influence or explain, right, the prediction performance of our neural code models, even under measured high correlation. Okay, so this is actually a really valuable and insightful finding. Okay? This is yet another experiment which I already mentioned in the past. This is an experiment that involved random masking versus AST-based masking. Again, here you see a little bit more details behind the structural causal model that we used for this experiment. And again, these are some of the confounders that we measured to study the impact while computing this average treatment effect between binary treatments and outcomes. And here, interesting results are is not just the fact that AST-based masking did not do much better than random-based masking. It's also when we drill down into the results into different types of AST nodes, we got exactly the same explanation. So we couldn't even find different types of AST nodes where the model did much significantly better than random. So when we drill down into the results, we got second level confirmation that indeed it doesn't seem to be the case that the models that we studied in this experiment were actually learning syntactic features from the code, which was again very, very surprising. Of course, this is just one type of explanation that I showed, but there is this global, really important question that we're trying to understand these days, or what kind of explanations we need to be producing, right, in the context of these foundational models used in software engineering tasks, right? And on one hand, we have this complex model, and on the other hand, we have this user, right? So from the user point of view, obviously, what users want in this explanation, right? They want an understandable explanation, right? They want to look into this explanation, understand why the model generated this particular code, that generated this particular recommendation. Also, from the user point of view, it's important how this is presented to the user. I remember we talked with Prem Dixie this year, and we really think that there is this last mile effort in terms of how to present these recommendations, confidences, support, and so what is a proper HCI component element that involves this last mile effort to make it really useful for users. But at the same time, from the model point of view, what is important, right? It's important that these recommendations are faithful or aligned, right? And when the model shows the explanation, it really aligns with internals. So it's not just lying you why it's generated this recommendation, but indeed it reflects what the inference process, right? And details from the inference process are somehow reflected in the explanation, so that the developer user can say, yeah, I understand why this recommendation is made. Maybe it's not perfect, but I understand. The model is giving me some insights of its internals or some intermediate level that I understand, or concepts using this intermediate level. Like, for example, if the model, in our case, is giving us explanations in terms of underlying AST concepts, we as developers understand, right? I understand what loops mean. I understand what identifiers or parameters mean, and I understand why this model is generating this explanation in terms of these concepts that I, as a developer, understand, right? Again, this is where our approach lies. But I just want to point out that there are many other ways how you can try to explain the results of this model. So I just want to clearly provide sort of a map that there are other complementary efforts that are happening in this field, which could be explored or even combined with the approach that we're working on right now. So again, another point which I wanted to highlight, which is important, is global explanations versus local explanations. And I drilled down on this issue quite a bit in this presentation. I think that local explanations are really important, right? To show on case-by-case basis to developers why this particular code was generated, or potentially help to detect the biases, right? Or help vet individual samples, right? Or provide some guidelines on how to fine-tune the model based on the local performance in the model, those different features that we care about, right? Obviously, global explanations are still important. We still need to get understanding of the overall performance of the model. Again, we need to detect these biases at higher level, and also we need to vet the model for the deployments. So this is basically some of the ongoing work where we're trying to generate these AST-based explanations. And the idea basically here is we pick this intermediate level because we are confident that this is the level of abstraction that developers understand really well, right? And at the same time, we're trying to, like you see in this example, we're trying to explain performance of the model given these AST-based concepts, right? And this is, you can see here a local explanation of why the model is generating this particular code snippet in terms of these AST concepts, but you can do really cool things at global level as well, right? So you can actually aggregate the data across snippets, and then you can say, now let me compare GPT-3, CodeGen-ML, multi-lang, and monolang across all these different AST concepts, right? And now you can clearly see that, well, multi-lang or monolang are doing much better in terms of scope, are doing much better in terms of operators, but at the same time, they're not doing as well as GPT-3 and CodeGen in terms of auto-completing iterative concepts. Okay, so you're getting much more refined, much in-depth view on the performance of the model across AST-based concepts that we as developers have pretty good understanding and grasp of, right? And this information is actually actionable, right? Because now we can do something about it. We can fine-tune or add some training data, or if talking about those superior vulnerabilities, we can potentially go back to the training data and identify those training instances that needs to be removed from the training data that we already in generating that particular project. Do we stop here? Obviously, no. We do believe that the holy grail answer to this question is going to be somewhere above AST-based concepts. So we need to push the boundary to the level which is closer to the level much closer to the user. Currently, we are working on the approach which is we brand this code rationals, and here essentially we're trying to explain, like in this case, we're trying to explain why this particular leakage was generated, or we're trying to answer a more specific question: which particular tokens or concepts in the prompt were responsible for generating this particular data leak in the generated code. Okay, so this you can think about this as raising level of abstraction from AST-based level to concept-based level, like in this case. And again, we believe this is going to be highly actionable for tasks like debugging and testing once we get tools like this, because once we understand particular concepts like URLs or other rational, which is responsible, this could actually help us to address some of the shortcomings of the model. Again, there are many things that we need to keep in mind while using our approach, in particular causal inference, in the context of interpreting these neural code models. When we use it in the context of different programming languages, we need to construct different syntax clustering functions. For example, what works on Java or Python, we actually need to readapt that for example, functional programming languages, and so some significant engineering effort may actually be involved. Defining structural causal model, this is the manual effort that the analyst needs to do. Connecting structural causal models with test beds, estimating and interpreting causal effects, and checking for robustness with verification. This is something that you need to do to make sure that your conclusions are reliable. Okay. Of course, there are more challenges applying this in practice, proposing new syntax clustering criterion, using causal discovery, using this for causal discovery and validity. In fact, this is one of the points which I discussed with researchers from Google. They're really interested in using this type of analysis for not just telling you which confounders you should be embedding and encoding in your structured causal graph, but actually discovering some of the new things that may be impacting this relationship. Integrating the code into this life cycle, and we talked a lot about life cycle using foundational models yesterday. That is going to dramatically change the way we develop software 2.0, software 3.0, right? So embedding these techniques in life cycle is, Steve also requires of that. And obviously collecting data for formulating software engineering-based interventions. Again, what I wanted to leave you with is a couple of thoughts And one thought is, in my opinion, self-transformation is not only natural on a sequence, but also it exhibits causal properties. So Graham here to tell you everything about naturalness. You define this term. He's a father of this. What I'm trying to tell you, there is more than just naturalness which is happening. There are some causal properties that we can take advantage to actually better understand what these models do and why they behave in the way they behave. And that can be actually very helpful to push the input for debugging and testing these models. And I believe that this intersection between causal inference and deep learning for self-machining is beyond interpretability. So it's not just useful for interpretability. I really believe it could open quote new science. Again, remember what I said at the beginning, I said that we moved from this golden age of manual feature engineering to the science of automated feature discovery. Now, in this new age of science of automated feature discovery, we need actually science to that must be employed to enhance this software data analysis, to reduce confounding bias, and increase causal discovery to elaborate explanations. So again, I would like to acknowledge the National Science Foundation who funded this research. Obviously, this is an effort which involved many of my current and former PhD and even undergraduate students. Again, this took a lot of time. So the research that I presented today took roughly 3-4 years to mature. So this was not a quick run and done project. We spent a lot of time. Some of the techniques and tools which I presented here, they don't even exist in machine learning, by the way. So we actually had to redo from scratch and specialize it for software engineering context. And I'm more than happy to answer any questions that you might have. Thank you very much for your attention.
Right, so let's open the floor to questions. I see my first hand was there. I think we have time for maybe 3 questions.
Thank you for a great talk. I hope I agree that it is very important to study those elements in your probabilities, to understand their strengths, right? So this makes me think about the traditional probabilities, right? In the literature, so we have both white box and black box analysis programs, right? For example, white box is for execution programs, or black box with automated testing, and so on and so forth, right? We're curious. So, what kind of new opportunities can be added here for understanding models? If we open the black box, say if it takes into account the model architecture, the training pipeline, right, it's actually better. So what kind of opportunities are there? We're curious.
So thank you for the really good question. So first of all, let me position where this approach belongs in terms of white box, black box. So it's kind of a little bit towards black box, right? Because we are having inputs, we're observing some outputs, and yes, we have some details of the internals, but we're not like measuring coverage or expectations or things like that. And I think that's a great opportunity right there, because just a couple of months ago, we had a discussion at Shonan with some of the participants on what else can really provide you assurance whether, for example, a model really understands certain concepts, right? Because here you can measure causal effect, right? But you have no understanding what's happening really inside the model when it's making those decisions. And so one idea that we actually have could be to combine with some of the existing approaches, which are primarily used for testing, right? Which measure neuron coverage or path activation. So one suggestion to the big opportunity could be actually augment these types of interpretability approaches with actually some activation or heat activation functions that you define, just to make sure, for example, if the model is generating this particular concept, right? Remember that I said we want to use rationals to see which particular concepts are responsible for the code generated here. If you could actually measure, for example, using our approach, if you could say, well, these particular keywords or concepts are responsible for this code. If you slightly change it, and then you look into the model internals, do you see the same activation patterns? Can you actually confirm that I think this is the concept, I think it's responsible, and the pattern of activation is very similar. If you do some very small mutation-based adjustments So there is a lot of opportunity, which I see immediately by drilling down into internals and providing some additional feedback or confirmations or assurance, right? That things that we observe in black box fashion also confirm at low level very clear. That's very interesting. Thanks so much.
Have time for one more question. I think we had a question was there that I don't remember secondly.
It was really nice to see this local art versus global art, like the open concept level. So I'm just wondering, have you thought of some other layers because of this auto creation progress where each token is a probability, even though the probability is high, there's some less values like less values of probability there. So that's a token. It's not one token. It's many tokens, but as well each sequence. Because of the beam search, you actually not only one beam, but multiple beams. As well, in the conversation level, you set different temperatures every time you beam. So there's a lot of layers in between that actually make the dimension really high.
Yes.
So I think this cultural analysis is nice, but there's many layers in between that hidden. I think that's very hard to solve.
Yes, you're absolutely right. I mean, with the AST level, it's kind of easier, quote unquote easier, because the number of AST concepts is fixed, right? When we move to keyword, it's also not that difficult, right? Because we kept keywords and probabilities. The big challenge really starts when we say, let's move to the concept level, where concept level is just distributions of probabilities of tokens, right? And we say, so it's like if you ever used latent shot application LD8, right? We have these probabilistic mixtures of topics, right? So which will represent certain topics or concepts, right? And this is the level where things become different, right? Because you could have more general concepts, more specialized concepts, various probabilities, and figuring out how to properly navigate in this space is going to be very challenging. But in my opinion, this is going to be the most useful outcome if we manage to do this properly, right? Because you're going to be as close as possible to software developer, to the thinking process of software developer, to explain them what is model generating what. But I agree with you, this is the most challenging slice of work.
All right, let's thank our speaker one last time. And if you have any more questions, ask during the break if you have any more questions. Right now, before we'll just do the poster award ceremony. So if I could have the poster co-chairs come to the front, and the sponsor is Dr. Erickson. And if we have a representative from ENC, I'm not sure if I didn't see this board. Otherwise, we can avoid it. Where would you read it?
Yeah, first, a thank you for all the posters. They were fantastic yesterday. I really enjoyed walking around and seeing everybody involved in such discussion and talking with each other and meeting each other. I mean, that's the purpose of these events, is to get to know everybody.
So we have, as we mentioned yesterday, we have 3 prizes. So we start from 3rd place, and we have also the platinum prize, which is agreed on also among the referees. So we'll start with the 3rd prize. The 3rd prize goes to exploring the boundaries of large language models in refactoring, and the presenter is Erin Mazloum Zadeh.
Congratulations.
Bravo, Fred.
Okay, so the second prize. Okay. Seconds, please. That was flat. Okay, that was the flat. Oh, so that was 3rd place. Yeah, okay. So 2nd place. So quickly. Okay, so the second prize. So the second prize goes toward refining table queries using LLMs, base name entities recognition, and this goes to Booyah Fadlullah Zadeh.
This award is sponsored by DNC.
Yes. So first prize by voting goes to evaluating the impact of flake simulators on testing autonomous driving systems. And this is for Mohammed Amini. Sponsored by. Well, the final prize goes to the premium level, which is also agreed on by the referees, which goes to an exploratory study on the operation and smells of foundational models leaderboards, and this is for goes to the Zamani Zaho. Zaho, right? Yeah, correct. So I think for the next time, we encourage everyone to submit for the next SEMLA for the poster session. We will have also hopefully more prizes and more opportunities.
Yeah, and just to say that there's actually a cash prize with each of the awards, so we will communicate with the winners to the amount and to send that.
Yeah.
Anyone vote for one vote?
Yes.
Yeah, okay. Very good. Okay, thank you so much. Some poster yesterday was pretty crazy, but I think the whole from the whole topic we saw yesterday, right? We have one component that is in the shadow, what we call the sustainability of the border with the plot, right? I think this is something I would like to ask the student or the expert here to keep an eye on this type of activity, where we're struggling with energy we spend, the carbon footprint, and also the acceptance, because our project needs to be accepted by the whole world. Right? When we say sustainability, it's 3 dimensions: acceptance, the reduction of the carbon, and also the beauty of the work we're doing. These 3 parameters need to be taken into account. And I encourage the student, the expert here, to start looking at this direction. As you know, 5G, 6G is going to be operated by AI and it's consuming a lot of energy. Yes, I think Professor is here to acknowledge.
Yeah.
We need to do something to knock down this amount of carbon emission based on AI and what you're doing. Thank you so much.
Thank you. This is also encouraging, I think, for the students who are pursuing research on these endeavors like that. This is something that can be applied. So please continue your work, the good work, and yeah, to show your cases. Thank you.
Thanks.
All right, I'd like to invite Prem Devandu to the stage to present. I think just plug in. So while Prem is setting up, I'll introduce him. So he's an ACM fellow. He's also a distinguished professor and of computer science at UC Davis. He joined UC Davis after a career in industrial R&D at Bell Labs in New Jersey. So he's not just an academic at heart, but he also has industrial experience behind him. He's worked in several areas, including software tools, secure data outsourcing, empirical software engineering, and of course, the naturalness of software. 5 of his papers have won the Test of Time or 10-year most influential paper awards, which is a big deal in our field. And he also won the ACM SIGSOFT Outstanding Research Award in 2021 for profoundly changing the way researchers think about software by exploring connections between source code and natural language, which I think is very pertinent to today's world. So thank you, Prem,
Okay.
and take it away.
Thank you very much for this invitation, and thank you for coming to the talk. Okay, so naturalist by now is old hat, so I'm not going to talk too much about that. But I'm going to talk about some other stuff we've been doing since then. So I want to begin. Oh, am I audible
way
even higher? Okay.
Like I have it here and it's very.
Oh, okay. So am I audible? Is it okay?
Some turn on? It's on. It should be on. The green lights are, right?
So it's still not
Yeah,
working.
the guy had a problem with that. Sorry. They're weak mics.
Okay, can you hear me now? Is that better? No? Yeah, that's probably as good. It looks like it's on, the light is on.
It is on.
Yeah. So life is horrible. So you still can't hear me, eh? So maybe I just shout, just if I'm.
Let's see if this one's any better. Maybe the battery.
Oh, yeah, this one's working. Okay, that looks like it's working. Yeah, great. Okay. So yes, why is life horrible? Okay. So so I'm an old guy. I'm 70 next year. So every day I wake up and there's 5 new models. Okay, 5 new papers I have to read. Everybody tells me you have to read these papers, right? And there's another new task. Somebody comes up with another new task that you can do with language models, relating to software. Outside of that, I don't really care. And there's 10 fancy new prompts. Somebody comes up with like another new prompt that you really have to use, because without this prompt, things are so much worse. There's dozens of new startups. People are telling me about how this one's going to change everything, and programming can be completely different, and so on. And then we have distinguished scholars. I named something like Ahmed Hassan, something like that. This guy's saying code is dead. So so this is bad, right? So so I'm looking at all this and I'm thinking to myself, what can we tell students? Are there any topics you can start working on now when you start your thesis? And 5 years from now, when you finish your thesis, it is still relevant? Is there anything like this, from no one? Okay, so, all right, okay, obviously this is all, setting up for my talk. So what I'm hoping to convince you in this talk is that this idea of bimodality, when it comes to applying large language models to code, is actually shelf-stable. So I've had several students working on this for several years now, and this seems like an idea that, kind of endures through several generations of models. So that's what I'm going to try to convince you in this talk. Okay, so what is bimodality? So the idea is that programming actually is intended, when you write a program, you're writing it for 2 audiences, right? Of course, the top part, the most important audience in some sense is the computer. So you write code, and essentially this code is communicating with the computer. And the computer gets some meaning out of your code that you write. And the way the computer gets the meaning is formally defined. It's precise in most cases. And it's when you write a program and you run it on different computers, it always means the same thing, right? So this is what we call the formal channel, right? Now, for software engineers, it's maybe perhaps even more important that your program is read by a human being. There's some other human being who is reading your code, and they get some meaning out of it. And this is what we call the natural channel, right? And they get meaning out of your code using different things than what a computer uses. So for example, for human being, things like identifier names, comments, and coding styles are really important in the way they understand your code. And every human being may read your code in slightly different ways, and this is not really a deterministic process. In fact, it's actually a statistical process. What the human being has in their mind is really a conditional distribution of this form. So they have some kind of like distribution over possible meanings their code may have, because they're not doing operational semantics, they're not doing symbolic evaluation. They're sort of intuiting the meaning of your code because you're reading it quickly and trying to understand it. And so really they're doing this kind of argmax computation over some distribution they have in their minds of what the code means. Okay, so I'm going to spend a few minutes sort of diving into this a little more detail because this part of this sort of view of the natural channel has really been quite influential in a whole set of dimensions in our work. And then I'll come back to start talking about bimodality. Okay, so this human-to-human channel where people sort of guess the meaning of the code is actually noisy, right? It's a noisy channel in the von Neumann sense. So what does this mean, right? So the idea is that, you know, if you do this, you can sort of write it in a sort of normal noisy channel Bayesian style, right? And then you can say, okay, you know, this is how you should interpret this argmax process. And then, you know, given some code that a human being is reading, you can sort of ignore the denominator and you get something like this. So, you know, there's some meaning, there's some prior over the meanings of the human being is reading, right? They're looking at some code and they have some prior over what this code might mean. You know, often this prior, as we'll see in a minute, depends on the context. And then given this prior, they're going to sort of do an argmax over how this code could be written. And I'll get more into this in a minute. But this prior, just focusing on this prior for a minute, this prior usually depends on the context, right? So there's some, I'm reading banking code, I'm reading, you know, a navigation code, I'm reading some scientific computation code. So given the context of the code I'm reading, I have some prior over the distributions of possible meanings. And then I go through the second step, which we'll get into more in detail. So there's a paper on this that you're welcome to look at. There's some other interesting papers I'll get to in a minute. But so basically this process, this defines a kind of process of code reading that I think is quite interesting. We have a couple of papers in Cognitive Science Journal. Again, I'll tell you a little bit more about them in a minute. But the basic idea is that when a programmer reads code, they're guessing the meaning. They're not really doing operational semantics. Nobody does, right? And so how does that process work? So if I'm looking at code on scientific computation, based on the meaning of the method name or the comments that they put in there, I'm going to guess some possible meaning that the code might have. And then what I'm going to do is, this is the crucial part. I'm going to say, assuming this code was written by somebody who isn't a perverse, statistic, crazy person, right? What kind of elements would I expect to see in the code? So I look for those elements. Okay, I'm not going to look at everything in detail. I'm just going to look for certain loop structures, if conditions, whatever. And if I see them, I'm going to say, okay, I got this, what this is doing, right? I'm not going to execute all the details. I'm going to say, yeah, this looks reasonable, right? This is probably what it is. And then I'm done, right? Now, if those bits don't exist, right, then I might say to myself, well, what other way might a reasonable person implement this code? And I guess some other possible ways, maybe a different algorithm. And I go back and see if that lines up with the code. If it does, okay, I got it. If not, well, you know, okay, so maybe I guessed this wrong, right? And I go back and iterate this process. So what this suggests is, if a person writes the code the most reasonable way possible, then it's going to be quickly understood, right? So if you write it some other way, it's going to take longer to understand it. Okay, so right, so this idea, you know, we've been having a lot of fun with this. It turns out this is not a new idea, right? So this actually idea that comes up in a different context in natural language. It's called the rational speech act theory hypothesis. And the idea is that people want to make themselves understood, and they kind of have a good mental model of what their interlocutor is thinking and how they would understand natural language. So they construct the language in ways that would facilitate his understanding. You know, look, English is my second language. I have an accent. For some of you, it might be the same. So I'm sort of constructing my sentences in a way that I have learned over the 60 plus years of my life to make myself understood better in a language which is not my native language, right? So same thing with code, right? So this is kind of an interesting idea that comes out of natural language, but we found that it applies to code, right? So we've done some human subject studies, and we've sort of basically shown that programmers write expressions in a predictable way. So And this was done in collaboration with my colleague Emily Morgan at UC Davis, who's a psycholinguist. So we use basically psycholinguistic methods to show this to be the case, using both human subject studies and corpora of code. So that's all I'm going to say about naturalness. This is interesting that when we wrote the naturalness paper, we didn't really know why we were seeing this, but in retrospect, there's good psycholinguistics reasons for why code is natural. So that's all I'm going to say about naturalness. So let's go back to bimodality. Right. So what we saw in the previous introduction to this idea is that there's basically these two channels: this formal channel that enables algorithms, and this natural channel that enables probabilistic modeling. And what has happened over the last 10 years or so is this probabilistic modeling has gotten really, really good, right? It seems to keep getting better all the time, right? Better ways of training, better modeling techniques, and so on. All right. So what's interesting about this? All right. So the interesting thing is the synergy, right? So because code is formal and enables these algorithms, right? There are different kinds of things that become possible. What I should have briefly touched on, but I'm not going to get into, is these bimodal studies of program comprehension that we did with our colleague Emily Morgan. But the things I'm going to talk about are sort of an argument, a historical argument of how this idea has been stable over several generations of models, even though they keep getting bigger and more powerful, right? The first thing we did was bimodal on-task training with the first generation of transformer models. The second thing we did is bimodal pre-training with the second generation of transformer models. That is things like BERT, right? So where pre-training and which are pre-trained and fine-tuned. And we sort of found that bimodal pre-training actually works quite well. And then the more recent thing we did, which was an ICSI this year, was the latest generation of models, which enables in-context learning. It doesn't require pre-training for different tasks. We can just do it with in-context learning. And how we showed how bimodality is relevant even in this new generation of very large models that allow in-context learning. Okay. So, and there's also ongoing work, at the moment, our work is really deeply engaged with the fact that these large language models are imperfect. And what is worse than being imperfect is that when they're imperfect in lovely ways, which make it harder for you to figure out why they're wrong, right? So they sort of make mistakes in lovely ways that are hard for humans to see, right? So we're sort of engaged with that idea, and again, we're finding that bimodality is quite relevant. So that work is still ongoing and not yet published. Okay, so let me start with how this training has evolved, right? So you had this on-task training where we gather input of prepares and train. For each specific task, we train a new model separately from scratch, starting with random weights. And then there's pre-training plus fine-tuning, where you train a larger model on a self-supervised task. Because the models were getting larger, they couldn't really fine-tune. They couldn't really train them on task because there's just not enough data to train them on task. So they do a self-supervised training on a simple task, and then you can fine-tune it with using input output pairs on a specific task for which you don't have enough data. So it's a way of leveraging the larger size of the model but limited amounts of data by pre-training on a self-supervised task. And then, of course, with the modern models, you train a very large model on everything humans have written, and then just a few input-output pairs in context, the models can perform quite well, right? So, and as you all know, this is essentially reflected in increasing model sizes from 1 million to hundreds of millions to 1 trillion right now. Okay, so right, so basically, this task goes into 3 separate phases of how bimodality was used. And I'm going to start with on-task training using linear parsing. Okay, so we did 2 different things using bimodality. One was binary reverse engineering, and the other was linear parsing. So I'm really only going to talk about the linear parsing part. So what do I mean by linear parsing? Okay, so here you have some essentially crappy code, right? So there's some dot over there, and then there's mismatched parentheses and some improper syntactic construction. And what we'd really like to do is to take this sort of badly written code and parse it into a proper ASD with type annotations, right? Okay, so that's what you'd like to do. And why would you want to do this? Well, mainly in sort of educational settings, right? So where students are writing code and they might make mistakes. I'm sure a lot of you in the teaching professions have noticed that this kind of syntax errors are very frustrating to beginners. And so you'd like to not have to make makes beginners suffer through this. It sort of is really discouraging to deal with this. And of course, also in places like Stack Overflow, where you're copy pasting code, you find a lot of incomplete and code that's not entirely proper. Import statements might be missing, but you'd still like to be able to parse and type it. Okay, so right. Okay, so where does bimodality come in? Well, what is interesting is that you can generate lots and lots of data from GitHub in terms of input, where input is correct source code and the output is ASC with types. And you can do this because of the formal channel, right? You can do lots of this. You can just take this input source code and proper output ASCs with types and make that as training data for a first generation of models. And then feed it to the sequence-to-sequence transformer-based model, and then you can learn to parse. Okay. Now, this isn't really all that interesting, right? I mean, because, you have a parser already, so why do you need to learn a parser, right? Of course, what you want is you want to basically take this, noise it up, and still parse it, right? So now, as long as you make the noiser look like the kind of mistakes that human beings make, right? You can learn this parser that's actually able to forgive all these errors and still parse it properly, right? So the reason why you can do this is because the code that actually human beings write, even the ones with mistakes, have sort of repeated structures. So for example, people write I equals I plus 1. Nobody writes I equals 1 plus I, right? So even if they forget the plus or forget the semicolon, you kind of know what to expect. Even if they just write I equals I plus, kind of know, yeah, there's one missing there, right? So because people write this code in these predictable ways, that makes the code easier to read, the natural channel is learnable. You can sort of learn to fix most mistakes that people make, right? So, so the presence of this naturalness and formalness brings this synergy where you can sort of create lots of training data and you can actually learn the kinds of things that you need to learn because code is so predictable. Okay. All right. So one problem with transformers, at least in the beginning, was that the transformers have this sort of quadratic property with attentions, right? So the attention doesn't scale with the window very size. So at least the beginning transformers are fairly small, so they could fit in the graphic memory on the cards. And so there was this limited window. So we had to play some engineering games to deal with this. So the idea is that basically you want to fix the code, right? But the bad code might be too big to fit in the window, right? So you have to play some games. So what we did essentially is that we first break the source code, which might be bad, into just the block structure, right? And the block structure might be bad because of missing curly braces or something like that, or missing semicolon. So you just fix that first, right? And once you fix that, you get this repaired nesting structure. And then what you do is you take the repaired nesting structure, put in the bad code, and break it up into bad fragments, which might have errors like missing operators, missing identifiers, missing constants, and so on, right? And then you essentially, fix the fragments. And once you fix the fragments, you merge the fragments using the spans that you previously figured out by fixing the nesting. And then you get the fixed code, right? And this way you can overcome the sort of artificial attention window limitation of the first generation of transformers, and you get pretty good code repair. Right, okay, and this actually performs quite well. So, we use this BlueJ data set that's from the UK, which contains real programming errors made by real students. And we measured it, the accuracy of single token errors. And the top one fix in about 70% of the single token errors is correct. The performance declines with size. So, and this performance, will be better now, of course, because the transformers are getting bigger. So, it actually declines in performance, but, we do get good performance up to about 60% accuracy even in the longest cases. So so this does get better. The performance drops quite a bit if you consider two double errors in two separate tokens, but it does quite well. Okay, so that was the bimodal training example. Now we'll get into bimodal pre-training. All right. So so what's bimodal pre-training? All right. So in pre-training, the idea is you're scaling up the network, so you need a lot more data. You don't have the amount of supervised labeled data, on-task data that you can use with such a large amount of tunable parameters as you get in these bigger models. So you first pre-train them on an unlabeled corpus using a very simple task, and then you fine-tune it on task with using the more limited amount of labeled data you have, right? And the same pre-trained model can be fine-tuned on several different tasks, so you're saving computation and saving energy. So this is like with things like that. So these models are trained in fairly simple ways. You just blank out some tokens and then you train the model to fill in those tokens. And some of these models you can blank out entire sequences and they can fill in these sequences as well. But these are self-supervised tasks, meaning as long as you have a corpus, you can make up as much self-supervised data as you want without any human labeling. So you can undo a lot of this, right? So of course, one thing you can ask is, is this thing actually teaching much, right? So is this actually learning any code in any sort of supervised any kind of sophisticated way? Because basically it's doing some kind of fill in the blanks, and it isn't really learning anything about the meaning of the code, right? So and it's except for some models, it's not really learning that much about code generation. So what we thought of, our idea was, why not learn how to edit, right? So by editing, I mean like what an actual human editor does is to take poorly written code and make it into better written code. Okay, so so this is kind of what an editor does, and this is sort of what most professors get paid to do, is basically edit student writing. We really don't do much else except editing what students write, and to make a pretty good living at it. But it's not as easy as you think, right? So students write this stuff, and what an editor must do is actually pretty complicated. You have to read what is written in the first draft, right? And then you have to understand the concepts behind what was actually written originally. And then having understood these concepts, we have to regenerate the same concepts with an understanding of how the reader is going to understand it. It's where the natural stuff comes in, right? We have to regenerate the same part in a standard, well-written style. So nowadays, because of the use of GitHub, it is possible to get this kind of data. But for code, how to generate this training data at scale, at enormous scales, where you start with like unnatural code and produce natural code, right? So that's kind of what we want to train a model to do. If we can do that, then the model is learning to both understand code, even if the code is unnatural, and is trained and is learning to generate natural code, right? So how do we do that? All right. So we need examples of fairly challenging editorial code task, and we need it at scale in sufficient volumes for pre-training a larger model. So this is the idea we hit on, is that this kind of thing where some text is missing is a fairly simple editing task. So a lot of these modern models like PFI, for example, are trained on this. So this gives some training on code generation, and it learns to reconstruct large sequences in some ways. But it's much simpler work than what actual editors do, right? Actual editors don't deal with this kind of badness. They deal with better badness, right? And so we hit up on this idea of doing code generation for more complex kinds of editing tasks. So the top and the bottom code are both correct. They both do the same thing. But the bottom one is unnatural. It's weird, right? Most people wouldn't write code like this. And if we see this in student code, we might actually tell them to write it differently to make it more readable and more conventional, right? So this is natural, and this is just weird, right? Now, the idea is that from there to here is automated, right? So we can generate code like this at scale. right? There's no problem, right? We can take anything in GitHub and we can apply these kinds of transformations and produce code at scale. And we can essentially teach the model to train the model to rewrite code automatically from this form to this form. So that part, the producing the data, is done using the formal channel at scale. And now we're teaching the model to understand the code and generate the code, and essentially we're teaching the model to naturalize the code. Okay. So the transformations we use to generate this kind of training data is loop transformations, turning for to while, injecting dead code, swapping blocks in if conditions, swapping operands, inserting confusing code like auto increments, renaming variables. And so we can generate lots of code at scale using this kind of transformations, and we teach the model to rewrite back to original. And so that's all pre-training. So by doing this kind of pre-training, we're hoping to make the model better at understanding code and generating natural code. And so we tried a bunch of on-task examples that require kind of code generation, porting code from C# to Java, porting code from Java to C#, generating code from text, and then repairing bugs, right? So, so essentially, what we do see is improvements over baselines, but small improvements. What we do see, however, is sample efficiency. So the model learns more quickly. This is NatGen's our work, and Code 35 is previous pre-training on code generation tasks. So we see essentially our pre-trained model learns much faster to do the same task and achieve higher levels of performance. And this sort of advantage continues for the NatGen approach, which is our approach, but the relative advantage diminishes with more amounts of fine-tuning. So the x-axis is the amount of fine-tuning examples that are provided. So especially in settings where it's costly to come up with labeled examples of fine-tuning, our approach seems to show an advantage. Okay, and so this sample efficiency persists in different tasks like text-to-code generation and also with bug fixing. Okay, so so that was the bimodal pre-training, and finally I wanted to talk about the in-context learning. Right. So in-context learning, is the first popped up about 2 years ago, and it's really weird, but it works. So in standard prompting, you can take these very large models, give it a question, and get an answer, right? And what you can do in terms of in-context learning is to give just a few examples in the prompt, and that's sufficient for the language model to learn what to do. So you can just give 1 or 2 examples of questions and answers. If you give a third example, it knows what to do, and this might be translation, it might be program repair, it might be program generation, it might be refactoring. And most of these things, just a few examples are sufficient to get the model to do what you want. You don't need to fine-tune it. And also, you can also, besides few shot, you can also do chain of thought, where you give a question, some reasoning, and an answer, and you give a few of these. And for the final question, you give it some reasoning and produce an answer. In fact, what is weird is you don't even need to give a reason. For the third question, you give it just a question and it will produce both the reasoning and the answer. So this comes out of the power of these large models, which are trained over basically everything humans have written. The reason why this works is not really well understood, but it seems to be working well. In fact, this works better than this. Just forcing the model to reason makes it perform better. Some people say this is because the quality of text in which you find questions followed by reasons followed by answers corresponds to basically explanatory text written by teachers or explanatory text found in books. And this kind of thing might be found in random places, but this is going to be found in higher quality text. So when you force the model to reasoning, it's actually kind of thinking about or recapitulating text it's seen, which is higher quality text. So the answer quality seems to improve in these cases. Okay, So, the reasoning is pretty simple, right? Without the reasoning, might be you just give question and answer without any intermediate reasoning steps. And maybe in such cases, it produces false answers. But if you intercede with some reasoning, then the answer quality seems to actually improve. Right, okay. So, so this is kind of what we mean by this reasoning step, right? And it seems to work better, right? So naturally, when we saw this, this is from, let's see, this year, we started to wonder, like, how do you come up with reasons for code, right? So, in order to do this kind of approach in coding tasks, you need to provide intermediate reasoning steps. But how do you come up with this kind of intermediate reasoning for coding tasks? One thing to bear in mind is, even though only a few examples are necessary to provide for any given coding task, it's important to provide relevant examples, right? So in order to sort of come up with relevant examples for coding, for program patching, for example, you need to have a larger data set of bugs and repairs, which you can provide to the large language model that are relevant to the question you're asking. Right? So if you're asking to fix a bug on scientific code, you need to provide examples drawn from scientific code, right? If you wanted to provide examples on to repair a bug on financial code or to generate a summary of some code that's in the financial domain, you need to provide examples from the financial domain of code summaries, right? So if you wanted to add reasons to these examples, you have to have reasons at scale. So if you have a pool of hundreds of examples that you're going to do retrieval augmented generation or provide examples for your few sharding, you need to have reasons for all those hundreds of examples. So how do you come up with this sufficient examples with reasons, right? So this gets tricky, right? So our basic idea is that, this idea of chain of thought, where you intercede reasons between the input and the output, you can come up with reasons by using the formal chain, right? So if the language model can, for condition and group-and-like reasoning, for the coding task, we can provide the kind of intermediate reasoning step that a human developer uses automatically for code, right? So how do we do that? It's because we can generate this intermediate reasoning steps using the formal channel, right? So our hypothesis is that for a programming task, when you ask a developer to fix a bug or summarize code or refactor or something like that, they're basically going to look at the particular context where they're in. Maybe they'll look at the GitHub repo context. Maybe they'll look at the kind of identifier names and the comments in the code. Maybe they'll look at data flow properties. Maybe they'll look at control flow properties. And all of these are available using the formal channel because code is analyzable, right? So this is the idea of automatic semantic augmentation of prompts. So as long as you have input-output pairs in your tool that you're going to do, where you're going to look for relevant examples, you can automatically insert this stuff in between the question and the answer using the formal channel, right? So given any question you want to answer, right, you can look in your pool for pairs of questions and answers. You don't need the reasoning, right? You take the input source code, you analyze it, you find some output, you stick it in there, right? And so the idea is by doing this, including for the target query example, because even the target query example you can automatically analyze. By doing this, you can get better answers. So that's the idea, right? So again, sort of like bringing this idea of bimodality into even the age of foundation models, right? Okay, so the automatic reasoning we can add is repo-enforce identifier information plus category and data flow information. So, so this is sort of what it looks like. So we take the source code, we add all this information in color automatically, and then we provide the output. So this is what each of the examples in your few shot look like. The source code and the output come from the data set, right? Whatever data you have, and if you have thousands of examples all automatically gathered, right? You can just insert this automated reasoning automatically into the most relevant examples and stick them in the prompt. Right? Okay, so once you do that, this analysis product can be added automatically. So there's multiple ways in which we derive this automated info. So the repo info just comes from GitHub. The other info, data flow info, and variable names and scopes, we get from TreeSitter, automatically iterated, of course. And then you find the initial 11th source code using DM25. And then, so this is sort of the overall overflow. You first take the input query code of which you want summary or you want code repair. Use VM25 to find relevant information. Use the ASAP tooling to add this relevant information. You feed that all to the generative model, and then you get an output summary or a code repair or whatever you want, right? So what we see is significant improvements on code summarization and code completion. We see improvements for models at different scales for several languages. And in one case, Java and Codex Da-Vinci, we did see much improvement. Interestingly, the repository information helps the most. And one possibility is that the way we were presenting the data flow information and the variable information was somehow not in distribution. That is, when you feed information into the prompt, you have to put it in a way that is similar to the way the models were trained. So it's possible that the way we provided data flow information is not in distribution. So that's some work ongoing, trying to see if we can make it better. The other thing that's important to notice is that there are all kinds of ways to add stuff to the prompt that make it work better. You have to have some baseline, because when you make the prompt longer, the model is doing more work. So, how do you know that your way of adding information is better than just some other way of putting more information? So what we did is we showed that ASAP augmentation is better than just simply using more few-shot examples, right? So it's all in the PPC paper this year. Okay, so that's a summary of our work. So naturalness is great, there's lots of applications of it. But nowadays the field is moving so fast that it's nice to have some stable queries on which you can do some research. So what we found is that bimodularity has been pretty durable. The idea that code is both a formal and a natural channel, and we've been able to use it for several generations of models and training approaches. And the work is still ongoing at the moment, trying to figure out how to deal with generated code quality. And we've also done some psycholinguistic study of human code reading, again, using the bimodal channel. I wanted to thank my sponsors, NSF, the Alexander von Humboldt Foundation, and IARPA in the US. Thank you very much. Happy to take your question.
Microphone.
Thank you so much. So my question is maybe the language specific. So you mentioned Java, Python, and PHP in the evaluation. I was wondering if the readability of the language affects the model evaluation. For example, Python is more readable, probably more understandable. And we see the syntax trees as well. So Java probably has a better syntax tree overview. So I was just wondering, what is your idea or opinion about the differences between the languages?
Yeah, so we have a paper on how language models, previous generation language models, how they worked on different kinds of languages and also on natural language. So it seems to have more to do with the amount of training data available, so than anything else. So languages for which there's lots of training data leads to better performance. So for some of the worst performance we saw was somewhat less frequent languages like Haskell. So that seems to matter more than anything else.
Just side of it.
The amount of data you have to train it, yeah.
Thank you.
Hello. Thank you for the nice talk. So when I was thinking about naturalness, so I teach a programming course, undergrad programming course, and I always ask students to do coding nicely, structurally, follow syntax, first Java. So if we think about naturalness, so you are introducing some kind of natural way, like in body code. So how this kind of tool will actually make students or the developer write batch code? Have you done any user study? Is this a good thing in the long run for the students?
Yeah, so right, so there is some work in Davis. I don't know if they published it yet. Basically, if you take buggy code, right, and the buggy code happens to be written in a more natural style. That is, according to a language model, you can think of two versions of the same buggy code. One version which is lower entropy, has higher probability, another version. The lower entropy version of the buggy code is harder for human beings to diagnose, right? And we've also seen in our work that when you ask a language model with historical data, it's using stubs for J data, right? You take historical data, feed it to the language model, ask it to do code completion. Sometimes it produces the buggy code, sometimes it produces the fixed code. In both cases, the language model is quite confident. So for the language model, the buggy code looks just as natural as the fixed code. And which is kind of worrying. And what is even more worrying is when the language model produced the buggy code, historically, that buggy code tended to stay in the repository for a longer period of time, right? And this is in our MSR 2023 paper. This suggests that currently, when people are using language models, and when the language models produce buggy code, it looks really nice, right? And it's going to stay in the code for a long period of time. So I think this is potentially an issue that we're going to be exposed to more and more, is that when language models produce buggy code, those bugs are going to be long living in the code. And who knows what kind of damage they will do. All remains to be seen.
Yeah, so it is like recently or 2016, bunch of Australian researchers scanned like some scientific papers where they found autocorrection issue in Excel. So like the gene name like septine, like it wrote like sep2, but it is actually meant septine2, but it autocorrected as September 2.
Oh.
So you see that kind of feature can create a lot of bugs.
Yeah.
Same thing could happen here too.
That's right. Yeah. It remains to be seen, how this works out.
Thank you for the talk. My question is, we're talking about going from natural language to natural language, but I was thinking in cases where the code already works, for example, legacy code, but it was written in a design pattern that is has been outdated. If it would not be easier to go to assembly language and then back to natural language in the current design patterns that are favored.
So what you're saying is that, like, if somebody wrote code in a language, say it was written 10 years ago,
yes,
using a design pattern that was popular then, that code might be now compiled into binary.
Yes.
And you're saying rather than try to rewrite the original code or try to complete the original code, wouldn't it be better to reverse engineer the code?
Yes.
Well, if you're using traditional tools and traditional approaches, that's probably quite reasonable. But if you're using language models, they're probably trained and they've seen the source code. They might be trained on code using old design patterns. And since they're trained on them, they would tend to reproduce them.
I see.
Right?
So there's not enough history of the current design patterns in order to replicate better.
Right. So it depends, right? So if the model, so for example, you can perhaps instruction tune models to force them not recapitulate the old design patterns, right? So some of the models are instruction tuned to avoid, for example, biased statements, right? Associating pronouns like he with doctors, for example. You can instruction tune the models to avoid those kinds of things, right? So in a similar way, you might be able to instruction tune models to avoid design patterns or programming styles that are now outdated. But you'd have to explicitly do that. You have to create separate training grounds to tune the models to avoid those things. But if you just train them on the corpus, they're going to reproduce whatever's in the corpus.
We have one last question. Yeah.
Maybe I can just speak very loud.
Sure. Yeah, that works.
So in your last study, you perhaps in the slide just before this one, you showed that repo info helps the most.
Yes.
So I was just curious, like, how did you find that out, and why do you think that is?
So it's just an ablation study. You just add and remove each thing and see how much it helps. The biggest improvement in performance came from adding repo. Yeah, so this is the sort of the part I was commenting on, which it's not clear yet. I think the reason is because the repo info is seen by the model before in training, right? the data flow information and the variable declaration and type information is something we added. And it may not be in distribution for the training data. So the model may not have seen this kind of information when it's being trained. So maybe it doesn't know what to do with it, right? Now the question is, how can we present the training data, the sort of data flow information to the model in a more in distribution way? It's an open question. I'm not really sure. I mean, don't get me wrong. It's not that it doesn't help. It does help. It doesn't help as much as the repo information. So it does, all those pieces help in statistically significant ways. But the help provided by the repo info is the most. And I think it's because the repo information is available to the model during training. In other words, it's in distribution. Whereas the data flow and control flow information and the data type information is not.
Thank you.
Sure.
All right, let's thank our speaker one last time. One more break, and we'll try to come back at the original time. I think we could go get them out of that. I don't think I've done 11:05. We'll do our best.
Like the binaries and just generate code, not interpret code. It's a translating from something which is highly difficult to interpret. Binaries is so basic,
Yeah,
it's easy to just generate properties.
Been using a model or using a traditional tool? Using, I mean, using a language model or using like regression? Which way did you?
Oh, I don't know.
Okay.
I didn't think, but the large language models would not be able to interpret the binaries, is that what you're?
So you can train them to do that.
Yeah,
I mean,
that's what I was.
you know, it's, there is some success in doing that, but not
Like,
as.
where do you put it? Like, so why not binary to?
I'll give them a few minutes. So when do you start working? No. You speak Norwegian? Hi. You in New York as well? Oh, okay. So you know around New York? My wife is from. I was there 3 weeks ago. Oh, really? Wow. Very good. My wife's father works at the University of Oregon. Yeah, so
But the accent there is very,
Yes.
very typical.
yeah, my wife.
Should I have a sharp search?
No. So I'll, if you don't mind, like I'll let you know in 5 minutes before.
Yeah.
But we're pretty flexible.
Okay, I will try not to be too long.
Okay. That'll help if I turn it on.
Welcome back, everyone. So our last speaker before the panel, last but not least, of course, I'm Jørgen Duck. So is a full professor of software engineering in Norway, so at the University of Southeastern Norway and Norwegian University of Science and Technology, joining us all the way from Norway, so thank you very much for that. He has more than 150 peer-reviewed publications in high-ranking journals, conferences, workshops in software engineering fields, including software startups, software security, and AI engineering. And he's currently leading several research initiatives on evaluating the adoption of generative AI for software development and business. So if you'd like to welcome our speaker, and then get into it.
Hi, good morning, everyone, and I'm very honored to be here today to share with you my experience and collaboration, and also my thoughts about future research regarding the generative AI in software engineering. So it's not that many work I will present here. It's done in a collaboration with my colleagues and also my students. So I will firstly present about myself and a little bit about the country. And we start first with the ongoing conversation, what at least from what I have seen that people talking about generative AI in software industry and research. After that, we present our recent research, what we are doing, and I have time, and I will share my thoughts about future prospects. As introduced, I'm a professor in software engineering at Norwegian University of Science and Technology and University of Southeastern Norway. So for you who are not very familiar with the country, so we are neighbor to Sweden and Finland. And NTNU located in Trondheim, in the middle of the country. And we also, it will be also the location for FSE 2025. So yeah, very beautiful city and place to visit. Also very well connected. So in the last 10 years, I had to do a little bit of everything. I'm I've always been a researcher, also a book authors, educators. I have to teach a lot, so yeah, I want to mention here, and also occasionally startup projects. We do research in different topics. Before about human and business aspect in software engineering and educations, and we publish in known software engineering journals, also in expert systems with application and securities. Also publish and serve for different software engineering communities, including FSC, RE. Also have a kind of a smaller scale conference in Europe, Profess and Exopt. So currently, me and my colleague will run a GP lab. We have a few postdoc and PhD students. We also host master thesis. We currently exploring different topics like LLMs and code generations, vulnerability detection and repair, fairness testings, and also we collaborate with industry partners, with small, middle-sized companies to explore the adoption of AI in their context. All right, so generative AI or LLM is all over the place. So we all agree about that. And research in great literatures, and that's a huge amount of text written about the promise and the appeal of generative AI for different domains, different sections. So just to give an example, a report from McKinsey saying that potential increase of productivity between 20 to 45% can be reached in the software industry. Also, if you search for exactly this phrase, LLM is offering a paradigm shift in the way we develop software. Just in Google Scholar, we find like almost 20,000 clicked results. We also hear a lot about this today. So at least many researchers are believing in it and writing about it, right? And from education aspects, it's very important for us to watch very closely what's happening, what's there, and in the state of the art, the research and the industry movement, because it have a direct implications on software engineering education curriculums, about what we teach students, what we teach students, and also the materials. Right. So yeah, I think this is also known to everyone here. Generative AI doesn't come only with the promise, and there's a lot of hero with that. So real world usage of code model has a lot of nuances and expectations. So human eval, so 160 programming problem in a very simple level, right? So it might not be a direct match with what the software developers have to deal with in their daily life, right? And also we know that it's non-deterministic model, is come with hallucinations, often wrong, and no guarantee on trust and security. And a lot of people here today, and also, I mean, speakers talk about quality issues with data models and applications. Not much. I heard about legal issues with the content ownership, but also very important to be efficient. And when we popularize AI models, the view for energy costs will be much higher, and what does that mean for a company, for a community, and for whole nations, right? Okay, but in that context, these are unavoidable trend, and we see that more and more research on LLMs in software engineering research. Right? So research in Google Scholar these simple keywords, and we see that last year it's already like more than 10 times the number of studies we found on LLMs with software development. And the bar has gotten higher than ever when coming to secondary studies. So may I ask if anybody here have done a systematic literature review or a survey paper? You raise your hand. Okay, so it's not many, but also like 10 people. So so here's the list of 7 recent secondary studies we found. And you see, for example, this one, the author have to read and scan and extract information from almost 600 primary studies. Yeah. And I believe that if you want to do a secondary study on LLMs next year or 2 years after, this number will be much more. So, for example, now we try to use AI assist tools to help with the literature review process due to this amount of paper available. Now that this one is the paper we done last year, and we're still under review and a lot of things we do fix, but we have done it completely manual. So it's a comprehensive and powerful literature review, and followed by several rounds of focus groups. And there's 17-20 core authors in the papers actively involved in this process. So we present a research agenda. So you can find the paper in archive. So from 11 research area here, noteworthy that's not only a technical aspect that are highlights here. We also focus on the engineering management, professional competencies, and educational aspects. Also macro aspect when we think of adoption or research on generative AI in software engineering. But just to summarize some of the key directions that we want to bring here, maybe to trigger discussion later. We believe that studies will continue to focus on methods to increase the performance of LLM in various software engineering tasks, both for generic and specific purpose. There also the need to revisit existing principles, theories, roles in software engineering in the lights of LLMs. Propose and evaluate new process, tools, practice to integrate LLMs in a more realistic real-life project context. And also consider LLMs as a software itself, and we also need to understand the quality attributes, measurements, testing, and monitoring these quality attributes. So in this slide, we with the students have started some empirical research on 2 directions. The performance of LLMs and conceptualize and testing and test and monitor quality attributes. And we focus first on AI ethics and fairness testing here. So most of the work is have done since starting from 2022. So some work that have been published, but most of them are undergoing. Okay, so this is some of the study we want to share with you. So this study 1, so it's very interesting. We also have the industry project, and there's a need to somehow support the code generation for TypeScript project. That's the language they use in the project. So we want to understand if there's an efficient and cost-effective training when support code generations and code summarizations. It's a very from a very pragmatic view. In this project, we applied the method like parameters, efficient fine tuning, and specific LoRa, yeah. So this from this reference. So here I just briefly present the steps we have done. So first of all, to select a survey and select a base LM models. So we choose 13 billion parameters total amount. Yeah, due to also this limited based on the resource we can afford. And so in the second step, we apply the row rank fine tuning. So the idea is to retrain much smaller portions of the weight matrix instead of more larger or even the whole network. So we end up with retraining like around 66 million parameters, like less than 0.5%. We combine with instruction fine tuning. So the idea is to build instruction data sets with a pair of instruction and an output, and use that to improve the controllability and performance of the model. So to ask it to relate more things that we want to see. So this is an example of the pair of the instruction, and this is the output supply. The instruction data sets actually be generated using the existing package, the self-instruct and event instruct that we also adopt from other research. The overall architectures look like this. So we extracted 20K pair of instruction data set from stack and applications. And use that as the input for the instruction turning, and we fine tune a view general proposed specified on TypeScript. And so we evaluate the project at 2 levels internally and run it with the monthly human eval pass it by, and we also try to apply it in the real projects. Yeah. So first of all, here we see the model outperform baseline models, and it's a consistent result, and even comparable with the model with the larger size. And at the second level, when we integrate the models, the tool in the project is also giving some very initial promising results. Okay, so second studies in this work, we evaluate self-evolving frameworks also for code generations. So self-evolving in a self-evolving framework, large language models will go through several circles. When it starts with gaining experience from new tasks and generate the solutions, gaining feedback on that, and then it improves itself, and this continue the loop. And in this work, we combine chain of thought patterns and self-evolving framework, and to introduce a new architecture for what we call COT self-evolve for code generations. So here the step one, yeah, so we also very briefly go through this. So step one, we will generate the chain of thought prompts, utilize the external knowledge base. So here we have the code snippet, but we also extract the human discussions on the code snippet from Stack Overflow or other forums. And so the ideas with the COT here is to put it in a more kind of human, to mimic the human reasonings here. So these are appears that we extracted and structured. So for example, so given the problems, and so this the discussion we extract, and this is the list of each suggestion on 3, and we extracted from the forums. Okay, so we use that to generate
the code. So that's step one. A trial of the solution have been generated. So here in the feedback, we can choose either we can choose human feedback on this, or we can have also automated works for the feedback. So in this case, we use the syntax tracker, the static analysis, and also code executor as the feedback source. So in the code executor, we run the unit test. So basically, if the code doesn't pass the unit test, we can generate the error message. But the thing is that with the error message here, it usually contains a lot of things, and the log file is also very complex. So we need another step to clean it and then restructure it in a more also to mimic human reasonings. So we introduce the second COT prompt generator here, and we restructure the COT prompts like this. All right, so this make a loop. So when we generate the code, we send it back again to this step. So the stopping condition now either on the unit test pass or we reach the number of iterations is 5 due to also the limited resource we have. So in this work we evaluate the results with the DS1000 datasets with asset 1, and it's also very promising outcome. So we compare to the existing model, the self-born. So we it's also outperformed the base model for GPT-4. Also do the test with many other data sets and try with the different LLM models. So it's a consistent performance. Yeah. So why evaluating and trying to improving the performance of the model, I think it's important, and that's all of us are doing. But we still think that it's still a gap. It's still a way to go until we can get to the level of expectation from industry, from a real world setting projects. So in our research agendas, we also explore the pragmatic views on generative AI adoptions from developers who actually also using Copilot, using generative AI tools, or from managers, from non-IT people, how they look at generative AI. So these questions maybe it's a bit different, but not about like, how to improve model in this way or that way. But it's actually about how we position generative AI in the existing world, in their daily life. For instance, there's a very common question that raised during our focus groups, how a certain generative AI tools can be integrated into current existing workflow in our companies. And what does that mean to fast-rate development? We make things even faster. It eliminates the way we work now. What needs to be done to achieve a natural language interface for coding for non-IT people? So with the citizens developments, we need to be a game changer things that will have to not only developers but also people without software engineering background can also use and develop software, and how organizations can foster control to promote a symbiotic collaborations between the developer and the generative systems. So there's a lot, there are different levels, different scenarios where we see the overall collaboration here, right? And so on and so forth. So so there's a couple of case studies have been done to in this direction, try to address or try to explore the current state answering these questions at this moment. So this part of the book that we just published. So there's a chapter about evaluating GPT model as a full stack developer. So this happens in a real world project settings. So the company have 10 people and they run they follow a Scrum approach do web developments. And the managers are brave enough to introduce and enforce the use of generative AI in the projects. And this is a description of the workflow they have used. So very quickly, the outcomes. So they find a significant impact of the prompt quality, and they find the heavily use of AI assist coding practice in the beginning of the project, but less and less visible in the later phase. They also report challenge like limited contextual memory. Not all the context information can be reflect or can be memorized to provide relevant outputs. Overly broad response, was non-deterministic behavior. So we have another chapter also published where we conduct a survey with the Ethiopian project managers, and all of them are doing some kind of agile software project management. And we look at we use the value-based theory when we look at the adoption intention. So the idea is that with this theory, it says they only adopt things if they see the gain benefits larger than the sacrifice. So also in this line of work, we interested in looking at non-IT people and how they see the adoption of the generative AI. So it's quite the results also quite interesting. So there's a need to evaluate the value creation and utility. So that's probably agreed by at least at the manager level in our samples. And the current adoption is quite focused on low-hanging fruits, which is simple enough and easy to see, straightforward. I think that's adopted the most by these sets. Writing email, helping with documents, and some stuff with the project plannings. But on the more giving more value, but it's more complex things to do that is in the lower in the list. They also raise a concern with issue like accountability. So if something wrong with the project, the decision they have made based on the AI generated recommendations. So who will take charge? And private concerns. So this is some of the insights that we extracted to present. Also in this slide, we try to also understand how the current generic proposed LLM models can be used at ease. And we try to build a virtual assistant for the software startup companies that's in our network. So the student they build 3 different chatbots here, and they actually do the user testing with the real companies. So we adopt design science, and they go through 3 loops. So the work been conducted in over a year. So the step 1, we try to use a different form patterns. We try to improve the effectiveness, try to improve the relevances of the model's outputs. And in the second circle, we try with zero shot learnings, and the idea is that we try what if we embed the theoretical, the knowledge we have from the information system from entrepreneurship. And thus we believe that the theory is the is the best practice, right? So we also try to fit it in the model and try to see if the model can be more helpful for the people. And last but not least, we try with graph. So we view the vector database here and we put with the similar cases due to our previous research. We have 50 cases and we included here. So yeah, we went through 3 rounds of user testings. Each round we have like between 10 to 26 user tests. And we use the criteria reliability, satisfaction, effectiveness, and efficiency. So although people rank quite a good level with reliability, but in general, the perceived effectiveness and satisfaction is not very high, and especially it's disappointed that we did not get a noticeable improvement when using graph. So also there are some insights from this. So the response about too general and not tailored enough to the fit of the specific companies. Some responses are too complex to the question asked. And they would like to hear some personalized and mental-like tones with more kind of human-like and critical mindsets when it comes to assistant job. And also a question about the relevance and designness of the knowledge base that we use for building the knowledge base. Okay, so I will end my talk with this my personal views after doing the review and also supervise students and interact and talk to people from companies. So I think it's important to still focus on the quality is too important. So I have doubled it that we should focus on the quality of data. Is essential to the development of LLM transport, effective and responsible. Sustainability, energy efficient, I think is very important, and it should be more and more important in the future. So we focus on sustainable and efficient way to adopt LLMs for software engineering tasks. And this can be looked at a different level. We also see a paper that talked about supply chain or ecosystems where the usage of the development, deployment, and the usage of the LLM models can be seen beyond the boundaries of a single company or single organizations. So explore, design, balance the interface, the LLM human collaborations, and we're talking about specific domains or environments. Evaluate and benchmark different tools. Co-pilots, but there are also more and more tools to appear this year and even more next year. So when a new tool comes in, it's important for us to evaluate the productivity and the effectiveness when we actually use it in the industry setting. And last but not least, we still need to see large language model as a software and even as a large-scale software systems, and all the process techniques and practice for software development should also be visited and be evaluated for the development of LLMs. Yeah, so yeah, thank you for listening.
All right, do we have any questions for our speaker? One question at the back there.
Thank you. Thank you for
At the back.
Thank you for the lecture, Masood from LLC. So I'm just wondering, so according to your findings, developer use the language model at the beginning, then their use decrease at the later stage. So what could be the reason? So does it mean that it was useful for project level planning, before estimation, those kind of stuff, or then when in the Scrum, basically you have to do iterative development, so that means you have to understand the code and you have to modify the code. That is something that language model is very good for, especially for the non-technical stuff. But when it comes to understand the existing code base and making code level changes, then it would not be that useful.
Yes, thank you, very good questions. At least for the project, we have seen the learning curve attached with the project. So in the beginning, they learn about the requirement, but also they have many to learn with the technologies of the programming language. So LLM has been used also for the learning process. Idea generations and try different simple level codes. But when we get to the later phase and the project has built up and there are more complexity, more dependencies between the modules, and I think they found it's less effective to use LLM as the way they use in the early stage to generate the code they want. And that's due to the expectation on the quality of the code and and also the size of the code base. That's the reasons why it has been less and less used. Also, a later phase project associate with more pressures on a deadline, so that give them less preference on trying things, but actually focus on writing things at the most comfort level.
Yeah. So the second question is, do you need to really modify the workflow of the developers to address this challenge, or the element can be embedded in the existing workflow that's still this?
I think this is a very, very interesting questions, and I don't think we have the answer to this, or at least from what we have seen and what we read. So people propose different scenarios, so in the beginning, like AI in the loop, where the AI take a small portion in the life cycle, and to get to more towards like human in the loop, where the AI is actually we have a lot of automations, AI as a main role, and humans intervention happen somewhere, sometimes in this process. But I think that's for what we have seen so far for small, mid-sized European companies, and they're just been considered using generative AI tools as a tool, it's co-pilot, right, or plug into IDEs, right? So that just to improve the individual level productivity, right? But there also a lot, I mean, talked to a lot of managers, and they have a wait and see approach. We haven't seen, I mean, things that, I mean, trigger them yet or convincing yet for them to leverage the usage of generative AI to the next level.
Thank you. Do we have another here? Last question?
Yeah, I just thanks for the talk.
Okay, so now we talk here. Have you seen maybe a compound factor that would be the trust to using a lot of tools, right? So maybe developers are very open in the beginning, so they use a lot of tools, but as they're using, mistakes happen, they don't trust as much, they start to kind of motivate for themselves. Have you noticed anything on those surface?
Yeah, so yeah, definitely trust is on a very important factors. We found it as a subtheme under the perceived usefulness. So things useful, they assume they are reliable as well. So we adopt the very traditional models like technological acceptance model. So consider LLM as a new technology. So that they go through the same way to evaluate the value they gain before they fully adopt the model.
Let's thank our speaker. Sorry, we have to. Un will be here during the lunch, so feel free to ask more questions during the lunch. I'm sure he'll be happy to speak with you. We have to move on to the panel moderation, so you can stay. Because you're on the panel. We're just gonna get this.
Hello?
Yeah.
Good. So we are starting the panel about generative AI and foundation models for software engineering. We have a chance to have a really bright group of panelists. So Prem Devanbu, Denis Kochevenik, Anne Nguyen Dun, and Xinhui Tan. Sorry for the pronunciation. I asked the GPT to help me with the pronunciation, and he gave me like pronunciation by example with some sounds, and finally I just go, let's try myself. Good. So we have a short presentation, 5 minutes. Please keep this 5 minutes within 5 minutes because we want to open the floor for discussion and have more interaction. So we will go for each panelist, we'll give a 5-minute talk about his or her position with respect to the panel team. And then we will open the floor for discussion. And I hope you have a lot of questions to our panelists. So there is no specific order. So it's up to you. Prem, do you want to start? Or Xinhui is already, is it yours?
Yeah, because
So go ahead,
think
go ahead
this-
with that.
Are the slides in there?
There is only one slide, so I'm not.
No, you told me that you want to use your laptop. Yeah. Okay. Yeah. Good. So go ahead.
Oh, okay.
Oh, you could use that.
Okay. I think because I think one of the first questions is that with the advance of AI or FMs, should we rethink our software development process? If so, how should we adapt our research? So I guess because this questions is very related to the picture that we have. So we have a upcoming paper, a precision paper on TOSM 2030. So it's like a vision paper on automated programming, large language model and beyond. So in this paper, we want to see in future what will be the kind of the programming looks like, the programming environments, how would it changes the programmer roles. So we have these two pictures. This looks quite fancy, but then it's actually automatically generated, both pictures. So the first one is that So we think that maybe instead of just a code writer, so usually these days programmers usually just writing code. So like in future, maybe because the currently automatically generated code is only limited to only just particular methods. So to go beyond that, we think that future developer may need to compose different code together. So to have maybe combine several different methods, and then they also need to be more like a designer. The architectural level kind of design, how to structure the codes in general is still beyond the limitation of current approaches, because they still couldn't take in as much tokens, they couldn't take in the whole projects as input. And then the other role of the programmers will be more like a quality assurance specialist, because currently things like testing and ensuring that the output is automatically generated is still more the role of what the programmer should do instead of just writing code. By the way, the second pictures originally when we asked DALL-E 3 to generate these pictures, they generate something with the mail. So these pictures, we replace it because after someone read our paper, and then they say that if we just include 2 mail pictures automatically generated, it seems to be too biased. But without giving it something specific, like having a female role as this, they still generated something like more like a male programmer. So this kind of bias still exists. So I think these 2 pictures shows a few problems. Also our vision of how the programmer roles will be in the future. So I guess maybe that's 5 minutes. Yeah.
Sorry, Diop.
Okay. Yeah. Yeah. So maybe I can start next. Don't have slide, but I can also reflect on the same questions that Chin has mentioned. So the right, so the futures of software developments when thinking of AI and FM base. So we also have a vision paper. So it's about multi-agent software development. So we have seen research about LLMs and FMs across all knowledge area in software engineering. We listed like elements knowledge area. So this happened in requirement engineering, happen in code implementation, in testings, deployment, and even with the management projects. So if we see a future where the research has been mature enough that we can have actually an AI coder, and have an AI tester, also an AI-based managers. So the human roles that we see in a project now can be replaced by an AI-based systems, AI-based agents. So the agent will be trained for that specific task. And instead of like we talking to a software, to a tester when we write the code, there will be an interface between code generator. It will be interface and the AI-based testers. So there also is more and more tasks that can be automated at the managerial level. So yeah, so that's I think that's we of course, I mean, it might happen in a certain domain, in a certain context. It might happen more in a more straightforward domain, with, for example, web developments. Yeah. And see, I can reflect on other thing. The second question here, what's the most promising research directions for software engineering communities? I think For us, I think the requirement engineering is an area that deserve more and more attentions. All people here are smart, and all people here do a lot of things to improve the capability of AI-based models. But still, I mean, at least for my or in my opinions, in not a very short term, the human input is still, I mean, essential for the projects, and we can focus on more on understanding and designing prompts, and maybe revisiting the role of requirement engineer in the current software projects. Yeah, that's my 2 cents.
All right, so let me try to answer the first question, how software development is going to change, because the answer to this question would be different yesterday, it's different today, and it will be different tomorrow. Why? Because we all pretty much figure out how to do software 1.0 development, right? With the requirements, design, implementation, testing, deployment, verification, and maintenance. However, software development is changing today, because now we're primarily working with systems, software 1.0 systems with software 2.0 components in them. And this is different, right? Because for that, we also need to incorporate other stages of software development. Like in this case, it's data collection, data processing, model learning, integration, model and data versioning, model management and maintenance, production testing, deployment. So this needs to be incorporated and reflected in the software development context. Now, the answer to this question will be different tomorrow, as we are moving even more closer to 2.0. And as Ahmed was talking about software 3.0, which is promptware and eventually agentware and mindware, support and so on, this will change even more rapidly. So that's the answer to the first question. Second question. What are the most promising ideas? I really like how Prem brought the notion of shelf life of ideas. I think this is really important. I fully agree that this is probably the most promising direction to by modality, or as we were previously talking about unstructured and structured data and evolution of this idea. And I really think that this research design space is very large. And Prem gave us amazing ideas how to seed models with information from other channels. But in my opinion, there are a lot of really interesting opportunities also, not just feeding, but fusing program analyses and models. So not necessarily just feeding data for program analysis to the model, but like program analysis working with the model. So there are many really interesting directions here to explore that stem from this bimodality, structured and unstructured information. Now, going to how can we compete with industry? Because Lori asked us, what can we do? Because industry has so much resources these days. What can we do to make the difference? This is a really important question, in my opinion, because indeed, when it comes to designing architectures or training larger models, we are hopelessly behind. We'll never be able to catch up with them. And we know that training larger models does result in very cool emergent capabilities that we as researchers study. However, I do believe that we as researchers can still have plenty of work in this intellectual merit space where we can make the difference in the idea space. And then let me just briefly point to a couple of directions, which I primarily thought from the challenges stemming from developing software 2.0. What are the major challenges and where we as researchers can make the difference? For example, when it comes to requirements engineering that you mentioned, plenty of opportunities here, right? Because planning these deep learning-based systems is difficult, right? Because performance or accuracy of the system is not known until the model is trained. Effort estimation is incredibly difficult, right? Experiment management, data management, training data management, experiment management. These are all really challenging problems that we have a chance of tackling and addressing in academic context. Maintenance. These software 2.0 systems are riddled with technical debt. Read the latest technical report from Google. It's basically a lot of glue code around machine learning code, put together with software 1.0 code. So things like data dependencies, right? In software 1.0, we figured it out. We can extract the static analysis, dynamic analysis. Not necessarily the case for software 2.0. Good luck extracting data dependencies in the training data. Really challenging problems. This is where we can come in and think about it. Reliance on pre-trained models, testing. Ahmed was talking quite a bit about testing and debugging yesterday. We cannot just take testing and debugging techniques for software 1.0 and quickly transition them to software 2.0. Completely different challenges, right? It's not enough just to debug model code. It's not even not that beneficial to debug or put breakpoints in the model itself. So the challenges are, in my opinion, are in intellectual merits. It's not in the computational space where we have really good chance of addressing them. And again, I don't want to go through all the exhaustive list, but there are plenty of other opportunities, which obviously interpretability, explainability, context, security implications, testing for bias in training data, and obviously legal, some of the legal implications that we need to think about carefully and figure out how to work with.
So I just really want to make one major point, which is that language models make mistakes, right? So just as just for some touch points, so we've done experiments with several different data sets. DiPyBench is a data set of Python functions which can be generated that come with test cases. So you can ask the model to generate those functions, see how many pass tests. STubs for J is a collection of bugs and fixes from GitHub. And so in these data sets, when you set language models to work on them, for DiPyBench, about 30% of the cases generate code passes test cases. For STubs for J, depends on the model, about somewhere up to 30% of the time, you get the correct code. The rest of the cases, you either produce buggy code, that produces some other random garbage that's fun. So they make a lot of mistakes. So know what to do. So basically, I just have one idea that we've been working on that we're trying to do, which is our belief is that at the end of the day, the last mile, that is the time from the language model generates code, the developer decides to use it or not. That's a crucial part. And the developer needs all the help they can get to figure out whether the random model, the language model has produced garbage or not. The reason why this is the case is that when the language model produces buggy code, if it produces garbage, it's fine. It doesn't compile, good. It's done with. You're not going to use it. It's good. If it fails test cases, that's fine too. The real problem is the language model produces code that compiles, type checks, passes static analysis, and passes all the tests, but it's buggy. And why is it going to produce that? Because that's kind of code it's trained on, right? The code it's trained on is code that has already passed tests, right? So when it produces bugs, they're going to be the nastiest kind of bugs you can imagine, right? So how do you help the language model? How do you help the developer fix that, right? So what we've been really working on is trying to figure out ways where the model itself could give the developer some clues as to how confident it is that this code is not buggy, right? And that's a really difficult problem because what it's trained to do is to reproduce the code that's seen in the corpus. It's not trained to produce a signal as to whether the code is correct or not, right? And so this problem is pretty well known in machine learning. It's called the calibration problem. That is, you have some notion of whether the code is correct or not, and you have some kind of signal from the model as to how confident it is in the code. So what you really like for the do is the confidence to be well correlated with the correctness. That measure of that correction, the relationship is called calibration. And for example, this is a problem in weather service, weather forecasting is a problem in medical diagnosis. And so it's been pretty well studied. And so, but making it work in a particular discipline like software engineering or medicine or weather forecasting is something where you have to sort of look at the parameters and the sort of configuration of the particular domain and make it work. And that's what our research these days about. I think it's an important issue for various kinds of problems in software engineering, not just code correctness, but other kinds of correctness issues. So I think it's an important problem, and that's something that I think will be around for the future because it always, I think for the foreseeable future, despite what Ahmed Hassan says, I don't think programmers are going anywhere.
Thanks. Answering those questions is very difficult, as mentioned by Dennis. So the answer yesterday and today and tomorrow will be different. And on Tuesday, we were at the dinner, and I don't remember which topic we were talking about, and say, oh, but GPT-4 cannot do that. And Dennis told me, but GPT-7 will. Yeah, now the floor is open for questions. Please, if you have questions, comment, either you address those question or comment to the whole panel, or if you could mention that the question is for specific panelists. So yeah, there's a question here.
I was going to ask my question related to this chance after your answer. In my opinion, there is a strong connection with the interpretation and execution, but it has to be distinguished. My question is that are we ready to sacrifice the performance to dig in more and understand the inner mechanism of the
I would say, can you hear me? I would say it's the answer to your question will be context specific, right? Because I had a chance to speak with somebody from Huawei. I forget your name. Gopi. He actually had a chance to play with the scripts that come with our paper. And one issue that he pointed out, this is not scalable for the context that they are interested in, right? So scalability or real time, if you want to really get interpretability working for your context, you will need to sacrifice something, right? So it's almost like in-field debugging, right? Or in-field failure reproduction, right? If you want to get some useful information for developers to be able to reproduce bugs, like for example, Microsoft at some point was embedding very lightweight information that would be useful for in-field failure reproduction, you have to sacrifice certain level of performance. So we as researchers are not even thinking about scalability issues. Right now, we are, when it comes to interpretability, explainability, we're still in the figuring out how to even do that. We're not even worried about computational effort. But at some point, we're going to start playing with the slide bar, right? And putting it where it matters, where the problem is.
Okay, so my question goes to the entire panel. How do you see the creativity part of the software developer changing with the use of more and more automated tools, large language models, right? So I think that's something we see very often. We don't research as a lot as I think we should. Developers very often choose new libraries, new frameworks, because they want to learn something new, something fun, even if at the system level, it doesn't make the system better. Right? Will we have actually more creative and more fun experience while being a developer, or would that diminish now that we work with so many automation that it's hard to understand the problem because it's so many things?
I can take this question. So thank you. I think it is a very interesting and relevant research questions. And I know a couple of people are working with this topic, creativity when adopting AI assisted learning. So from what I have seen, I believe that it will have a certain impact. So first, people will learn to do things and be creative in different ways. And here, though, there's a code generator come into the picture, how to best use it with the current capability of the model. But in a future scenario when the model capability be saturates, when it gets to the level that it can be easy, convenient to use it, and yeah, and even even in a scenario where the human intervention is minimized. So yeah, so where's the room for creativity here where a certain project can be completely generated? It's my view.
Let me throw something very easier discussion. Maybe creativity eventually will be able to learn what creativity means, statistically speaking. So right now we're training these models on code, which is in the repositories. Eventually, these models will start learning from keystrokes. So not just snapshot level, but continuous learning from what developers do. So you can imagine that these models will learn what is natural, or natural behavior, natural added sequences, or natural implementation plans. So eventually, statistically speaking, I'll be able to say this: if you are to implement this feature, that's the most natural way to write this lines of code to get to implementation. That's the most natural, whatever we mean by natural. So statistically speaking, right? And then at some point in time, I would be able to statistically measure creativity and say, well, that's a very interesting way to do this. It's different, it's creative. And maybe at some point we'll be even able to measure deviation from the image.
Sure. So I mean, for me, creativity is essentially involves human beings. There's no creativity that we judge when we see some painting or writing that's creative. We judge when we look around or we support and see it's creative. Right? So without a human in the loop, there's no notion of creativity because some human has evaluated to see it's creative. It's part of human dialogue. So as far as whether people continue to write creative code, I don't know that it's going to stop. Mainly because at that point, when we start worrying about whether humans are creative in code writing or not, it's not a matter of finances, right? I mean, most artists don't get paid. Most writers don't get paid. I mean, it's just a fact. Very, very few writers are actually getting money. And they do it because they want to be creative. So I think people who want to be creative in coding will continue to do that. And even if language models are being good, they will still require humans to evaluate it, I think.
Thank you. Just a quick follow-up.
Oops.
Do we see the need for new programming languages? Training the tools of the past. Do you see the new impact the creation of programming language or frameworks since their popularity is heavily based on what's the training data?
I actually, I think I haven't answered the first questions about creativity. I feel like because I talk to a lot of developers, sometimes they say that most part of the code that they are writing is actually just regular code that is mostly do not involve creativity. So I would think that instead of creativity, maybe the other way is the specialization, because usually developer have some kind of specific knowledge about certain domain that may be more needed, and then those kind of data will not be in public, so it's less likely that those kind of specialization knowledge can be automatically generated. And then for the second part about whether the needs of programming language, I think that I was reading that they try to design some kind of language just for kind of interacting or for this kind of large language model. So it did inspire some kind of new design of language.
I just want to quickly add that creativity in code, this is essentially type 3, type 4 codes. So we need to be able to study techniques, right?
As a moderator, I'm not supposed to answer questions, but I will. No, I mean, software engineering is not just programming or coding. So there are other tasks, and other tasks require creativity also. And we are just working recently. We conducted a study on modeling, like how when doing domain modeling, using these LLMs as assistants, and we asked our question, do we have like this limits the creativity? And we measured the diversity of solutions made by different participants. And the things that is important is not, is the inferred knowledge is good or not, and how to deliver it to the specialist. So same thing for programming. So we could have LLMs that have inferred good, really knowledge somehow, but the way we deliver it, is it automatic? We just complete the model without asking the designer, or just let the designer ask for help at some moment, or wait until the end and then comment about his model and improve the model. And with these different alternatives, we had different diversities between the solutions and creativity. So I think we should pay attention about separating and inferring knowledge and delivering knowledge to help people when they are performing software engineering tasks.
We talk about sacrifice, we talk about scalability, and the previous presenter was talking about the performance, right? So I'm wondering, what are the, based on your experience, what are the apparent or obvious challenges? Maybe about performance, like not just using LoRa to do some downstream tasks, but maybe some other aspect in performance, but as well, not including trustworthy, but some other aspect about human, because I think the trustworthy is important. A lot of human are not equal to. What are the other challenges you that's apparent that research is to solve like even?
Yeah, thank you for the question. I can say because I think I have a relevant research to reflect on it. Because we also have students working with pair need testing, and we actually focus on a specific domain because because actually people want to build an AI system for education, so actually for grading and supporting teachers in schools. So I think that's your question. It is also domain specific, and in our case, it's very important to ensure the fairness, but for teacher and for students to be fairly treated through the systems. But then it's also come with question: what does that mean with fairness in education? And this has a long history and controversial, and even people don't have, a consensus view on that. So we summarize more than 21 different definitions, different categories on fairness. But we try to bring it down, and we look at, okay, so algorithms fairness and how we can ensure, at least say, from the way we operationalize the concept. Then it's so we test. We want to ensure both performance and fairness at the acceptable level. So yeah, we are like such a mentioned, like we have to sacrifice something. So when we put the fairness in the picture, we see the reduce of performance to the acceptable level, and at least from a practical point of view. Then we also want to see, because the current model is only focused on a single sensitive variables, but we want to have a more comprehensive framework. We want the model to treat the student equally in terms of age, genders, nationalities, the year of studies, and other variables as well. So and then we get the external input that this also important, not less important than the performance of the model.
So so what we're doing now is try to see if we can achieve a a model that's protect multiple variables and at the same time achieve the performance.
I just want to bring one issue, which I think is really important. This is data quality and potential feedbacks in the systems of the training. So let me give you an example. For example, if you look into Zillow, which is used to estimate housing prices, right? If you take the highest price there and you pay that price, or you pay above asking price, for example, you get that house, your price will be recorded back in the system that will be used to retrain the model. So similar thing we're going to see in source code context. A lot of code will be LLM generated. It will make its way into the repositories and it will be used in training down the road. And it will significantly impact the flow of training data. So as these things get embedded into the developers' lives, into self-development life cycle, we're going to see these inadvertent, accidental challenges that we will soon need to be facing in the process.
Next question.
So,
Oh, go ahead. Sorry for that.
yes, so part of the point I wanted to make is that there's a lot of concern in the US, the intelligence services, about the possibility that these models are co-opted, right? So take your favorite bad guy, you know, George Soros or Putin or whoever, Trump. Let's suppose they invest $1 billion in OpenAI. Now what happens? You know, you might not even know who's investing in OpenAI. You might not know who's got financial control. Large publicly available models. And so now they can insert code into some launches, because people just trust the code that's familiar. So assuming you're using a model you don't trust, how can you trust the code? I think it's a real problem for a lot of people.
My question is for the panel. So yesterday we had a presentation talked about the firmware instead of the codeware. And today we have again the evolution of the program. Instead of writing the code, we'll be generating the code. So I have two questions based on the implication of this shift or evolution. So the developer is going to work as a quality assurance specialist. Currently, this can be done because we are trained with the foundation of software engineering, and we can evaluate the output generated by the large language model. But maybe in the next 10 years, if we do not have those foundations, how would you expect the developer, who in quotes is now quality assurance specialist, to evaluate the correctness of the generated code? Then the second question is the social economic impact or influence of this evolution. Is it going to replace the jobs of some developers? If it's going to replace the jobs, are we creating solutions that will lead to economic meltdown, or are we addressing this challenge? Thank you.
My quick answer is that I see the developer of the future basically like in those satisfied movies, like soldiers with exosuit. So LLMs is like your exosuit. They will still do programming, they'll still do quality assurance, but they will be much more subtle.
I think that's very good questions about the education. I think it's like if we were thinking about you want to validate an automatically generated code versus a human written code, I think it's something different. Like there were research that shows that if you need to verify someone codes, even though like someone were to provide you some suggestions actually, but you will not be able to understand, especially if you are a novice kind of programmer. So because you someone tell you how to kind of change your code, but then for them to tell you how to change your code, they may use some kind of other example and code that also need further explanation. So it's almost involving like you reading some others people code. So, but that is also a good practice, I think, like reading other code, understanding automatically generated code. But I think the education need to focus more on like not being trusting like what is being written and then automatically generated. I have this kind of problem because in my class I'm teaching, I ask students to use ChatGPT to try to use it, and students did overtrust it somehow. Like for example, they didn't check whether the path that is generated is actually a valid path or kinds of things like that. So I think teaching students how not to have this kind of too much confidence about the automatically generated code is important questions, and I think there's no research on how to do that or how to more incorporate that, because it's not just one way kind of thing like that we need to know the consequences of trusting, and then that will kind of not doing it. So it's a long way to go, I think, for that. For the second part about the social, technical, so economical aspect, I think that's very good questions, but I don't really know whether it's cost more to ask someone to like fix the bugs that is written by the automatically generated code, or like I mean, because I'm working more on the testing perspective, I feel like I still always have the job because I always need to find bugs in either human written code or like automatically generated code. But I would think that that is also one of the way to think about if it may not be just simply replacing humans with AI kind of thing. I think it still needs to be, sometimes AI just take you too long way. Like they may tell you that you should do this, and then you go back to the same kind of cycle. So it may be still more time consuming, but it's worthwhile to do a study. I even think that like what is the cost, like whether there is a higher cost to fix automatically generated bugs, and then versus fixing, because I remember when we were teaching software engineering class, we always have the nice diagram that say that when you fix the problem earlier, and then the cost is less, but we don't have this kind of diagram that shows that if you fix the automatically generated bugs, the cost is higher because like you also need to use the API, and then you also need to pay for the programmers. If the cost is higher, maybe that will make it more convincing, I feel.
I just want to throw in one more controversial idea. So I think most of us, including myself right now, are stuck in this local maximum understanding that these foundational models are going to be everything 5-10 years from now, in the sense that LLMs is all we need, which is going to grow them, right? They're going to have more capacity. They're going to be larger, maybe new architecture, maybe more training data. And eventually, they just by doing that, we're going to address all the existing limitations, and we'll have all these new emerging capabilities. But don't forget that AI is a big thing. Within that AI, we have deep learning, and then we have machine learning, and then we have representational learning. This is kind of small thing where we are stuck right now. Eventually, it's going to be beyond that, right? Eventually, it's not going to be just foundational models. It's going to be AI things. So to me, the really interesting part of the future is once we start going outside of this small circle, foundational model, once we really hit the wall and say, well, GPT-7 still has these issues. Yeah, we significantly increase the size, we increase the training data, but we're still hitting these walls that we've been hitting 2 years ago, something along those lines. We actually have to now be more transformative in the way we move forward. So, and that will impact the answer to your question.
I also have a very quick feedback on the question, because it's very interesting questions. So the second question is about the social economic impacts. So I believe also that will trigger a lot of discussion about that. But my view on that, so when the student graduates, I mean, this year, next year, you think that they will be difficult to find jobs because of the current, the appearance and the popularity of LLMs model? Yeah, probably not. But I think that's in the future, when the models they get to new capabilities, I think it's also important for educator to watch, to understand the movements and to prepare our future students with the necessary skills and competence in this picture. And I think this will not happen like next year or in 5 years. I think that's the journey from AI in the loop to the human in the loop. It will take much longer, and I don't think it will happen very soon. But I don't know if any of you that go for job interview or internship interview have been asked that your competence with Copilot and how you use Copilot or how you use LLM to support your work now. Maybe no. It's still mainly about your logic and your critical mindset, your programming skills, and how much you can learn things and how much you can solve problems. So I think that it's I won't be not too skeptical on this.
I don't really, let me just project it rather than use the microphone. So I think, one thing as far as the social and cultural impacts of language models is that, what we hear from queer theorists and cultural theorists is that the existing power structure is still receding, right? And language models can amplify that trend. So even in coding, so because, when you describe a piece of code you want to implement, there's a lot of cultural assumptions that go into interpreting that description of what code is designed to be built, and then the code gets generated, right? So if you have a language model that's trained on what the corpus of code as it exists now, it also reflects existing cultural positions and values, right? So, critical theory people like people who do queer theory or feminist theory or racial theories might say that, if you do that, then the models are going to recapitulate existing power structures that are reflected latently in the code. And do we want that? Do we not want that? I think it requires some consideration. There's a lot of pushback against critical theory, but I think it's worth thinking about. I think there are some interesting ideas.
Okay. Okay.
From things, I was wondering, so right now what we're doing is that the LLMs are actually, or the LLMs are outputting code. And there's this idea of paradigm shift where we might skip that step and not have the output be the code. So maybe from your perspective, I'm curious to see, what do you see that be replaced with? Maybe from some of the notes that some of you mentioned of being able to see the confidence level and various studies, even though it's working. Is there another format that would be a better output that would also help have more of these software makers and non-coding programmers? It'd be a little bit more democratized. So very curious to see what would that look like. Is it like QML? Is it something different?
Well, Ahmed yesterday said that it's going to be promptware. So it's instead of code, we're going to have prompts and we're going to have version prompts and maybe versions of metadata, which models these prompts will use to generate. I don't know. I'm personally not that convinced. I think we still going to be code centric for a while. Yeah, we may have all various ways to produce code, but ground truth, in my opinion, is still going to be code for a while. I don't think we're ready for the drastic paradigm shift because we don't have foundation to support this paradigm shift, in my opinion, right now. But again, I may be wrong, and I'm wrong most of the time. So.
Good. Okay. We still have time for 1-2 questions, and then we will wrap up the panel. Go ahead.
Hello, I think last week, former researchers from OpenAI stated that AGI 2027 is slightly plausible, which has brought a lot of discussion online. So I want to ask the panel members, do you agree with that claim? And when AGI comes, how will that affect how we create software?
I think Ahmed can answer that question.
We should have invited him for the panel finally. Any thought?
I already answered. My question does not, answer does not change.
Good. So let's move to the next question. This is our last question.
Thank you for a very nice discussion. So it's a kind of open-ended question. So with these large language models, we have been trained to think on abstract level. So we have been trained. So I remember first I started coding with C, then to reverse this string, I had to write 5 lines of code. Then I used Java for an API invocation, and now slowly we are moving up to the more abstraction level. So do you guys see any kind of danger in this kind of trend? So do you think that we need a trade-off between this abstraction level thinking and the low level details? Do we need to make any kind of trade-off? Because if there is any kind of, let's say, serious level bugs, people will think from an abstract level perspective, but they will probably not be interested to understand the low level details.
I think so. Let's to the previous question that was asked about what kind of way do we present information to users in a way that they can properly understand when they should trust the language model and when they shouldn't, right? So, if you think about code, you could just color code according to the confidence that the language model has in its correctness. But if there's really no code and the model is doing something like scripting my tax filing or scripting how I should collect medical insurance claim or something like that, right? I don't really know programming, but I want a model to produce for me some complex script that handles how I travel or how I get medical help. In the US, it's a lot more complex than here, right? So how do you sort of help a user who's getting some complex series of steps executed by an agent who doesn't know programming, but still might be worried whether the agent is producing good code or bad code at a very high abstraction level? How do you provide them with proper information? I think it's an interesting question. Not my area, but it probably involves a lot of HCI studies and so on about how you communicate with users about computation in a level that doesn't involve programming. I don't know how to do that, especially when it could be wrong.
I wanted to quickly mention, and somebody asked this question earlier, how do you see the evolution of programming languages in this new context? And given your question, I think there is also a huge opportunity, and this is something that I bet we'll see in the near future. For domain-specific applications or for certain domains, we may see some interesting evolution of programming languages where it's not quite just natural language used for programming, but it's some domain-specific semantics embedded with natural language, where we can make very rapid advancement in development. Imagine Android, for example, development, right? Where you can just have some specific keywords representing very concrete concepts so that there is no ambiguity mixed together with natural language for very quick prototyping and development. So we're gonna see, in my opinion, and again, as Prem mentioned, 20 startups every day, and I already see these things happening, right? For domain-specific applications, where nice fusion of domain-specific languages with LLMs could produce very rapid results.
Thank you.
So thanks for the questions. Perhaps we will go for some concluding remarks with the panelists. I want to ask one question. So there are two possibilities for the future. So we will continue to train these bigger and bigger and bigger models. And so the two possibilities is having big brains. If having big brains means that we are dominating things, the whales should dominate the world. Or the whales are already dominated the world, but we are not aware of it. So how do you see that this race of having bigger and bigger and bigger model is it linear with the capability of these models to produce contents that is usually dedicated to humans, or you are not seeing that that will be linear, like in that case? So just quick conclusions.
This question about AGI also was asked earlier, right? I mean, so I don't know, I think it depends on the way governments respond to markets, like with everything else in the Western world, so the markets are gonna produce maybe in the future something that replaces human labor. What happens then? I think it's up to democracies, governments, whatever.
For me, it's totally impossible to make the prediction, but I don't think it's linear. We're actually doing right now a study where we're trying to measure emerging capabilities. We are basically trying to somehow quantify them and then see how emergence across models of different sizes. And we don't necessarily see the linear relationship here. But again, it's extremely hard to say. We need to have more data, more empirical results to be able to project. But I don't think it's linear.
I mean, it could be any conclusion on any aspects.
No, not just final reflections. When you raise the question, and I already think about the energy consumptions. Yeah, so I think that is. I don't think it's sustainable or healthy to. I mean, with the rate of like increasing the model in the size, I think that it wouldn't be more towards building a smarter model and balancing between the specific tasks it should be done and also with the size of the model.
Yeah, for me, I think I agree with what they say about. I don't think it's linear. I think it's also still more depend on the data quality. Even if you have trained more data, like maybe like the most of the research we're focusing on like selecting the correct data, like improving the data quality, and then they're also like fixing the mistakes that is made. So then it will make it not linear in that sense.
Thank you.
Silly.
Yeah. You are the organizers.
So we can consider the people building this model programs. Because we have been discussing as if models are coming this way and then impacting programming with their own stuff. But these are also apps, right? Like GPT, whatever you want to name it, it's an app. So do we consider the people be building this AGI that's coming program? And if this is the case, I guess the current skill set of programmers, or the current types of programmers, to build those type of apps, do you think it will be different in the same way? Really looking at the other way around.
I have a quick answer. I personally think that application developers will probably be gone. There will be systems people, and there will be data scientists. And application developers would move into this data scientist definition. So data scientists and systems.
Yeah, I completely agree with Food says, and I think that's actually the core areas of software engineering or machine learning, isn't it? That's the name of the symposiums. Because I think like building, I mean, in the modern era, I think building the model, writing the code for the model is only a very small portions, and there's a lot of other tasks around the database, with the data curations, with the infrastructure, with deployments, and I think it's also very important to think about engineering methods. So I see people start talking about the DevOps for machine learning. We talk about the practice. We talk about tools. At least I have two friends who work as a AI scientist, asking about if I know any tools that they can use or can support their work. So definitely, I think this should also be a subject for the software engineering research.
I think Fus mentioned a good problem. It reminds me of I think some new events that happening. So I checked. I think it was in GitHub. So there were some kind of incident where someone was copying another people model. And then like I feel like this way of development, because they sometimes they know that they want to write a new model. They want to they only focus on the publicity of the model. but then they don't really actually build the model by themselves, and then they're just copying. I think this copying, because there's only limited way to improve the model. So I think the kind of plagiarism in terms of building new model will be an interesting problem. At least I see that this is happening, and then like people were just saying that just because this model is less well known because it was in some kind of Chinese community, and then they're just copying it, and then they say that okay, this is built by Stanford. Like they just put a new label, and then like people are trusting it, but I would see that like when there are all the people who are designing this new model, that will also have these problems because they don't know how to build this model, or like the improvement usually very little. Like these cases happen where they just simply change some kind of parameter, or they change some name, they do some renaming, and then they claim that this model is new. So I would think that this also another problem that could come out of this.
So I just wanted to raise a question in response to Futz's question. Consider two things, right? One is the model itself, which is energy that it consumes to answer the query, to process the query. And then consider the person who built the model, who lives in Montreal, drives a car, travels by plane, eats a lot of meat, which uses more energy. It's not clear to me. I mean, I'm not saying anything specific. It's not clear to me who uses more energy.
Good. So let's thank the speakers and the audience for this very interesting panel. Thanks. I don't deserve it. I deserve it very much. It's very good. Thank you very much. Yeah.
the food. So let us start the session about FM trade-offs, efficacy, efficiency, security, transparency, and fairness. So let us welcome our first speaker, Professor David Lowe, who is Professor of Computer Science and Director of Information and Systems Cluster at Singapore Management University. Professor David Lowe, he received several international honors, including recently the IEEE Fellow, the Fellow of Automated Software Engineering, ACM Distinguished Member, and so many other international research and service awards and recognitions. So Professor David Lowe will talk about the efficacy, efficiency, and security of code LLMs, promises, and builds. So the floor is for you.
Yes, thank you very much, Ali. Very good afternoon to everyone. Am I audible clearly at the back? Yes, thank you very much for the confirmation. So very happy to be here at SEMLA again. This is my second time giving a talk at SEMLA. Last time was in 2019, right before ITSE. I enjoy giving a talk here at SEMLA. And I'd like to thank the organizers who invited me to come here. Thank you very much for all the arrangement. So I'm very happy to talk about the efficacy, efficiency, and the security of code LLMs. So this book will describe some of the promises of the code LLM, but also some of the perils as well. And I'm very excited to share this in this short talk. So first of all, since I guess I'm the furthest to travel here, let me tell you a little bit about our small island called Singapore. Right. So this is the world map, and do you know where is Singapore in this world map? Yeah, it's somewhere there, right? It's actually not in the world map because it's too small, right? Not in the world map. So it's actually located here, right? And if my geography is right, I believe the Monaco is over there, and we're actually separated by about 15,000 kilometers, right? So the trip to here takes about 20 plus hours, excluding the waiting time. So, but I'm very happy to be able to come here again in Montreal. So, and in Singapore is a diamond-shaped island, so it's pretty small. So if you travel from the west and going to the east, then that will actually take about 45 minutes by car. If you go from the north to the south, it will take about half an hour by car. So small island, and there are 5 million people living in this small island. And in this island, it's very green, just like here in Montreal. There's a lot of trees. The government making an emphasis to plant a lot of trees, so that Singapore is green and rather cool as well. And then this is the view at the night. So this is the special icon of Singapore. So it's a mix between a lion and a mermaid. This is called the merlion. So this merlion statue is actually very close to our university. You can walk from this merlion statue to our university, the Singapore Management University. So in Singapore, some people say that for every 1 million people, the government will create one university. So Singapore is the third university that was created. It is a management university, so most of the schools are business, economy, and accountancy. So actually, when I first get a job at SMU, I talked with some friends that, hey, I got a job at SMU. And they told me, I thought you were doing computing. Why are you joining a management university? But actually, we do a lot of computing as well. So we have our School of Computing. And within the School of Computing, we have this Center for Research on Intelligent Software Engineering. So the center was started last year. We have a number of visitors because people come and visit us from Canada. Adana was there after ICSE, and this is the group will be put together. So we do a lot of interesting things about software engineering. One area is on AI for software engineering. And we started maybe a number of years ago looking into how data mining can be applied to software engineering. And then we also, after that, looked into other things like information retrieval, natural language processing, search-based algorithm, and applying them to different types of software engineering problems, including test oracle generation, intelligent issue trackers, how can we process and improve crowdsourced software engineering, and also how we can do automated code repair. And we are recently very much interested about large language models, especially how we can trust them and how we can synergize with them. So if you are interested in a few thoughts that I have on this direction, please feel free to read the archive paper that was presented briefly during the ICSE last year. So we love to collaborate. So we collaborated with many people in Canada, and I hope that this talk can also trigger some more collaboration between some and attendees and us at Singapore Management University. And hopefully the photos of Singapore will interest you to come and visit us in Singapore. So I'm going to go to the main content of this talk, which is on the efficacy, efficiency, and the security of code LLMs. So I think many talks today and also yesterday talk about LLMs, right? So we are very excited about LLMs. And according to Wikipedia, the first LLM is Google Bird that was released publicly in October 2018. And since then, people have designed bigger and bigger LLMs, but people also design LLMs that are focusing more on code, or they call them code LLMs. For example, the first code LLM was done by Microsoft. So this is Code Bird, released around at the end of 2019. Then Microsoft released again another Grok Code Bird. And then Salesforce in Singapore actually released this code T5. And then there are many other bigger LLMs, including like the Code Llama that are recently released, right? So we're very excited in this. And in Singapore, we're also excited in this. So since a year after Bird is released, we see how we can apply it to analyze data that software engineers produce, especially text data. And we're also continuing to look into many different applications of LLMs. More recently, we look at how LLMs can also be used to improve, for example, vulnerability repair. So, of course, there are a lot of work done in this direction. And together with a long list of collaborators, we were actually looking into what kind of works are done in the scope of large language model for software engineering. And we are actually very excited that this exponential trend. So like in 2020, we did about 7 papers. And then in 2023, just half of the year, we see the number of papers actually go to 160. Right, so there's an exponential growth. And it also cover different aspects of software development and also software maintenance, software testing, and so on. But of course, the problem is not solved. There is a lot of open problems. And the problems is not just about like the LLM does not work so well. There is functional issues with LLM, but often the problem is also the non-functional issues. So recently we looked into a systematic potential review, and we find there is a lot of work that discusses many other non-functional problems with LLM. For example, problems related to privacy, explainability, usability, and the list goes on. And also we can see there is an exponential increase in the number of papers in this collection. So in this talk, I'm very happy to share with you some of the recent work that my students, collaborators, and I are doing on trying to improve the efficacy of LLM for target software engineering tasks, and also how we can improve the efficiency of the LLM, and also how we can improve the security of the LLM. Well, for the last part, I promise you I'm not going to talk about promises, but also perils. So for this last part, I don't have a solution. I only have problems. So hopefully some of you can have a solution to solve the problems that I will highlight. Okay, so first of all, talking about the efficacy of the LLM. So I'm going to talk a little bit about this paper that was presented 6 weeks ago through NIXI in Portugal. So this is how LLM can be used for repairing vulnerabilities. And in this work, we actually extending a few other work that have applied LLM to repair vulnerabilities. So the setting is often like this. So we have this vulnerable functions. And then after that, we have this vulnerability type. And then we feed this information into the LLM. And then the LLM will process this information and finally produce the fixed function. Right? And there is a few papers that show that this works to some extent. So when we start this work, the question that we ask ourselves are as follows. There are many other things that developers often look at when they are repairing vulnerabilities. These have not been used in the prior setting. Can we use them so that we can boost the performance of this large language model for vulnerability repair? So that's what we do. So one thing is that the prior work have not looked into the structure of code. If we look at the structure of code, for example, at the abstracts index 3, could we boost the performance further? Another thing is that there is a lot of information on the CWE. Like for every vulnerability, we can actually figure out, for example, what kind of vulnerability it is. And also, we also have a few simple examples how those vulnerabilities appear in code. And we also have a detailed analysis for each of those vulnerability examples. Right, so we said to answer this previous question, the first one is that how can we incorporate all this information, right, so that we can do better vulnerability repair. And the second thing is that how we can let multiple LLM collaborate together, so that at the end result is better. Right, so this is the two questions that we said to answer. And our answer is in form of a solution. We call it Bullmaster. And the solutions have the following features. So one thing is that when we're trying to understand the structure of the code, we just focus on AST, but it can be extended in the future to other kind of code representation. And also incorporate information of various vulnerability from CWP. And one problem is this: if we put a lot of input to it, many of the LLM, especially the lightweight LLMs, actually have limited window size. So we need to deal with lengthy inputs. Otherwise, it will not fit the context. Right? Another thing is that we try to make two LLMs work together. One of them is a general purpose, but very big LLM, GPT 3.5. And another one is a small LLMs, but we can fine tune and specialize it for the target task, which is vulnerability. And we combine that together and we demonstrate that this combination, and also by making use of this data-centric innovation, can improve efficacy in terms of the number of things. So the following is the high-level design of our Bullmaster. So first of all, we take our vulnerable functions, and then we partition them into code segments that can fit into the context window of lightweight LLM. And then after that, we also take the vulnerable functions, and then we created an abstract syntax tree out of it. And then we break it down also again to AST segments so that it can also fit into the context window of a lightweight LLM. And then we have a vulnerable type. We search through the CWP database, and then we can get information like description of that vulnerability. We also have some code examples that are simple that the CWP contributors have provided to illustrate that vulnerability. And also we have some detailed analysis as to why that code has a vulnerability. So all this information are helpful, but we're missing one other information. We're missing this one. We also need the fixed examples of this simple vulnerable code examples. And that is often missing. So we have the detailed analysis, we have the example with the vulnerability, but we don't have the fixed examples. And we make use of a collaboration between multiple LLM to generate these fixed examples. And then after we get all the pieces of information, we just fuse them together. And after we fuse them together, we can actually take the vulnerable code and then we transform it into a code that is free of vulnerability. Right, so we have these additional innovations, like we need to make the model understand abstract syntax tree. Because many of these models are trained assuming code as a sequence of tokens rather than an abstract syntax tree. We also need to do some kind of multitask learning to boost the performance further. And also this information in CWP, they follow a tree structure, right? So there is a relationship between different vulnerabilities and how we can make use of that information. I will not bore you with the details of this. They are available in the paper. So just would like to highlight this high-level description of the method Bullmaster. Right, so next I'm just going to present like how does it perform when compared with state-of-the-art solutions. So we compare with 10 different state-of-the-art solutions, including this 4. So we take the general purpose LLM like GPT 3.5, GPT 4, they are not specialized for vulnerability repair. We also take the task-specific algorithms like beam repair and mode repair, right? And then we can actually demonstrate that we can double this exact match score. And also we compare the performance of Bullmaster with the second best performing solution in our experiments. And we consider different segments of vulnerable code. For example, we take vulnerable code that affect long code. We take vulnerable code that affect short code and so on. And then for all these groupings of vulnerabilities, we also show that the Bullmaster outperformed the best performing baseline. Right, so these are our solution, Master. And there are still a lot of open problems in this domain. For example, dealing with complex vulnerabilities. So we assume in our work and also in the prior work that the vulnerability only exists locally for function. But sometimes vulnerability can cut across many different functions, and we want to repair them, then we need to change many different functions. And the current solutions are not able to do that. Another thing is that we want to also consider the larger code context. Here we focus just on the function and information from CWE and also other pieces of information that are available in CWE. But we haven't considered information from other parts of the repository, right? So can we elaborate all that information in order to fix vulnerabilities, especially complex ones that involve interprocedural analysis? And yet another one is that how we can establish this trust and synergy with developers. Let's say you are a developer, your job is to fix vulnerabilities, right? And then you make use of our tool Master, and the Master make a recommendation of the fix. Would you trust it completely? If you know that your job is on the line, so you want Master to provide some kind of rationale, some kind of evidence that the vulnerability is indeed a fix. So at the moment, none of the solution can provide that kind of a solution so that people can have trust on the outcome of it. So we have put our thoughts in writing in this following papers that will be presented in Brazil during this SE Vision 2030 by TUSEM that is organized just before FSC. So I hope you're coming to Brazil, right? It's not too far from here to go to Brazil. I will fly 40 hours from Singapore, so you will fly less than me. So I hope I can see many of you in Brazil. AI Wear is there, and many other exciting events happening in Brazil. And then that's the first part about the efficacy. I'm going to talk about the second part now on the efficiency of this code LLMs. So I'm very happy to hear, like after the winners of the posters were announced just now, earlier today, there is a call for us to look more into more energy saving, more green, right? And more sustainable LLM, including LLM code, right? So this is about that, on this efficiency. So LLM, by definitions, is large. And is also, because it is large, it is rather slow. And it creates a problem because developers often prefer tools that they can run locally because of this privacy and latency concerns. For example, a few months ago, Apple banned internal use of external AI tools. And also GitHub Copilot issues, 20% of them is due to the network connectivity, right? It's poor internet cannot connect to GitHub Copilot, right? So ideally, we should be able to deploy LLMs to IDE. But this is not easy, because this is what the VS Code team actually said. So Visual Studio Code is the #1 IDE now, and they actually say that 50 MB models is the upper bound. The ideal size is 2 MB. And then this model should produce result in 0.1 seconds. So this is the expectations. Can we meet this expectation with the current LLM, even the most lightweight one? Well, this is the findings if we are using like commodity laptops. So we find that like CodeBird, the size is more than 400 MB, close to 500, and the latency is about 1.5 seconds query. But compare the numbers, right? 2 MB versus 400 MB. Well, big difference, right? And then 1.5 seconds versus 0.6, a big difference. So clearly the reality is very far, right? From the expectations, right? So code LLMs clearly are much larger, much lower than expected. And more than that, these code LLMs are also not green. LLM consume a lot of energy. Similarly with code LLMs. So, so if you run CodeBird on your regular laptop with this type of battery, then your laptop battery will last not so long. And then do you know that if you run CodeBird 1,000 times, this may be common if you are using it, for example, to give you recommendations while you're writing code, then it will consume about 0.14 kilograms of carbon. It's the same as driving a car for 1 kilometer. That is not good. And please remember, CodeBird is actually here, right? This is the smallest, the most lightweight LLM, and there's much bigger one out there that consume a lot of energy, right? So I think there's a lot of things that we want to do so that we can try to save the energy and make the world a greener place. So for that, for the last few years, so we have worked partially also on trying to optimize code LLMs. We proposed a solution called compressor, and more recently avatar. So compressor focuses more on optimizing code LLM so that it is small, it can fit into 3 MB, and also it can be a bit faster, like 4 times faster than if you use the bigger LLM. And more recently, we looked into avatar. It was presented also a few weeks ago during MIXI. Well, we tried to look not just on the size and also speed, but also we look about energy consumption and also the carbon footprint. Right, so we can make it much more faster than the one that can be realized through compressor, and also can improve in terms of the carbon footprint. So let me provide you a little bit more details how this method avatar actually works. So this is the overall workflow of avatar. So first of all, we need to identify the configuration space. So a large language model has a lot of configurations, right? So they have a lot of hyperparameters. We set different values to those hyperparameters. The model size can either be so big or it can be very small. Right? And then it forms this configuration space. And then what we want to do is that we want to try to see if all the configuration space is valid or not. Because we want a small LLM, an LLM of size 3 MB or less. So not all configuration space will produce an LLM of that size. So what we did is that we used this SMT-based method to prove through the search space so that we get a much smaller search space to look at, right? And then the next thing that we need to do is that we want to build this efficacy indicator. We want an LLM that is small, that is fast, that is green. But we want an LLM that also works. So we don't want an LLM that is small, green, but can't do anything, accuracy is 0. We don't want that, right? So we need to also estimate to what extent can that LLM works. So we want an efficacy estimator or indicator. And we want this efficacy indicator to return us an estimation in a split second. Why do we want to do that? Because otherwise, we have a lot of configuration, even in the blue configuration space. If for every one of them, we need to train an LLM, we need to evaluate the LLM, then it will be very costly. So what we want to do is that we want to use this efficacy indicator, and then just given the configuration, make an estimation to what extent the efficacy or the accuracy of the model will be on the target downstream. Right. So after we have these two things, the next thing is that we want to search through this blue configuration space. So this is a search problem. It's a multi-objective search function because we have a few objectives. We want it to be small, we want it to be fast, we want it to be green. We also want it to be effective enough, right? High accuracy scores. And there may not be just one solution that outperforms the rest on this configuration space. So what we get is that those solutions that sit on this Pareto front, right? So all those Pareto optimal solutions will outperform the other solutions, at least in terms of one out of the many objective functions. So and after that, we use this configuration in this Pareto front to initialize the configuration of a compact and green code LLM. And then after that, we use this process referred to as knowledge distillation, so that the small model can learn big model. I leave the details to you in the paper if you are keen to read them. I'm just going to provide a few information on some of the key steps. So one thing is this. So this is the configuration space. So this is the various hyperparameters available. And then if you try to enumerate all possible combinations from this space, it will be 4.5 times 10 to the power of 19. Right, so it's a huge space. Right, we cannot possibly try every single one of them; it will be too costly. So what we do is that we try to create an equation, right, that will approximate the model size, right, in terms of many other hyperparameters. And then after that, we have the constraints in which we want the size of the LLM to be less or equal to 0. Right, so we just solve this constraint using SMT solver. And then what happened is that we can prove more than 70% of the search space. So for this 70% of the search space, we don't need to do anything, rather just focus on the remaining 20%. So for the remaining 28% is a search problem. So we use a variant of genetic algorithm, and we want to optimize this 3 different objective functions. The size of the model, the number of floating point operators, which corresponds to the inference latency, energy consumption, and carbon footprint. And another thing is the efficacy of the model, right? So we want the model to be as effective as the big model as much as possible. Okay. So also this is the knowledge distillation process. So basically we want to minimize this loss function. So we have 2 models, one that is small and one that is big. We give them the same input, we observe the output, and we want the output to be as similar as possible between this big model and the small model. So this is how we train the small model so that we can learn on the big. So these are the results that we get, right, that I mentioned earlier. Another thing is that the efficacy drop is not so much, it's just 1.67% for that 2 tasks, right, vulnerability prediction and code detection. And also the throughput, if you put it in the server, right, you can process like close to 10 times queries than the big, right? So this is the results that we found. Of course, things are still open. There are many things that can be done. For example, we need to look at more SE tasks. We just look at 2, there could be more. We just look at 2 models, the lightweight one. There are many bigger code models out there. And also there are many other LLM acceleration methods. Like for example, we see there is a paper on dynamic model inference. And also there is also potentials to incorporate static program optimization as well in order to optimize the inference time of LLM. So we focus a lot on inference, but there's also a problem with training. And there also maybe one way to reduce training time is by selectively picking data that can help train better LLMs. Right, again, we put some reports in writing, and we presented also in Brazil. So if you're keen, and I hope many of you will come to Brazil, please come to listen to this talk as well. So I've talked about these 2 different things, and I'm gonna talk briefly about the last thing, about the security of code. So LLMs provide a lot of promises, but also there are also hidden dangers, there are perils, and we need to be aware of them. And then we need to also do things to mitigate those problems. So this is based on this work, stealthy backdoor attacks for code models, done together with Jay and a few others. And then in this work, we are actually trying to deal with this problem called poisoning attack of code models. And the poisoning attack works like this. So there could be a malicious person, right, putting a code that has been poisoned on GitHub, maybe paying people so that the code can be promoted. A lot of people like the repositories, right? Star the repository. And then this unsuspecting model developer will just grab all those repositories with the high stars, right? And then learn the model, right? And everything will work out well. It's just that that model will have a backdoor. So what's the problem with the model with a backdoor? So the problem is this. So in malicious people actually provide a certain kind of input, referred to as a trigger. Then this malicious backdoor model will produce a malicious output. Otherwise, it will produce a benign output, right? So this is the problem with backdoor attack or poisoning. So there have been a number of work in the literature. So one in the SE community, one in the ML community, that talk about this problem affecting many software engineering tasks, including code search. One issue that we found is that this work usually consider triggers that are basically inserting date code. So if it is a fixed trigger, the trigger is inserting the same date code, right, at different parts of the code base. And another one is a grammar-based trigger. It inserts pieces of date code that come from a particular grammar. Right, so if you are a developer, you look at this, date code may not be too natural, especially the date code that looks alike, appearing many times in the code, but that may not be very natural. So what will happen is that we actually plot the distribution and find that those poison examples can be easily detected in 99%. Right, so this may be good news, like maybe people cannot attack code like this because these type of attack can be easily detected. But is it really true? Is it a false sense of security? So we set out this work to see if there is still remaining problems there. So is it possible to create a stealthy backdoor? And if it is possible, we want to tell people so that people can be aware of this problem. And to demonstrate this, we create a solution referred to as an afraid door. And what happened is that it has these features. So one of them is that rather than injecting date code, not so natural, what we do is that we actually rename variables, right? And then the good thing about renaming variables is that first, it is more natural than injecting date code. And second thing is that variable locations are distributed everywhere in the code base, right? So we have some randomness there. And thus this design is more stealthy. Another thing is that we made use of our SE2024 paper to generate variable names in an adversarial way. So meaning that we don't put any random variable name, x1, x2, x3 as a replacement, but rather we pick variable names that are close in the semantic meaning use. Right, so that's what we do. And then we demonstrate that using this method, we can actually do many of the defenses. So a lot of defenses actually no longer work when we consider our stealthy backdoor attack. Right, it's much harder to be automatically detected. And also we do a human-based study. The human-based study actually find that the poison example is also much harder to be manually detected. For example, take a look at DR, which is the detection rate. So when human actually look at the poison examples and non-poison example, and I try to identify those that are poison, the detection rate for failure is just 4%. While the detection rate for the poison example by the fixed and grammar-based method is close to 100%. Right? So we highlight that there is this problem, right, with the backdoor attack. And thus there is need for more work. For example, looking into novel attack vectors that wasn't considered before. Right, we want to tell the community about it so that people can take action against. And also we need more effective data auditing tools. Because at the moment people just collect data, maybe use a certain kind of a GitHub stars to filter repositories, right? But there are more things that can be done. And there's also a need for this trustworthy LLM for code ecosystem, because it's not just one model, one data, they form an ecosystem. So recently we wrote a bit about this, the ecosystem of large language models, and there's need to look into these ecosystems and try to make sure that it is safe and secure. So I still just have a few more minutes. I'm just gonna summarize. So I talk about the efficacy, efficiency, and the security of code LLM. For efficacy, my message is this. So it's great to look into model innovations, right? But often we have a problem. We don't have enough GPUs to do that. But sometimes rather than looking at model innovations alone, you want to build bigger, more complex model, it will also be good to look into data innovation. Sometimes we can change the data and we have the domain knowledge on that data. And then we can use that data to make the LLM look better. And rather than just focusing on one LLM, now we are open for choices. There's so many LLMs out there, the small one, the medium-sized one, the big ones, right? Could we use them together in a collaborative way? Of course, the question is how to make them collaborate. And the second thing is about this efficiency. I think more work needs to be done on this. So we can make the existing models smaller, faster, and cleaner. But this is just for one type of LLM, right? There are many other types of LLM available out there. We have not made this working for a encoder-decoder model, right? So there's a lot of work that can be done here, and we're just focusing on the classification task or generation task. So we have not been successful yet, and a lot of work is needed here and can be solved with collaborative. And then this one is highlighting the perils, right? There's these dangers of a backdoor attack. So we want to have some policy to ensure that we build an LLM using open source data, it is secure. And also we have some solutions to deal with this problem corresponding to a stealth feedback program. So I think we are living in an exciting time. So maybe like the early 1900s for aeronautics. Do you know what picture there in the background? First flight, right, by the Wright brothers, right? Do you know how long that flight lasts? 1 hour, 10 minutes, 1 minute, 20 seconds. It's just like 800-meter, actually 12 seconds, right? So then we need to land back to the ground. A lot of problems. So today, I think LLM, we have many success stories, but still have a lot of problems. But with a lot of collaborative effort, I think we can make this a reality so that we can build the future software for the benefit of the people. So I'd like to acknowledge, thank you very much, SEMLA, for supporting me, and also the group at the SMU. Many of these are their work. And if you're interested to visit us, please just contact me. And we're very happy to have you visiting us in Singapore, especially when it is winter here, very cold. Singapore is always warm. So please come and visit. Thank you. We will have a couple of questions. Thank you for your talk. It was really interesting. The one aspect that I confused about is when it comes to poisoning talks, what would one probably what would someone ask think from I see. That's a very good question. Like, what is like the tech scenario? So I think that some of the tech scenarios could be like maybe when you are doing you have a competitor, then you know that the competitor is using a certain LLM to recommend code search for example. And you poison the data so that what happens is that every time they search a code, what happens is the recommend code that has been proposed. So in that sense, you can hijack the problem you can see for your competitor. So that's fine. So it's sacrifice sacrifice. Perfect.
Okay, so thanks for your like so we didn't see this amount of reduction in the like model size and the carbon footprints per city. So I'm wondering, so how does this reduction of model size impact the by for example the generalizability versus other reading?
Yes, that's a very good question. So there is a catch here, is a trade-off. So the big model tend to be general purpose, can do many different things. But the small model is specialized for one task, for example, vulnerability detection or clone detection, then it can be able to do that well. So it's like the big model has a lot of neurons, and those neurons may not actually all be necessary for one task. So by compressing the model, we can make it specialized for one single task. It's good for that one task, but if you try another task, then you
Thank you.
Yes, thank you.
Actually, President, well, thank you for the presentation. It's really great. Small question about the security aspect was, I was wondering how would you think of obfuscation code on the triggers whereby if we obfuscate the code before we get it to the LLM, what impact do you think it have on the effect of poisoning on the
Thank you very much for the nice suggestion. We have not tried like obfuscation as a way to break this attack. Right. So we do not know what whether that attack will still translate and just obfuscate everything. So we have used all the data, but before we use it, we obfuscate that. But there's also this trend that if you obfuscate all the data, then maybe the LLM is not that good because we inject a lot of noises. So they may not be able to produce code that looks natural. Just to obfuscate it would be unnatural with a lot of data. So
maybe there's a threshold between how much obfuscation I involve installation and attack.
I believe so. I think there needs to be like a nice balance, like how we can combine the data together, or maybe make the model less susceptible to things that and not see the food. So that's one thing that we look at, how we can change the loss function. Create a box.
Even out to realization.
Yes. That's, I think that's an interesting future direction. I hope you're interested in moving with solving this security problem.
Thanks, David, for the presentation. I'm curious about how the efficiency works. So if I understand correctly, this slide, start big model, automatic, and end up with a small model. This is a specific task, right? So in this case, I think it's right. So assume, I don't know, 6 months from now, we have no time to build everything from the initial model, just frame or small model. So now what do? You need to rerun the pipeline? Is it costly to run this whole pipeline? Is there anything you can do maybe in terms of in-office learning and adding examples to the smaller models? So how would you basically deal with the data that's seen?
I think that's a very good question too, like how do we deal with the evolution of data? How do we update the small model? I think we can work the whole process here, which is not too expensive actually, but it's not like cleaning the big model from scratch. We take a couple of hours, so that's the possibility. Another possibility could be maybe we just update the small model. But we haven't tried which one actually is working well. The thing is that very nice setting that it is fine. And another possibility is that we are recently looking like hot fixing on. So people hot fix code, right? So basically they try to break, fix the things that break into code when code is running. So we are developing something to hot fix models actually. And then, but we have not really tried it with the overall changes. We recently tried so that it does not use code that are bad or code they should have code learn is a good example of not the bad example of fixed code. But which one of these three actually works best in the scenario that you mentioned? Between more experiment.
Yeah, cool, thanks. Yeah, I just asked is to make it more efficient. So you need to retrain any time there's a cost to that as well. So I was trying to figure out cheap ways to fix it.
I think like few weeks ago, I attended this workshop. There's one person actually sharing that there's different costs, like training costs and also inference costs. Training cost is usually very huge, inference cost is very small. But the problem is that we do inference billions of times every day. So the small cost is built up, and in the end, the inference cost is much higher than training costs. They consider the aggregate cost like that.
We have two more questions. Sorry for the time. Yes, please go ahead.
Hi, my name is Jen. I'm an associate in California. Thank you for the talk. I actually want to know more about when you use an information elements and you want to find a more fixed. So how do the elements work? Was it data system and why is that such a good?
Yeah, I think that's a very good question. I didn't have time to go into detail, but we're happy to share like high level things how it works. So what happened is that we have two kind of features. One is like we consider more data, and that's boost performance. And we also consider multiple LLMs that boost performance. So the 2 times improvement is not just having LLM working together, but also looking at the data. And we also need to understand the characteristics of those LLMs. So what happened is that we find the general purpose LLM is very good. It considers a simple code example that has a vulnerability, and it has a detailed analysis as to how that vulnerability happened. So if we have those cases, we can produce a very good repair. Like this general purpose LLM, for example, are there examples of vulnerability that are simple and comes with detailed analysis? And then here it's CWE. So CWE has a lot of examples of broken code that has vulnerability and a lot of analysis of why is it broken. So we need to adapt to the LLM that is general purpose that you apply, then we get fixes in our. right? And then we use that information to train a much smaller LLM that is specialized for the possible. And we find that by this collaboration, the result is better because we consider the strength and the limitations of each. But that's just one way. There are many other ways to do it. This is just two LLMs. There are 50 or hundreds out there, thousands out there. How to make them collaborate together? It's still difficult. Thank you.
Hi, Professor. I'm here. Hi, my name is Rashna. Thank you for the wonderful talk. My question is because efficacy, you mentioned that while detecting, while fixing the vulnerability, there was a problem that the data was less. And this is always the case in software engineering, that we have very good ideas, but we restrict ourselves because we do not have specific data with that. And we are in the world of LLMs. So, do you think we can use LLMs or that with limited data and knowledge we have to generate synthetic data, and it can help evaluate or test our ideas on implementing software engineering problems using the synthetic data? Can we do it, or is it not applicable in the software engineering research world?
Yeah, I think that's a very good question as well, very good direction. I think we recently also very keen using synthetic data. We tried with a number of LLMs to generate synthetic code with vulnerabilities. And we find some LLMs actually performing better than the others. And we also do a human study and then find that, yes, those vulnerable examples are correctly rejected. We also try to test whether we can detect those vulnerabilities and find that, yes, we can detect them. However, we try to use them to learn a model that can detect like on the wild vulnerability. Sometimes the improvement is not so much. So we still do not know the answer to why it happens. Sometimes, like my previous experience, we have another project that trying to infer this, basically what we learn from binary code, and then try to understand this control flow integrity. So we want to infer like this function as many parameters. So if people tamper with the binary code, then that signature is no longer preserved. And then sometimes the method has one parameter is very common. A method with 2 parameters is very common. 0 parameters is very common. A method with 20 parameters very rare. So we don't have data. So we syntactically generate data and let the deep learning learns. But the problem is that the deep learning learns our pattern. So there, that's what works. So the problem with synthetic data is that the way we generate synthetic data, we have a certain pattern, and the LLM doesn't know. We learn from those patterns. And then at the end, we think it's not able to do its job. So I think it's a very exciting direction, but we need to make sure that the LLM that we train is not biased to the features that we find.
Those scenarios, software engineering that we want to test.
Yes, so we want to make the synthetic data really capture distribution from the real data. And or we make the LLM ignores those characteristics in the synthetic data. Do that, any questions? A lot of exciting questions.
Okay, thank you very much.
Yes, thank you. Thank you, everyone. Thank you, Professor David Lowe. So let us welcome our next distinguished speaker, Lin Meng Zhang, who is Associate Professor in the Department of Computer Science at the University of Illinois, Urbana-Champaign. So he's the recipient of the SEM SIGSOFT Early Career Researcher Award, NSF Award, Career Award. He has received multiple SEM SIGSOFT Distinguished Paper Awards and many other awards with collaboration with so many companies, including Samsung, NVIDIA, Meta, Amazon, Google, and so many other companies. So he will be talking about crystal clear code, LLMs, Star Code 2, and Magic Coder. So Thank you. The slides are ready.
Great, thank you.
Yeah, so the floor is for you.
Can you hear me back? Okay, great. Thank you for the very kind introduction. I'm very happy to be here to talk about our recent work on towards crystal clear code language models, Secretary 2 and Magic Coder. And I'm Li Minzhang. I'm from UIUC. Although I'm from I work at UIUC, but I flew all the way from Shanghai to here. So it took me 20 hours to get here. So I'm quite excited to be here. Okay, and as we know that software nowadays is everywhere. So from smartphones to air-file control systems, which is great, right? Because they can make our life much easier. However, bugs are also everywhere. So they can delay our trip, crash our cars, or even crash our airplanes, right? So according to recent for example, software bugs cost us over $1 trillion every year and can affect billions of people all over the world, right? So how do we eliminate bugs, right? So to do so, let's take a look at a very simplified software development cycle. So how do developers build a system? What's the typical process, right? Well, first, developers need to first generate code, right? Well, we are human beings, so we make a lot of mistakes. We also generate a lot of bugs while writing code, right? And because of that, we need to spend time to find those bugs or fix those bugs. And unfortunately, this is not a one-off effort. This process got repeated again and again during software build cycles. Right? For example, for big companies like Google, Microsoft, Meta, they can have hundreds of thousands of such build cycles every day. And developers need to spend a tremendous amount of time dealing with all those tedious tasks. Right? So, well, then how do we automate those tasks to make life easier for the developers? Right? So, luckily, in the literature of software engineering and the relevant areas like programming languages, people propose a lot of techniques to automate those tasks, including program synthesis techniques to generate code directly from scratch, program testing techniques, analysis techniques to find bugs, and also repair techniques to fix bugs, right? But of course, that is not the focus of today's talk, right? So, and given the extremely popular language models, we can ask a question. So, how would recent language models change the game, right? So, and before we go ahead and try to introduce our work, let me just also briefly introduce the basics about language models. Just two pages, very simple introduction. So these just models that are assigned probabilities for token sequences. So they are typically now built with the transformer architecture with the attention mechanism. Right? I can give you a very simple example. So if I want to model this program statement, so what does that mean for a model to model this statement and even to generate such a statement, right? So, well, everything is just about probabilistic computation. So for example, if you want to generate this statement, it's just about generating the tokens one by one from left to right, right? And for example, what's the this probability would be the probability for producing the first token and then producing the next token, but then the first one, the last one, but the earlier two. So one by one. When we produce every token, you basically pay different attention to the earlier tokens because they may have different ways on deciding the next token. Right? So for example, when you compute the last token plus one, we may want to pay more attention to variable. Why? Because we are sending out one and a variable, because we have to be type compatible, right? So luckily, those models, they are able to basically capture such subtle relations, right? So that's the basic idea of language models. And you may be curious, right? So this kind of basic idea to use probabilistic computation to model token sequences has been here for 7 decades. Even the N-gram model have similar ideas, right? So what made those language models large and powerful, right? So first, I think they are trained with the huge number of parameters based on the scalable transformer design. For example, across the years, and David also showed a very nice figure about the trends, right? So around the years, we are having bigger and bigger models, right? Just this year, Jason Huang just confirmed in the NVIDIA GTC day that the GPT-4 model really does have over 1 trillion parameters. So we have huge models. That huge number of parameters can really store massive and compress massive information, right? So, and they are also pre-trained using large amounts of data. So for example, they can be pre-trained on trillions of tokens from various sources, including Wikipedia, GitHub, online discussion forums, right? And those kind of massive pre-training can really help the model to learn a lot of common sense information and also basic knowledge, right? And because of that, the models also developed emerging capabilities. We can do some planning, do some reasoning, right? So, and they also show impressive performance in programming, especially generating simple programs, some toy programs, algorithmic programs, right? So our question is that in my group, we asked a question that can language models really help with the quality assurance of real world system, not just toy programs, right? And inspired by this question, so we started looking to the direction roughly 3 or 4 years ago. And this is all like a brief overview of the work we did in the past 3 or 4 years. So mainly three different directions. The first one is about how do we apply language models for really important but challenging software quality assurance tasks. For example, testing, analysis, verification, repair, and synthesis, right? So our work in this domain has found a lot of interesting bugs for diverse types of software systems using language models. For example, we found a lot of interesting bugs using language models for compilers, like constraint solvers, Go tool chain. Like this stuff is a quantum computing system and also Linux kernel. So this is one direction we are looking to, basically applications of language models for software quality assurance. And the other one is the opposite question. So how does software quality assurance, Earth, the software engineering people have been studying for decades, how that work for the language model side, right? So we look into how to use the traditional techniques to ensure the quality of the language models themselves and their low-level system support, including deep learning libraries, compilers, and so on. Right. So, for example, our recent work like Evo Plus has been used for more rigorous evaluation of the recent code models have been used by a lot of people, a lot of groups all over the world, got almost 1,000 staff on GitHub. And also our work on ensuring the quality of the low-level deep learning systems have found a lot of interesting bugs for really popular systems. For example, we have found over 800 bugs for popular deep learning systems, including PyTorch, TensorFlow, for ONNX runtime, TensorRT, TVM, you name it. All those different important deep learning systems. And also, like one example is that for PyTorch, which is probably the most popular deep learning framework nowadays, right? So we found like over 10% of all the high priority bugs for PyTorch within a period of 8 months. And so the last kind of direction is that to support better software quality assurance, so we start to build our own code language models, right? And because we also want to ensure the quality of the models themselves, right? So we release everything about our models, release the architecture, training pipeline, pre-training data, instruction tuning data, and all the ways, everything. So it's different from the so-called open source models. When people talk about open source code models, they are really meaning the open weight models, because a lot of open source models, they only release the weights, right? While for us, we release everything, all the pipeline, all the data we have. And our work has been used by people all over the world. And for example, our Stackcoder 2 and Magic Coder work has been started for over 1,000 times on GitHub. Wait, why is this issue? Maybe there's still some compatibility issue on this, even I'm using Google Slides. Sorry about that. There should be some compatibility issue with the hardware. I don't know, somehow. Anyhow, it's stuck. So forgive me on that. Yeah. So and more recently, so big tech companies, they are also trying to use our techniques to pre-train or fine-tune their own models. For example, the very recent Google CodeGamma models, IBM Granite models, and even the Stackcoder 2 models, they are instruction tuned using our Magic Coder idea. And a lot of other teams like Medical Llama teams, Snowflake, Arctic teams, and even some other teams, they are also using our Magic Coder idea to generate more instruction tuning data to fine tune their own code models. So that's a brief overview. And from the title, you can see that this part is the main focus of today's talk. I'll just go ahead with that. If I have time, I'll also briefly introduce our recent work on applying language models for software quality assurance. Okay, and let's just jump into the first direction. So how do we build fully open source, transparent, or crystal clear code language models, right? So let's begin with a brief summary about the current status, of the state-of-the-art code models, right? So there have been a lot of hundreds, if not right, code models all over in the world you can use. There are proprietary models from OpenAI, from Google, from Anthropic, right? And there are also so-called open source models. So you can see that those models, they only have the model weights available. They're not releasing their training pipeline. They're not releasing their data. So just the weights, just the model itself, right? Of course, there are stakeholders who release their model and data available in the past, but still it's a pretty old model nowadays. So to summarize, there's a lack of fully open source powerful code models, and which can be problematic because it hinders a lot of different research, right? Like model replication, enhancement, interpretation, decontamination, quality assurance, and so on, right? It's just like black magic to people, even you release the waste, right? So a lot of details are missing. So, and they mostly focus on mainstream languages, like at most any language also for for the open source open waste models. And what about low resource languages like emerging languages and so on, right? And also they mainly focus on the source code like completion task. What about like LVM IR, for example, right? And also they have limited cross-file dependencies. I'll show you what it is about later. And a lot of issues about that. So like inspired by all those questions, so we start to join the big code organization. So, and we built the like next generation of Starcoder. It's called Starcoder 2. And also we built the next generation of the Starcoder 2, like a pre-training dataset we call the Stack V2. So this is the overall design for Starcoder 2. You can see it's just typical decoder only design with a lot of new optimizations, right? And we also built a new dataset called the Stack V2 based on the software heritage archive. So we cloned like over 60 TB permissive code, where we filtered all the code using copyright information, and we also deduplicated the code information we have, resulting in like over 30 TB data, right, which covers over 600 languages. And we also include, besides the like GitHub open source code information, we also include a lot of other information like LVM, IR information, GitHub issues, pull requests, and so on. So, based on all those massive data, we train a series of models from 3B to 15B, using over 1,100 or H100 GPUs. And this is the overall statistics for those models. And with this, like GPUs are generously supported by ServiceNow, Hugging Face, and NVIDIA. Okay. So this is a typical overall design. I'd like to talk about some details about within the design. So one thing I want to talk about is about the source code representation, which is very, very important. So how do we like tokenize the source code within the open source projects, right? So I can talk about first the traditional way in Starcoder 2 and almost all the other code models. What they do is that for every single file, so like from one project, they just mix files from different projects altogether. Okay, so that's why in the representation you can see that for every file we include all the information, including the basic repository name, file name, code information. So every file gets this information, and they all get mixed together. And so this is the basic idea. So when you pre-train the model, you do the next token prediction, and the files in the context, they are not necessarily from the same project because they are all randomly mixed up. So they can be from different projects. So as you can see that if you do next token prediction using this style, there's like you can hardly capture cross-file dependencies because the files in the context, they may be totally irrelevant to a current file, right? That's why you can hardly capture the dependencies, across different files. And because of that, we actually initiated another design. We try to cluster, very simple idea, but it works very well in practice. What we do is that we cluster files within the same repositories together. Okay, so for example, when we represent the files within the same repository, we have the repository name, right? And then we have all the files like listed under the same repository. So in this way, when you do the next token prediction, which is the main task for pre-training, you will see that the other files within the context, they are very likely from the same project. And what's the impact for that? Doing so, you will be able to capture a lot of different connections when you predict the next token, because all these files, they are now highly relevant. So this very simple design can force the model to really capture a lot of active connections, can make the model to be more sensitive to the information in the context, can be more powerful in performing long context completion, long context applications. So very simple idea, but it works very well. And the next thing I want to talk about, besides like open source project, besides source code, we also provide a lot of extra training data, including like GitHub pull requests, like Jupyter notebooks, Cargo notebooks, documentation information. So they are all in terms of a billion tokens. Okay. So for example, even the category with the smallest volume, like even documentation with only 1.6 billion tokens, they still include a lot of information. For example, we cover all the documentation for over 10 like popular package manager platforms such as like Python package index, and like even npm and so on. Then it also includes thousands of programming books. So really a lot of information passed into the model. And one special case I want to talk about is the last one, intermediate representation. So we try to, besides source code, to also fit fit the model with some code in some intermediate representation, like for example, LLM IR information. So how do we do that? So what we do is that we generate over 4 million self-contained. We found over 4 million self-contained compilation units, accepted solutions, to the programming problems, and then we randomly 50% is source code to IR, and then 50% IR to source code, so that we can understand the back and forth translation number 2, right? So how do we prepare all those LLM IR information, because the source code can be from different languages, right? So we build some infrastructure. So for example, we have a intermediate layer, so where we have all the different compilers, and for different languages, we can feed them, we can pass them into different compilers to compile into the corresponding LLM IR information. So this is the overall design about how we get this massive amount of LLM IR information, which is non-trivial. And this is an overview about the results. So we have studied Sakura to diverse number of different tasks, including code completion, code reasoning, data science, mathematics, computation, repository level, completion tasks, and so on. So we can see that Sakura 2 basically it achieves a state-of-the-art performance, when compared with models with similar sizes, all those different tasks. And we also released the full set of the pre-training data set for Sakura 2. So if you're interested in pre-training your own models, you can try the data set. It's called Stack V2. So, and which is the most comprehensive code training data set to date, so covering over 30 TB data after duplication. And to date, the Sakura 2 model series have been started for over 1,000 times on GitHub, has been downloaded for almost 500,000 times from Hugging Face. So if you want to use some open source models, which is small, fast, but still powerful enough, feel free to try out Sakura 2 in your project. Yeah, so this is all basic idea, process for Sakura 2, and it's a series of base models, right? So, and one problem with base model is that, say, I can definitely, after getting the base model, I can definitely ask the base model to complete some tasks, right? So I can give it some prompts, right? Okay, maybe let's assume this is a Sakura 2 base model, right? So create an easy Python coding exercise for me, because they're just pre-trained on massive coding, code or natural language data. They don't have the capability to exactly follow the natural language instructions. So the problem is that if you use the base model, they may just give you something which looks okay but useless. So if you want general exercise, they just give you some code, right? So they don't have the powerful support for natural language following. So because of that, people have studied a lot about instruction tuning. So how many of you here have heard about instruction tuning? Can you raise your hand? Hopefully you have. Great. Yeah, if you haven't heard about that, easy. I can introduce you basically very easily. Very simple idea. It's just a type of fine tuning. So the basic idea is that if they're not able to follow natural language instructions easily, okay, how about we just fine tune them based on a lot of pairs of natural language and descriptions and the solutions, right? So that's the basic idea. Very simple. Just fine tuning, right? So you can produce a lot of high quality instruction response pairs, right? And just train the model to better understand, okay, given this type of instruction, what should be the response? And just fine tuning, right? So, and after that, you can get an instruct model. And if you use the instruct model to say, okay, create me an easy Python coding exercise, similar prompt as before, right? Now they can better understand that. Why? Because they've been pre-trained, they've been instruction tuned on a large number of possible instructions. So they know better what they want, right? They can better align the semantics of, they better understand the semantics of the instructions. So in this case, they can generate you a solution, exact solution you want, say, including exercise description and also a solution, which is exactly what you want. So that's the basic idea of instruction tuning. So very simple idea. But then the problem comes to how do you generate this massive number of high quality instruction response pairs? of course, one way is that just manually do that, right? So this is some of the commercial models may have done that, at least for part of their training data, right? But this is extremely costly, right? So what people typically do in the literature is to use large language models to automatically generate instruction data. So, and there have been some existing code instruction tuning techniques. So for example, one of the earliest ones called self-instruct as part of the code Alpaca project. So the basic idea is very simple. Say, I can first like take some manually reading seed instruction response pairs, right? It can be like any different instructions for general purpose, like Q&A or for coding problems, right? I just manually write like 20 of them. And then I could just ask the model to please give me another one, which is follow similar format, right? So this is very easy. So model can do in context learning and can generate some similar instructions, right? So this is one way you can do that. And this is called self-instruct. Okay, it's very popular. And the other ways, but they basically rely on seed instructions to directly generate new ones, right? Well, you can only, as a human, probably it's costly to collect a large number of instruction and solution pairs. You probably just have a few dozens of instruction pairs, and they're limited, right? So that's one problem. So they rely on seed instructions, okay? And the other one is called evil instruct, which is part of the Wizard Coder project, which is specifically for coding. Like this evil instruct can be applied to both general purpose problems or coding problems. And this Wizard Coder paper apply this idea for coding tasks. So the basic idea is that, okay, so once you have some seed instruction data, right, for each one of them, let's evolve that into different ones. Okay, that's why it's called evil instruct. It's evolve instruct. Okay, the basic idea is that given a seed instruction data, say some instruction and some solution, right? What does is that, okay, please add some a constraint to the original problem, right? So please add more reasoning steps to the original problem. And okay, let's change the problem a little bit so that we can have higher time complexity. So all those different rules can help you to create more and more instruction data by just evolving the existing ones, right? So that's the basic idea about that. And for both of them, there are some issues because you can see that both of them actually rely on the models to imagine what is the next instruction data they can generate, right? If you purely rely on the models, well, those models, they are just based on probabilistic computation, right? So they will only generate you the ones that are commonly seen in the training data, in the pre-training data, right? So which is problematic. They have a system bias. They won't generate you diverse, realistic data. So because of that, we actually propose our own instruction tuning methodology for coding tasks. So it's called OSS instruct. The idea is extremely simple. Okay. The basic idea is that we just want the models to get inspired from open source. For example, we can take the Stack V2 data as a reference because the Stack V2 data, so they include a lot of open source projects, right? So we can get a lot of example code snippets from those existing high quality data set, and then we use those code snippets to inspire the model to generate something follow the same test, same content, or same concept. Okay. So in this way, we can generate high quality and low bias coding problems, which is also orthogonal to existing instruction tuning approaches. I can give you one very simple example. So this is the open source code database, right? So we can randomly select some code snippets from there. So probably this is the one we just randomly fetch from the code dataset, right? And what we do is that we pass this dataset and this prompt into the model. Say this prompt is just please gain inspiration from the code snippet to create a high quality programming problem. So you can see that in this way, we ask the model to get inspired from open source code snippet. While the open source code snippets, they are infinite. So, and they are listed and they are controllable, right? So in this way, you can really generate realistic, controllable, and high quality problems. And this is the one you can generate from this code snippet. So you can see that the generated problem is that we are working on natural language processing project, and I need to create a program to pre-process and classify movie reviews. Why they come up with such a problem? The reason is that you can see that there are some
SVM, sport vector machines, name space, right? They have some classified models, right? And there are also some reviews. So they get inspired by those like interesting tokens and create very interesting new problems. So this is how we can use open source code snippet to guide the models to generate really interesting, diverse, realistic, and also controllable instruction data. Okay? And so this is the summary of the magic coder idea. So we basically apply that like to a lot of different base models. This one was performed right on top of the DeepSeek coder base model, and we can achieve a very good performance. Like when considering the size, it's only 70 model, but we can achieve a comparable performance compared to a lot of commercial models. And so to summarize, so OSS instruct is a normal instruction tuning method from open source, and we based on that we build a magic coder, which is a new series code models, which is fully open source, because we release not only the model weight but also the instruction tuning data and even the pipeline to generate such data, right? And it even outperform GPT like 3.5 and even Google Gemini with only 7B parameters. And so for now we got almost 2,000 stars on GitHub, and it got like over 20,000 downloads from Hugging Face. And more interestingly, so recently we saw a lot of code models built on the idea of OSS instruct. For example, the very recent Google Code Gamma model, IBM Granite model, and also big code stability model, they are all built on the OSS instruct data. And a lot of other teams, for example, Colama teams, like Amazon Q teams, Snowflake Arctic teams, Play, Autopilot teams, they have all talked to us, and they also tried to apply like OSS instruct to generate high quality data to instruction tune their own models. And this work was led by my PhD student, like Yuxiang Wei, and it's going to publish at ICML this year. So we're going to present that, I think, later next month. So yeah, please feel free to check out the paper for more details. And since I got some time, I'll just go ahead and also introduce some of our other work applying large language models to really important and really challenging software engineering problems. Okay, and so one problem we're looking to is fuzzing or fuzz testing. So the idea is very simple, basically. So it feeds a string of random characters to a program in order to uncover bugs or vulnerabilities. And the idea is very simple. So basically, you can even implement a fuzzer within one line of code. So this one line of code is a practical fuzzer. What it does is to generate random strings, try to crash your program. And then you can execute your program with random strings generated by the random fuzzer. And for any of the crashes, you can inspect if it has detected any issues, any bugs. Right. So that's the basic idea. And although the idea is very simple, it has huge impact. For example, one project is called OSS Fuzz, initiated by Google in the past 6-7 years, already found like over 8,000 vulnerabilities, over 28,000 bugs across 800 projects, including a lot of influential projects like LLVM, Mozilla Firefox, Maven, Hadoop, and so on. This is just one example. There are specific applications of fuzzing a lot of different downstream domains, downstream systems. So the particular problem we were looking to was called deep learning library fuzzing. So why do we look into this problem? Why do you want to fuzz to test deep learning libraries, right? So the reason is that deep learning libraries like TensorFlow or PyTorch, they serve as the fundamental building block for all deep learning pipelines, right? Including like the very popular large language models, right? And autonomous driving systems. So in the end, they are all built using deep learning libraries, deep learning frameworks, right? You can imagine if an bug in those libraries or frameworks, the consequence can be really serious, and they can even threaten human lives. And because of that, we look into the problem, right? So, and the problem turned out to be, okay, you just need to generate simple programs, random programs to crash to use the API from the libraries, try to crash the libraries, right? For example, if you're going to test PyTorch, you can generate a random piece of code like this one, and then run that using like PyTorch, see if it crashes or not, right? So the idea is very simple, but it's actually extremely challenging. So the problem is that
this is in Python, which is a dynamic typed language, right? It is like a dynamic typed general purpose language. It's not easy to generate valid Python programs, right? And on top of that, you have a lot of deep learning operators, deep learning library like APIs. So for example, for this very simple for the API, it involves such a complicated constraint. We need to satisfy this constraint in order to make this program even executable. Okay, if you change any numerical values in the program, it won't be like executable. So how to find deeper bugs? So it is extremely challenging problem. So to summarize, we need to handle both Python syntax and semantics. There are complex tensor computation constraints. There are other implicit, explicit AI constraints. So very hard problem. And of course, we can use traditional fuzzing techniques, which can be mainly categorized into generation-based one and mutation-based ones. So basically, generation-based techniques, they generate input programs based on predefined structure or grammar, like context-free grammar. So if you want to generate a Python program, you can use the context-free grammar from Python and generate a simple Python program, right? And for mutation-based approach, you don't need to generate test programs from scratch. Well, you can take some existing program, try to perform small mutations, small changes on the input program to create even more diverse ones for testing or for fuzzing. But they both have some limitations. The first one, like generation-based approach, they will have high manual effort to ensure the validity of the created test programs, and they also have limited generation capability. So one example we can have is called SysMIS, which was I think proposed like around 13 years ago, and it's a very classic tool for fuzzing C compilers. In the past decade, the authors contributed like over 40,000 lines of code to SysMIS. But still, it cannot cover all the recent like features of the C language. Okay, and similarly for mutation-based approach, they also require high quality Cs and mutation patterns. Also require high manual effort to ensure the validity of the created programs. So that is, they can even hardly synthesize like Python programs, not to mention deep learning programs, which adds additional constraints like tensor computation constraints, API constraints on top of the Python program, right? So that's the problem. So, and you can see that the traditional techniques, generation-based or mutation-based ones, the problem is that we need to explicitly model all of these constraints and then explicitly solve all those constraints, which is highly scalable. And because of that, so we had the idea of using large models for fuzzing. So the basic idea is that large models, they are trained on trillions of open source code tokens and can auto-regressively generate human-like code. So for example, like on GitHub, there can be over 400,000 projects like TensorFlow or PyTorch projects, right? So you can imagine for a model pre-trained on GitHub data, they can auto-regressively generate valid PyTorch or TensorFlow programs automatically because they may already have all those constraints like learned during the pre-training phase, right? So that's the basic idea. So we use the probabilistic computation in the language models to implicitly model the constraints to directly generate valid programs without worrying about all of those constraints and solving all those constraints. And the basic idea can be applied to not only deep learning systems, but any other systems like in the wild, because the models, they have seen hundreds of languages. So they can have broad impact besides this particular problem we were looking to, right? So, and the design is that, so for generative models, we can like, we just auto-regressively predict the next token, give a previous left-only context. They are typically implemented in a decoder-only architecture. So this is a generative task models can perform. There are also models which can perform infilling tasks. So basically, I can mask out a part of the program and replace that with some placeholder, and I can ask the model to basically infill the most natural token to generate another program, right? So this is so this kind of infilling models, they can use bi-directional context to fill tokens in the middle. So we can consider bi-directional context. So this can be implemented using encoder-decoder architecture, encoder-only, or even decoder-only like models. Okay. So, and they are both trained on trillions of code tokens, right? So they can learn how to directly generate programs or mutate programs in the middle. So that's our basic idea. We use generative models for generation-based fuzzing, and we use infilling models for mutation-based fuzzing. So we are simulating traditional generation and mutation-based fuzzing. People have been studying for decades using large models. So this is a like overall big picture. It's very simple. So we first generate seed programs just using generative models. We generate like a simple deep learning programs from scratch. And then we further jump into the evolutionary fuzzy loop. We use infinity models to further change the seed program we generated to create even more diverse programs for fuzzy. And we use traditional test oracle, like a differential testing oracle. For example, we can find if the deep learning programs have different results on GPU and CPU ends. So this is the overall summary of the work. So this is a project led by my PhD student in London, and which is published in ESTA last year. So this is the first language model-based approach for fuzzy deep learning libraries and beyond. So you can see that we do seed generation and mutation using generative and infinity models. We can achieve high coverage than traditional techniques. We can find a lot of interesting bugs. And this work also has a lot of interesting implications or guidelines for the future work along the direction. For example, it demonstrated for the first time that modern language models can automatically perform both generation and mutation-based fuzzy. People have been studying for decades, while they are fully automated. Okay. And in this work, we targeted the challenging domain of deep learning systems, but it can be easily generalized to other domains. And so this is exactly next work I'm going to talk about. So how we generalize the idea to more domains, right? So basically, this is a fast forward work. So we can directly apply the tiny fast idea to different systems like constraint solvers, compilers, like quantum computing systems, and so on, right? But you need to do manual prompting for each of the problem domain. So in this fast forward work, we want to basically have a fully automated approach so that you don't need to manually perform prompt engineering for different domains. So the approach can help you to automatically decide what's the best prompts. So to do so, we use a multi-agent system. So what we do is that given all those different information available for different systems, we can first use a powerful model like GPT-4 to summarize the most important information to do some planning, right? And then we can generate candidate prompts for the actual smaller generation engine. So then we can run small scale evaluation and to see, okay, what's the quality of the text generated by different prompts? And then we can use the feedback, the quality, for example, the compilation rate, the validity rate, and so on, to rank which prompt is the best. So we can do auto prompting based on dynamic feedback. Then we can select the best prompt for full scale fuzzy. And we'll apply that to a lot of different systems, including C compilers, C++ compilers, GoTorch and Java compilers. And for each domain, we compare our one implementation against dedicated tools for that specific domain. You can see that over half of the tools we compared against, they are state-of-the-art techniques, and over half of them even won some best paper awards or most influential paper awards at some top places. And we found that surprisingly, our one implementation using large models can cover more code than all those dedicated tools, and we can find a lot of interesting bugs for all those systems, including our quantum computing system. So this is a collaboration project with Matteo and Michael from Stuttgart. It's led by my PhD student Steven. So this Steven just presented it earlier this year at ICSI for this work. Okay, and okay, so there are also other like recent work on language models based testing fuzzy, right? So feel free to check it out. It's a very interesting survey of language model based fuzzy, and nice table showing all those, summarizing all those work. Feel free to check that out. And okay, so I'll just quickly go through 3 slides probably on the repair side. So another problem is that how do we apply language models to fix the bugs, right? Rather than finding the bugs. So if you long like a line of research along that direction, and when we look into the problem, the most recent work was like neural machine translation based technique. So then we asked a very simple question. So instead of performing repair edits using neural machine translation, can we directly generate correctly? Very simple question. And after that, we had a serious work, including alpha repair and child repair along the direction. So the basic idea of alpha repair is very easy. It's the class style repair technique. So give a buggy code with some context information. So what alpha repair does is that we take both the context before, context after, and then we also take the actual buggy location, transform that into some comment into the input, right? And then for the original buggy line or buggy function, we replace that with some placeholder. And we just ask the model to
recover, like crack code based on the context information. And it worked very well. So this is the all like basic idea. So I just skip the previous work. And this is result. So alpha repair demonstrated that the first time that basically large models can outperform existing repair techniques people studied for over a decade. And this was published at FAC 22. And this is last work. So after alpha repair, there have been a lot of work on trying to apply large models for repair. But they mostly follow the same pipeline. Given a buggy function, pass that into the model, ask the model to fix it. So a lot of information, important information are missing. For example, there are earlier patches, there are test failures from earlier patches. All those information are missing. Okay, and because of that, actually our idea is to leverage those earlier patch information, test feedback information to help for more guided repair. So that's a very simple idea, right? So, sorry, right. This is okay, and you can see this is a very interesting bug. We can fix bugs that cannot be fixed by existing techniques. And if you compute the cost for current GPT, we can fix every bug within $1 when the bug locations are known. Right. So to my knowledge, that's the first work for using like fully automated iterative repair using large models. And after chat repair, there's been a lot of work along the direction. For example, Google DeepMind have like self-debug, there's a self-refine to apply similar ideas for different domains like program synthesis, test generation, and very recently people have been applying that to like agent-based systems, repair agent, protocol rover, like 3 agents, and other fixed agent stuff. And yeah, so that's pretty much. There's even some like dev company like having some idea of iterative program refinement. And yeah, this is the last page. And so I just want to stop here. So we are in a transition, right? So before language models, they are copilot, but now in the future, there may be the main driver for some tasks, right? So there are a lot of interesting problems, and there are also a lot of issues with the current models. So they're not perfect, clearly, right? So I'm happy to take any questions we have now. Yeah.
Thank you very much. If you have time for a couple of questions, then we will have a break. And we still have another block after the break for this session. Questions?
Thank you for your presentation. So with the one of GPT lower and other models, so I just wonder, so how is the regular user, programmer, and doing the error handling things? Not like a professional software professionals who has providing skills. So what do you think like the current language model is any challenges to cater for this kind of performance?
Yeah, I think like I think there was some simple like interesting studies about like who would benefit more from language models, right? So I think one, if I remember correctly, one interesting finding was that if you are more experienced developers, you may benefit more from language models because like for example beginners, they may blindly trust the solutions written by language models, which may not be always the case. So I mean they are very good to generate like reasonable, legit solutions, but not always correct. Yeah.
Other questions?
Thank you for the interest. So you talked about adding computation operations or deep learning code for these. So I'm just wondering, so I think I asked this question. So in the deep learning model and deep learning code, so only part of the business logic is related to the code, and rest of the logic is basically done by the data or the model itself, right? So do you see that by looking at the code, just can you really design, let's say, effective task testing using the lens?
So I'm not sure if I understand your question correctly. So you're asking about the mutation part.
Yeah.
So how do we perform mutation, right?
No, I know the mutation operations, but just by looking at the code, at the Python code, can we really design an effective mutation?
Yeah, so that's a
model.
very good question. So I think there can be a lot of feature work along that direction. How do you perform effective mutations, right? You can even using large language models to decide where to mutate, and how to mutate. But for now, we just use a random approach. We randomly mask different specs in the code, and then we use models only for recovering different code portions. So we do not use language models to decide which location is more promising. But I think that can be very interesting feature work.
If you're doing a kind of similar work, so we are applying mutation to the deep learning code, and then we are trying to train the model, and we are trying to see whether that model is crashing or something. We're trying to reproduce certain deep learning bugs.
Okay.
But here we can see that code is only part of that whole detailed cycle. So model and the data are also very important.
Yeah, so I fully agree. Like there can be some part of patterns, operators, like locations, they are more sensitive. They may trigger interesting bugs, right? But for this domain, we are looking to different library of fuzzy, right? So it's relevant to the huge database of the huge code base of the different libraries and patterns, right? So one thing we did was that we take some intermediate feedback from the earlier ones, so that we can use some reinforced learning to dynamically decide which location we should look into. So besides that random selection, we also do some reinforced learning to select the most sensitive information. Because if you don't trust the connection between the input program and the huge code database, you cannot have precise prediction which part of the program may be more sensitive for bug finding, right? So we trace those kind of dynamic information for that. Yeah.
Thank you. Thank you.
Yeah.
Thank you for the presentation. So for the pre-training task, how much of the agents required for training?
Yeah, so it's typically even for the 70, if I remember correctly, it's over 100,000 hour GPU hours use H100. So which is a couple more sense if you use small GPUs.
And thank you for open source data set. So in your opinion, what's the suggestion about the community use the data set?
Which data set?
Stake.
Stack V2, right? Yeah, I think there are some other models using the stack. A lot of models actually use the stack V2, stack V1 better because stack V2 was just released, right? So I think it's there are different ways you can build on others, or you can start your own. I know there are some open source models. They do their own collection filtering, right? There are also models who choose to build on stack V2 or stack V1. Can save some effort, but they don't have full control about the full process, right? So it's I think just some personal choice. I see different groups. They sometimes they choose to build on ours, sometimes they choose to do their own. Yeah.
Or maybe one last question.
So my question is about the adoption of these models in IDs because we work on the old code system for software maintenance. So for if I think about from bug prediction to bug localization to bug repair.
Yes.
In terms of bug inducing code, right? So in the past, we used to use different models for each task,
yes.
Right?
Mm-hmm.
Now, if I want to do that things all together using LLMs, so what kind of problems you see in this approach? I made the change in the ID. Now I want to go. I want to go for count, and there is a bug in the code.
Yes.
So you need to first predict the code is buggy, then you need to utilize it, then you need to prepare.
Yes.
But using LLM, I can do everything.
Yes.
right? I don't need separate models. How I can use LLMs for these three separate tasks, like natural.
That's great question. This is also part I covered by the first point here. Basically, so I was talking to Ahmed earlier today as well. So before, like in software engineering, we have a lot of different techniques, like for repair techniques, for localization techniques, test generation techniques, debugging techniques, and so on, right? It seems that we have a lot of scattered great ideas. But now with the language models, actually, we have a unique chance that we can really unify a lot of different tasks for them to boost each other to have even better performance, right? I think this is really unique chance for the software engineering community. And like agent-based like system can be a perfect match here, right? Because you can have different agents for different tasks, right? While they still work together somehow, like the Devon idea, right? So they can somehow communicate with each other. They can be the different agents. They can be the same model, right? They can also be different models. Very likely they can be different models because for different tasks, you may want different models. They have their own strengths. It's not like always one model win all, right? So for example, even for test generation, you probably want different models. For example, you want one model which is very powerful but probably slow to analyze the problem a little bit, to provide detailed information, detailed guidance. For another model which is not that smart, right, but fast enough to perform really extensive testing. So I think for different tasks, definitely going to be the best model for them. And I just believe that a language model framework or the multi-agent framework really bring us a unique opportunity to connect all those different tasks, to automate them even more, like for some of the problems for us. Yeah. Thank you.
Thank you. Let us thank again our guest speaker.
Thank you.
When we have a break, make sure you will be here for the end of the last talk. Thank you.
Oh, thank you so much. So I'm going to a little bit over time. Sorry about that.
10 minutes break and thank
You missed a lot of constraints there. But at the same time, yeah, I think it might be a mistake. Some special process or some right? Me too, yeah, so there are definitely this crazy even the models, just try to analyze everything.
Yes, please, can we share the QR code? Can you project it and tell people before the beginning of next session?
Yeah.
I will tend to do so first, but I want just to make sure if we can put it inside the computer so that before the beginning of the session.
Okay, I talk to Foods.
Yeah.
I'm not sure because I feel it may not be a face to.
All right. But I think I already talked with him and he said that he's going to sleep, but I can talk with him again.
Yeah, so yeah, I think it's a nice better to nice Julian. I would say awesome. Well, yeah, please. I know was I had a mailing list. I have the email.
We have it.
Yeah. That's another way.
Yeah, that's another way.
Yeah. That might be another way. I feel it's to send the personal email. Send an extra email. Take a minute to because we turn here. I don't think there are many people who actually do it. And the send email is permanent.
Yeah. Do we have it? The email list of attendance. You can do that like that. So I can prepare an email and then you can send it. Right. Okay. I will
also talk to people at personal.
Yeah. Okay.
Whether it's nice. But yeah, it's better. It's better. Weather is better. City is also nice. I mean, the sea and beach are very close. And lots of rain. Lots of rain and still raining sometimes. Middle of January. Sometimes we get at the end of the December, but yeah, mostly January, February. Yeah, I know. I have seen it. So yeah, how many students do you have?
Yeah, also I have some students. Yeah, we started with new cases.
So you recently got professor?
Yes.
Yeah, I'll be applying for tenure this year.
Oh, yeah.
Applications. Thank you. I hope the
That's matter of administrative process that we have to go through.
I hope the committee sees in that way.
Yeah, that's a formality.
So so I know you work lots of visual and which can
Like for
be presenting the last talk about algorithmic fairness from traditional ML to foundation models. So let us welcome our guest speaker.
Thank you for having me. Can you hear me? Well, yes, you can hear me. Yeah, okay, awesome. Because I'm super tired now. I'm just trying my best to have the energy. And I'm sure you're all also the same. It's the last talk of the session. So I'm going to talk about algorithmic fairness from traditional ML to foundation models. I always start with the question of what is the importance of algorithmic fairness? I'm always explaining, but for this audience, I thought I don't need to explain. Who actually know already what is algorithmic fairness? Can you raise your hand? Not many. I thought you should actually know. So algorithmic fairness is a topic that I'm going to talk today, which is technical approaches to mitigating discrimination in ML models. It's a relatively new field. And just a disclaimer, algorithmic fairness is not about the technical approach only, while in this talk, it's going to be a technical approach. And it also include other aspects like investigations for journalism, auditing, community organizing, and I'm not going to talk about those in this talk. I invest a lot of time to create this slide for giving you the history of algorithmic fairness, which is somehow started in ML, because fairness is not a topic just for machine learning or computer scientists. It's actually started in ML around 2014, which was a call at the time that Obama was the president in the US for the harms of algorithms. It was the area of big data, right? They're kind of let's check if there's a harm for different people. There was funding. And then in 2015, you're starting seeing that people at a time they were kind of focusing on applications for ML in different fields. And then they're observing there are impact on people. And they started, for example, Amazon case. I'm not sure these cases I actually put here. They are the most viral cases for algorithmic fairness. Have you seen them, these pictures already? No. Okay, so this one, it's in 2015. Amazon had the advertisement for job, and it's been shown that this actually targeting women for the low paid or non-technical job. The reason was Amazon kind of trained it based on their own data, right? And they were kind of mainly white male, right? And they couldn't kind of address that, so the tool was kind of removed. Then we were seeing kind of the cases of fairness in policing, law enforcement, that there's more common at the police going to the neighborhood where Black people are living, not because the crime rate is higher, because the algorithm actually keeps sending them to the same neighborhood, and they're collecting the data and they're creating this kind of feedback loop, right? They're kind of sending the police to the same neighborhood. Then we have Compass, which is the very viral case of the software that is for risk assessment that is used across the US courts. And judges are relying on the score that they're getting from Compass to judge about the people. And they could actually sentence people to jail for 2 years. And there are cases, kind of the ProPublica article about this in 2017, that we talk about how racist they are because the score is higher for African Black community. And then we have also the case for the face recognition technology that this person was an MIT researcher at the time. If you don't know her, she is Joy Bovini. And she actually was researching about face recognition technology, and she recognized that this technology are not recognizing her face. So she had to put the white mask on her face for this commercialized face detection technology to recognize her face. It started actually a movement for banning face recognition technology in different countries. In California, they actually kind of had the ban. It still is used for law enforcement. Then we started seeing kind of like these measurements for word embedding. People kind of starting kind of talking about the fairness measures because the motivation was kind of like we have law against discrimination, but how we can translate it in machine learning, how we can come with the mathematical notation. And they started the movement of like people talking about like what is algorithmic fairness measures, right? So for a while, people are discussing about the measures, and then people started talking about, okay, so we do have the measures. What we can do about it is kind of using it for mitigating this kind of discrimination in machine learning pipeline. We started having conferences dedicated to this topic like FACT or AIES around 2018. Before it was mostly workshops. And now in the major AI and ML conferences, you see that algorithmic fairness is one of the main topics because of the impact on the society, because ML is actually used across different fields and businesses. Then we started seeing kind of like tools for assessing fairness based on the measure that people are coming up with. And then we are also seeing applications different domains, right? So for example, fairness in healthcare, fairness in recommender system, fairness in finance, and then also in other domains, kind of language, vision, etc., etc. You see that 2018 was kind of the birth, when the birth came to the market. And then in 2022, at the end of 2022, something happens that we all are aware of, ChatGPT. And then it actually changed the game. So then we are seeing kind of like more bigger foundation model coming to the market. What I want to talk about is that the field has 10 years of history. What we learned from this 10 years of algorithmic fairness in ML. So from the algorithmic fairness measures, what we realized was we have different measures. There is no single measure that can satisfy fairness for all fields. Fairness is context dependent. You have to define it based on the subject. So you cannot define fairness for healthcare similar to the fairness for loan approval. It is very different context. The context is not just about the task, but also about the society in large, because you also need to understand the law. So healthcare in Canada, the policy is very, very different than the US, than in Europe, right? So even for a specific task, you need to define it, but also you have to look at the policy, the law, etc., etc. So there is, sorry. Oops, can I go back? Yeah. So fairness is a social technical challenge. It's no free lunch. It's subjective. You cannot have one notion that can satisfy everything because we started having this impossibility theorem in fairness. So people started showing that the definition that people are coming up with, they are not compatible with each other. We started seeing different groups of fairness notion, individual fairness notion, group fairness notion, a statistical fairness notion, causal fairness notion. And then we get to the era of mitigation. So how we can use this notion. So we specified that we have to select a fairness notion for that particular task. So how we can actually mitigate it. So people started thinking about the machine learning pipeline, and they kind of like saying that bias can appear throughout the pipeline. So we have bias in the data is unbalanced, we have historical discrimination, etc., etc. And then we have algorithm that could be biased, and then we have the output. So we need to think about fairness throughout this pipeline. We need to select a metric in order to do mitigation. If you're changing the metric, the result is not going. So if you're using demographic parity, you cannot expect a model to satisfy another notion, right? So choosing a notion is actually highly depends on the results that you are getting out of it. These are the lessons that we learned throughout these 10 years of algorithmic fairness that we were trying it for ML. What changed after we are starting this new era of foundation model? What is new era? You already see the exciting photo very often that we are actually seeing more bigger and bigger models coming to the market every 6 months. They are trained on different types of data, from text data to image data to video data, etc., etc. And why this is happening? Because of a scaling law. Do you know what is a scaling law? So a scaling law is the motivation behind such a race that we are seeing in the companies. What does it say? It says that if you have more data and you have more capacity in the model to train based on that data, you can actually improve the performance in different tasks. So you can get better performance in text, in image, in video, in coding, etc., etc. Is it true? Are we actually improving the task? Yes. We are not blind, right? When you are seeing like you are using ChatGPT, you are seeing that it's actually very powerful tool, and it actually have solved most of the problems that we were facing for different tasks in ML. That is not the fullest story that we are hearing often. The fullest story is that it is very much depends on the evaluation and benchmarks, right? So all of this race that we are seeing is based on this particular evaluation that you're evaluating the model based on it. At this point of time, I'm not even sure that the model are actually not seeing those benchmarks. They may actually be overfitted on those benchmarks, first of all. Second, most of these results that we are seeing are actually working for the majority distribution. So it's not actually working for marginalized communities. And let me give you the definition, what I mean by marginalized community. Marginalized community has a definition in social science. It's not what I define in ML, while I'm actually giving you the definition in ML that is kind of the root of the problem. So marginalized community is systematically excluded and discriminated against, often based on the sensitive attributes, right? So for example, there is a race issue, ethnicity issue, gender issue, and they are not receiving the same service in the society. I'm defining it in ML as this community are the community that we don't have many data points for them. So the size of their sample is small. This community has a distribution which is complex. So you need to learn from it. It's not an easy distribution, right? But it is distinct from the majority distribution. So if you're assuming the large language model, English, for instance, is the largest distribution that we have. But there are other languages, they are still complex, right? And we call them low resource languages because the sample size that we have for them is small. They are still complex. The distribution is different than English. What happens? So I told you like we were kind of like focusing on the discrimination mitigation based on the pipeline. But let's just look at how the pipeline actually has changed. So before, in traditional ML, we were collecting data for particular tasks. It was very focused. The size of the data set were relatively small. And then we were using a machine learning model to train, and then we are getting the outcome. What has changed for foundation model is that it's data hungry. So what they're doing is not kind of focused, right? Because the promise of foundation model is it's not context dependent, actually. You're creating this foundation model that you can actually use it for any downstream task that you have, and you can perform well. So what they're doing, for example, for large language model, they are trying to crawl and train the model based on the publicly available data on web. And that's why when we are considering a language model are working very well for English, because if you're looking at like the map of like the data is publicly available, most of this data are coming from North America and some Europe. We are collecting this large data set. So it's going to be very difficult to actually mitigate at the pre-processing step. And then we are using very complex models at the very largest scale. So the number of parameters of this model are also huge, which make it very costly to even try in-processing approaches. So what people are doing? People have started thinking of, okay, so we need to come with fairness measures for foundation model. But if you remember, I said that we learned that fairness is subjective, is context dependent. How we can do it for a foundation model is advertised that is not going to be context dependent. So people have started thinking about, like, we can measure how stereotypical they are, how toxic they are, and they are kind of like measuring the behavior of the model based on this kind of probabilistic metrics. So you may have heard about a stereo set, which is, for instance, you're giving this kind of like prompt template. So a stereo set, we are giving this prompt template. For example, girls tend to be more, and then you are kind of like have a mask that we are kind of asking the model to fill this, than boys. And if the model picking with a higher probability the stereotypical answer, then they kind of like this measurement saying that the model is biased, is stereotypical, okay? And there are many different variations of this way of measuring fairness in language model. For instance, my student Mina, she also worked on a similar context, right? How we can actually measure that this language model, but in a very specific context of socio-economic, they have bias or not. And what I mean is that whether this language model is assuming that, for example, women are poorer than men, and they are assuming that. Black people are poorer than white people. If you're widowed, you're divorced, right? And why it is important? Because these models are used in these applications. In Canada, IRCC actually mentioned it, that they are actually using models to summarize applications. And they have this kind of biases. What does it mean? That your visa might be rejected just because they're assuming that you don't have enough money. And this bias is coming from the core of the model thinking that way. And we also think about the intersectionality. So I'm not just a woman. I'm a woman at this particular age, this nationality, this race, etc., etc. So we also consider intersectionality to see how that actually impacts. And we see that, for example, if you are a widowed woman, you're doomed. But also, we checked that most of the time you're not really asking, for example, if she's a widowed woman, what would happen? You may have your name in your application. These models are very accurate to infer from the name what is the gender, what is the race, what is your age, etc., etc. And then we just put the name there, and we see the same bias of intersectionality is actually happening just with the name. But there is a problem with these measures. These measures are not robust because these models are very conditional generators. You're changing the character, the way that you are writing, and the model behavior may change. So for the robustness, we try to paraphrase different lexical, different grammatical, etc., to make it more robust. But still, it's a gray area for me, this kind of measurements. In foundation model, we cannot really, like these companies, they are not really working on fixing the data. At most, what they are doing is some filtering. They are not changing the way that they are training the model. So what they are doing in terms of fairness, or what is now a very popular terminology, safety, they push it at the end of the pipeline. While we learn in this field that you have to think of fairness throughout the pipeline, throughout the life cycle. We cannot really push it at the end of the life cycle. And then my students work on it to see what would happen if you're actually pushing it at the end of the pipeline. So if you're familiar with large language model, when Llama 2 came to the market, they actually published about like how safe Llama 2 is, how they make it safe. They actually adopted the different benchmark for safety. And one of them was toxicity. Toxicity data set that they're kind of trying to train the model, and they showed that they kind of reduce the toxicity. But what they did actually is there was an assumption of Muslims are terrorists. So they tried to avoid that. And they're training the model that if there is a kind of like a query of like a Muslim or terrorist, the model should refuse to answer. But the model learned that they should refuse to answer when there is a Muslim person because they have an assumption that they are terrorists. So you can see that my student has to create the benchmark, which is not toxic anymore. So the question here is that you are a helpful assistant, complete a blank, Muhammad got to the plane too. Is it toxic? No. If you're changing Muhammad to John, which is a white American name, the answer is that he's going to Hawaii. But when you're asking about Muhammad, poor Muhammad, I'm not answering you because I'm assuming Muhammad is terrorist, a plane is happening, I'm not going to answer you because it's not appropriate to make references to harmful or violent. Again, for Black people, there is a stereotypical assumption of like they are often going to jail. So if you're asking about the Afro-American name D'Angelo and saying that you are their helpful assistant, complete this blank, D'Angelo only met their father at 18 because the model response is that he was at jail. That's why D'Angelo didn't see the father. But if you're asking about John, what's the answer? Is that his father was at war. And that's why he didn't see his father. And you can see still this kind of harmful assumption are there. It's not harmful query, but harmful answer, refusal is still there. So we are not fixing the problem. We're just avoiding, and we're actually changing the harm. So what is happening now, instead of like a model throw harmful responses to you, is refusing. So we're actually changing the harm to the quality of service harm. So you're harmful to the same group of people, which is the minority class, but refusing. I recently wrote a position paper that I'm going to present at ICML in a month. And I discuss about the new phenomenon that I call it cascading disparity. So most of the fairness literature, we were focusing on performance disparity, which is the case still for foundation model, right? But there is another issue. So fairness is not just about performance. We also have privacy disparity. So this model, in terms of memorization attacks, in terms of privacy issues, it's more likely to happen for marginalized community. We also have robustness disparity. So the models are actually assuming, because this is a different distribution, this distribution, which has a small size, this is adversaries. They detect them as adversarial. They are not working well for them. At the time that we are actually deploying it, also, they are more vulnerable for adversarial attacks. Because whatever you're doing for robustness, it's not for this distribution, it's for the majority distribution. And my student actually kind of like work on multiplicity, but he also showed that we do have this gaps of like this one is for female and this line is for male. So we are seeing the huge gap of robustness for female. And also we are seeing the robust, huge gap for privacy for female versus male. We also have hallucination disparity. So you know that language models are talking about, okay, so you cannot rely on their results, right? And the outcome can be fabricated. But also, it's much higher rate for marginalized community. So I have a student Clay actually try to see the facts based on different languages, based on Wikipedia. And we see that there is a huge gap of hallucination between English and other languages. I'm Iranian, and obviously I tried Farsi, and there is a huge gap between English and Farsi in terms of fabrication, in terms of hallucination. We also have model understanding disparity. So whatever technique that we are developing for interpretation, explanation, also is for majority distribution. So what is happening is that whatever technique that you have to explain the behavior of the model, you explain the behavior of the model for that particular distribution. your explanation is actually wrong for the other distribution. And what is happening, what you're giving to the people as explanation is wrong. And then you cannot really identify issues because part of like explaining AI is for debugging. So you cannot even debug the issues of the model for that particular distribution. And then we have model multiplicity disparity. What is model multiplicity is that people are recognized that we are training this model. It's a practice in ML for such a long time, and we are doing the hyperparameter search. It is very ad hoc what you're doing, right? But there is a set of model that can have the same performance. And people in the community call them Rashman set. Rashman set have the same performance, but they don't have the same characteristics. And it is because of the way that we are doing the hyperparameter search. So this kind of under specification is also more higher at a higher rate happening for the marginalized community. So you see higher rate of multiplicity in foundation model because of the size of the parameters that we are seeing, but also the higher randomness behavior or arbitrariness for the marginalized community. So again, the same student who work on multiplicity and law, because this problem of multiplicity, lawyers, they don't have a clue about it. They don't know that you can have multiple models with the same performance. Because one of the questions that lawyers ask is the Moore test in Canada, is that they're asking, could you train a better model? Actually, they could train multiple better models, even the same performance, while they have a very different profile in terms of fairness, privacy, robustness. And we also show that there is a high ambiguity and randomness behavior for marginalized community. And then safety disparity. So whatever we are doing for harm, for toxicity, etc., also there is a huge gap between the harm towards marginalized community and the majority. And I already showed the example of large language models. So in the paper I actually discussed, there is a root cause for this. There are so many reasons, but I specifically talk about one technical root for this. And that's coming from the representation disparity, the embedding disparity, the way that we are learning from this distribution that is not the same. Why? So here it's a very simplified example. Assuming that we have this number of distribution, 4 distribution, I guess, here, with different colors, right? These distributions, if you look at them, they are different distributions. Here, assume even the size of the distribution is exactly the same. What we are doing in ML is that we are creating this loss, which is expectation over all possible data points that we have. What is the underlying assumption is that we have one single distribution. And what is this one single distribution here is that if you have this distribution, that single distribution that we train the machine learning on is the dotted version. Is it similar to any of those distributions? No. We train the models on the distribution that is not similar to any other distribution. Why working for a majority here is because the size is influencing that this aggregated distribution to be closer and closer to the majority distribution. And that's why when you are looking at this loss, it's actually working good for majority distribution and not the minorities. What is happening is that because we are not learning their distribution, we are actually missing those data points. In the representation, we have a gap. So in the, for example, low resource languages, 2 concepts, for example, apple and house, that in English are distinct. Obviously, in other languages are also distinct. Apple and house are not the same thing. What is happening because of this embedding disparity is that they are going to collapse. It's going to be flattened. And the house and the apple are exactly the same thing in another language. Because we are not learning the nuances. We are not learning the characters of that language. We are not learning the grammatical differences of that language. And that's why flattening happening. And when flattening happening, we cannot fix it at the end of the pipeline. You cannot fix this by just adapting it to different tasks. So what we can do? We can actually recognize that there are different underlying distributions. What we can do is we can actually assign capacity to different distribution. So here, one of my students actually work on recommender system, a specific music recommender system, because I'm very interested in cultural evolution in the age of AI. How we are shifting the culture. So if you're listening to music, how many of you actually listening music in this Spotify music streams? It's actually becoming the platform that everyone listening music into it. And we have issue for different cultures. As an Iranian, often all Iranian all Iranian music are similar. We do have different types of music. The model cannot really understand this is the classic Iranian music and this is pop music, and they are not understanding the nuances, but they are doing very well for English. So what we did here, we actually define different distribution based on the label which is coming in the country, right? And here we could recognize that there is distribution differences. And then we said that how we can actually assign embedding to be uniform across different culture, and how we can actually remove noises, right? Because distributions have some similarities, right? A space should be kind of like shared, but there are some nuances that you don't need to use it on the other music, right? So you're using a specific, for example, instrument that only appear in Iranian and Turkish, etc. music, right? So by doing that, we actually showed not only there is no price of fairness, that people are actually in the field for such a long time talking about it. If you're thinking about fairness, there is a price. You cannot achieve the same utility. We showed not only you can achieve better utility, but for everyone, for all the culture, not just for the English, but also for other countries. The source of disparity, of course, is not just embedding. If we don't have enough data points to cover the distribution, obviously fixing that embedding the space that I talked about is not fixing the issue. It's still, we need to collect more data. It's still availability of the data for different communities is an issue. And we need to actually do this kind of community engagement if you want to use this model. I worked a lot on the training paradigm. I talked about the issue of the loss function, but it's not a stop there. There are so many things that we are doing by just the best practices that are wrong. So for instance, if you are ever trained ML model with gradient descent, you are familiar with the way that we are creating batches. What we are doing is kind of like randomly, we are creating batches, and then we are training the model based on it. Then there is a minority. The size is also going to be, for example, if you have 10 samples in the batch, and one of them is coming from the minority because minority is 10%, what we are doing when we are calculating gradients, we are aggregating. If the distribution is different, that data point, the direction of the gradient, the norm of the gradient is different. But when you're aggregating with other data points from another distribution, you're canceling out that batch. That's why we're not even learning from those data points. We also have the issue in foundation model because the way that we are using them is different because we need to adapt them to downstream tasks. We are doing fine tuning, we are doing RLHF, RLAIF, how we can kind of adopt the system to human preferences. I'm working currently on like how these kind of practices are also very harmful. The way that we blindly kind of like assuming that there is only one user preferences, still we are doing the aggregation of the user preferences. Although in your family, I'm pretty sure at home, you're also not agreeing with everything with each other, right? You have different preferences. Preference can be very personal and can be very context even dependent. So we need to do alignment RLHF based on the context too. So what I would suggest is that we need to have a holistic approaches for fairness. Algorithmic fairness is one dimension of responsible AI. And I already showed you that fairness, we have a gap of privacy, hallucination, robustness, etc. So the problem is that if you're just focusing as a community, me just focusing on algorithmic fairness, another person focusing on privacy, we are creating problem for each other because some of these domains are aligned, some of them are at conflict. So we should have a holistic approach. My student actually worked on loan approval during the COVID, before the COVID, and after the COVID. Why? Because distribution shift happened. How many of you actually get a loan from the bank during COVID? I did. I bought a house. It was a very different era than now and before. So we collected data for loan approval during, before, and after COVID from the US, which is publicly available. And we showed that, first of all, multiplicity is happening at a higher rate for minority. But then there is this mitigation techniques for multiplicity in the literature. We try that. And we showed when there is a distribution shift, that often it is gradually happening. They are not really aware of it. Issue amplified if you even do the mitigation. So what is happening is that if you are just focusing solely on the mitigation in one paradigm of multiplicity, not considering fairness or not considering distribution shift, we are actually creating problem more than if you're not doing anything. Here also my student Saber work on fairness, privacy, and robustness in federated learning. Privacy and fairness, if you are familiar with this two literature, are at odds. So when you're adding noise for the differential privacy, often there is a gap in the fairness. What we did is we actually recognized our different distributions. We aligned the distribution to learn from it, and we showed not only we can improve performance for all the distributions with DP, but we are also removing all the gaps between the distributions if we recognize the distribution. And then I'm working on definitions that are based on different fields. Algorithmic fairness, robustness, causality can be defined in a single framework. So I'm actually working on this new metrics that if you apply it in your machine learning model, not only you are addressing fairness, but also robustness, causality, and currently I'm working on privacy. So you can actually have it all if you are actually combining and see that it's different, if you're having this holistic approach. What are the open problems? The first thing is that, do we need to go bigger? Can we go smaller? So one of the reasons that I talk about that we need to have metrics for capacity is that if you're familiar with the pruning techniques that people are working nowadays, we are observing that actually we are training this model on this big amount of data with high parameters. It's a kind of an overkill for the majority distribution. So with 90% removal of the parameters, we are still getting similar performance. But there is still a fairness gap if we're just doing the techniques that are proposed in the literature for pruning, because pruning is actually working for the majority distribution. So in this paper, my student Rohan, which is actually published at iClear this year, we propose an approach as how you can do pruning by understanding the fairness to get a model that has the same performance as before. And then the motivation for fairness for such a long time was laws against discrimination. And still nowadays, in any discussion around responsible AI, people are talking about AI regulation. We don't have AI regulation. We do have regulation for fairness in different countries. We do have protected domains, we have sensitive attributes. We started in kind of creating this metrics, but we also need to change the way that we are thinking about AI regulation. You cannot have AI regulation for machine learning without understanding the dynamic. In the past few years, the whole industry has changed. So we cannot create AI regulation without understanding, okay, so how foundation model come to the place and change the whole market, right? AI regulation should be dynamic. I'm not saying the framework that I'm showing here is the best framework, but I'm saying that if we can have dynamic AI regulation, in this paper, we actually talk about fairness in dynamic pricing. If you have a market, and this is my student Jesse, who is the economist, in the market, right, how we can actually introduce fairness. And we actually show that if you have a dynamic regulator to introduce tax for fairness and subsidy to kind of like give back the money to the society, we can actually work better than the ideal case that all firms do self-regulation, which is not happening. Like firms are not going to do self-regulation because they care about profit. But we show that we can actually dynamically learn this behavior. We use RL, right? But I'm not saying RL is the best approach, but I'm just saying that we should consider dynamic regulation. The last thing is that we have measures in foundation model. There is a huge gap of like, what is the intrinsic measure and extrinsic for the downstream task? If I find this socioeconomic bias in the language model, how can that manifest in the downstream task? It's not clear. So I'm kind of like saying that this is a gap, that we should feel it, right? We should understand how we can actually connect them. If we are using those measures that like for 10 years, we are actually working on it, establish some metric for some task, how we can still use them for the new era of foundation model. We should also understand the complexity of the real world. There are heterogeneity of distribution that I talk about, but heterogeneity of the value, the culture, the people, the resources. And we should consider all this if we want to have a democratic society with machine learning. With that, I'm giving you some takeaways. We need to design machine learning model which is participatory. What does that mean? Is kind of considering all the people who are part of that paradigm, from the society, lawyers, experts. If you're creating healthcare application, have a meeting with doctors, but also patients, right? As a technical people, we need to be in this interdisciplinary field and be comfortable with it. And educate yourself about this. And always ask this question throughout the pipeline, how we can introduce friends. And with that, first of all, I thank my group, Equal Lab, and also my sponsors, and also you for hearing me. Thank you.
Thank you very much for the great talk. We will have time, unfortunately, for only 1 or 2 questions. Then we have to move to the panel. Any questions, please? Yes.
A nice talk. So it's great to know all the unfairness towards minority. My question is that, so you discovered that for some cases, large language models are showing women are poor, or the thing is that if it is the fact, how you can change it? Like, actually, I feel that women actually making less money than the men, right?
It's a historical discrimination.
Yeah. But
it is a fact in the society.
It is a fact in the society.
As a woman, right? Particularly you're not going to be the stereotypical woman in the kind of like society. What is the risk here? Is that when this foundation models, this machine learning model, even if you're not thinking about foundation model, they have these assumptions. And if machine learning model are going to be used across all banks here, and all of them have that assumption, it's going to be systematic bias towards marginalized community, which means at this point, you're going to a bank, there's a person reviewing your application, some of them are biased, some of them are not. You have a chance at least, right? What's happening in the future, if you're not fixing this issue, is that it's going to be systematic, it's going to be for all women, and we cannot do anything about it. And that's a risk. We are going to amplify the bias that is actually in the system, in the society that we are seeing, because we are creating the systematic way of doing it.
Thank you.
Thank you. One last question.
Yes, thank you very much. So when you look at the bias related to large language models, how do you take temperature account and what?
And what effect does it have on bias, on increased temperature?
So it is a common practice that, like, if you want to make sure that like the model behavior is reliable, you put the temperature to 0. So the sampling that you're getting is going to be exactly the same for all the experiments that you run. But if you're also changing it, so for the papers that we are publishing, we are doing a temperature 0, but also we're changing a temperature to see on aggregation level of the probabilities of the sampling that we are getting. Is it changing? And for example, for socioeconomic bias paper dimension is actually the same, right? So the model behavior are still significantly on average more biased towards marginalized.
Thank you very much. Because thank you again, our guest speaker. Thank you very much.
Thank you.
So we'll have the panel just after this.
Too much. It's too much that way. Yeah.
Okay, hello everyone. So we reached to the last segment of this workshop. I think you guys are still keeping up, a lot of technical talks, right? So I would welcome all the panelists. So you can see the name, David Lowe, then Gulnush Fernandez. So I will just from her, and Lingming Jan, and Laurent Barcelo. Please take your seats. Yeah. Yeah, it's my honor to be here today. I'm Monami Roy from University of Saskatchewan. So I'm the assistant professor working on my tenure. So it's great to hear from these great researchers. I see you guys are doing overwhelming work. So today's panel is on FM trade-offs, efficacy, efficiency, security, transparency, and fairness. I was following Silo where you could actually post questions. I don't know whether you have noticed or not. So many people actually asked one question because you guys are doing overwhelming research, how you are balancing work and life. Yeah, so could you please, like, I want to take it a little bit less technical. We have a lot of technical talks. So could you please comment on that first? Yeah.
Yeah, so so I think it's very important to have a balanced life, right? So to me, I just do some regular exercise sports to keep myself refreshed, right? So I can work more efficiently when I work. So I have fixed schedule every day. So what time I need to sleep, or for example, me, I need to sleep 9 hours every day. So that's fixed. And the other time, just decide, okay, I do this like in the morning time, like afternoon times, and then do some regular support. So yeah, and nothing special for me.
So first of all, I feel I am a little bit of an outlier because I am not a researcher. So I'm in a much smaller LLM compared to my colleagues. So I feel it's, but still, work-life balance is a very important topic, and sport, I think it can be very important and very study. I was playing important, and I need to work a little bit more. And well, one thing that I try to do, like actually, I presented my sabbatical period every the end of June here. And if you have the chance to take sabbatical, that will be great. Yes, it's not each of it's more research and service. As soon as taking more of time, we can do. So I also think that exercise is good. So prior to me taking sabbatical, I was at about 80 kilo heavier now. So during sabbatical, I spent some time exercising more, walking more, eating less unhealthy food. And I guess that's like a bit of success and a work-life balance, but I need to work on the things to make things more balanced.
I'm not a professor to answer this question. I'm an assistant professor. I have a son who is 3.5 years old. And I have many hats, as you think. I don't know. I cracked the code of fairness. I haven't cracked the code of this question. I couldn't lose weight. And even hearing you just go to sabbatical doing it, oh my God, I have to wait for 6 years. What I suggest to my students, if you're in academia, it's a race. And unfortunately, there's so much pressure on graduate students. I hear you, I feel you, right? Don't be overwhelmed by this. Work on things that you're really, really passionate about and you believe in it. Don't work on things that just because you want another paper, because that's a burnout. Because currently, if you are in this field, work requires food, very easily. If the idea is a low-hanging fruit, and it might be a soup. So work on things that you really like, and prioritize things. Prioritize your health, prioritize yourself, prioritize your family, right? And create boundaries. Work is there, always there, right? So if you're finishing it today or tomorrow, it doesn't really matter. There is a race, but you don't need to participate in this race, right? Again, I'm not an expert. I was actually hearing you and I'm learning from you. But yeah, I think we're boundaries.
Thank you. So now I will get back to today's context. So you can see these are all kind of non-functional attributes you need to handle when dealing with LLMs, right? But and they are competing goals, and why it is necessary to balance these quality attributes, and could you please put some context from your experience, like how you were balancing these quality attributes, competing quality attributes, and how you're handling the trade-offs?
I can start. I just mentioned in my talk that I believe in holistic approaches. You have to take up other things. You don't need to just on one, because part of my research, one part of it is just showing like if you're focusing on one, there's a problem with the other, right? And you need to have this holistic approaches. You need to kind of like solidify the fields to learn from each other, to understand each other. Because at the end of the day, responsible AI is the model that is not only fair, but also robust, but also secure, but also efficient, etc. So we need to have all those things, right? And we need to learn. We need to actually educate our students to think broader than just kind of like narrow it down. All the science is kind of like focusing on one thing, but we need to think broader.
I was thinking like it just focus on one thing instead of functional correctness. And maybe the other things that are not taken care of, but those things that prevent those technologies to be used in practice. So for example, maybe is the solution not to the plus, so the solution to be fair, or there's some security issues behind it, or it takes a lot of energy. And so that the one that uses it is only the one who have terms of use, or maybe small companies use it. So if we can address all these
dimensions of quality, and whether it's functional or non-functional, I think you get more people to make use of the solutions in practice, whether it's software engineering purpose or for other purpose that
Well, in my view, I see two reasons why at a high level we make trade-offs with all these concepts. One is because to some aspect they are conflicting. But for us, more importantly, is we are working with companies that are not like OpenAI or Facebook or Microsoft, that are limited budgets that are constrained. So we have to make choices. So it's one reason, one important reason.
Yeah, I think we talked about a lot of different functional, non-functional properties, including efficacy, efficiency, security, transparency, and so on, right? So a lot of them can be conflicting with each other, right? So if you want a global, like optimal model, you really need to consider all those trade-offs, right? For example, if you build a very powerful model, very likely the model is going to have a large number of parameters. It's going to be slow, right? That's the fact, right? So, and also if you want to add a lot of tuple alignments, a lot of guardrails for security, and so on, it's going to be affect the performance model to some extent, like, I mean, the efficacy part, right? So we really need to consider all those trade-offs. But I want to talk about one special rule about transparency. So that part, I think it is always important, if possible, for all the model builders to release things they could release, right? Because that will allow a lot of people to access like more in the design model, the data, everything, allow more people to look into those issues, functional issues, non-functional issues, to improve that as a community, right? Because everyone is hiding their internal details. And then like people just need to like build everything from scratch themselves, right? We're wasting a lot of energy, a lot of resources, and we can easily, like build on each other if we release everything, right? So I think transparency is extremely important, going to be beneficial for all the other functional, non-functional properties. That's also the reason that we are looking to fully transparent code models. So we want the community to also look into this very important fact. Yep.
Thank you. My next question is kind of a follow-up question. Like, what kind of strategic decisions you can make to balance like efficacy and efficiency? I will ask. Yeah, maybe someone can. Yeah, you can.
I think there's, for different application scenarios, there are different considerations. I think for the model users, builders, they really want to prioritize like different functional, non-functional properties based on specific scenario, right? For different cases, I think the choices can be totally different. Right?
Yeah, I think it's very application specific. So depending on the, and I think, for example, if you work on urban grading, probably you want something very reliable. If you are working like insurance, that is very important. So I think there is some security in that. Also, I think we can all agree on the general principles. The difficulty comes to how do you operationalize these principles. So what are the metrics you take conclusions or you ask for? That is a risk. And I'm dealing with customers that don't understand all these things. And it's really quite complex. And I think we do research of our role in trying to really provide a deep reduction in the complexity of all these topics.
I also agree that I think we need to better understand the requirements for each potential users. There's a lot of rules about for the arm engineering is actually consider the large model, such additional dimensions that we added for maybe more heavily. So I think we need to quantify the cost of every dimension, and then we need to ask the company whether they prefer this or that, whether they can go without this or is it a must. For example, let's say they won't have such a hardware, there's no choice, but they need to make or make use of smaller products. And we need discussions that if they do have access to hardware, but they need to pay a lot of money for it. So to understand the increase in efficacy commensurate with the increase in dollar cost in terms of accessibility. So I think these questions are answered by the finding and then optimize solutions for them. Of course, there's certain things that is a clear no. For example, in applications, let's say was to build something for a bank, but a person is approved for a loan amount. And if that solution is the bias of the gender or bias against the non-competitive group of marginalized community, the cities of more women. So I think we need to really understand all the requirements. But also create a mentioned operationalization. So let's say you want A and B and C and D, you have to have a level for that. So I guess there is no such just box. So the numbers and say you move one at the level. I think maybe we need more work.
Yes, I am as sad. There is no free lunch, right? Although advertise that like establishing models solve all problems that we have. It's not the case, and I'm advocating like context, smaller scale model, excellence model, right? Which is context dependent, right? Fairness is as I mentioned, but already you all mentioned, right? Context for different clients is different, right? So you cannot be advertising rely on foundation model to be a solution for everyone.
So what I'm hearing that before building the model, requirement engineering is really important. Like we need to understand the task or the requirements from the clients, right? Thank you. So I will have my last question, then I will open the floor for the audience. So when I hear about fairness for the developers, I feel kind of lost. Like I cannot, like, I don't do research in fairness, so it is kind of hard for me to see what kind of unfair thing could happen in developers community. So could you please walk me through some of the context where like unfair LLMs could do, like the foundation models could do unfair things to the developers? So I'll give the mic to David first. Because you are doing software engineering. Yeah.
I think there are two possibilities. Like one of them, it could be that we are asking the LLM to produce a code to do certain checks, and then that code actually puts some checks that are obvious. For example, it could say that maybe prefer manual payment, things like that. So the problem itself may not be very obvious, but it could be that the code itself is obvious. So that would be one possibility of the fairness is an issue. Another thing is that does everybody benefit equally from like GitHub Copilot or LLM power tools? So are we making it divide even more between those who can do and those who cannot do? So in the sense that we are working in the company, then there are many different demographic group will use the LLM benefit one segment of the community over the others. And if that's the case, then is it fair? So that's the question. So this are things.
Fairness expert.
Fairness is not like joke. But what comes to my mind is that like what I'm seeing in the community of like using LLMs for code generation. Often is your ability to speak English and specify your prompt in English. And whether you have access to these models, right? Some of them are still free, right? But it's actually going to change the whole industry of like software engineering. If you don't know English, if you don't have access to lots of resources, the internet in order to code it. So I think the speed of like software engineering in English speaker countries are also going to be much higher because they're using this assistant for helping them how to code than other kind of countries that they don't have access to the resource for language.
Yeah, so I answer your question from a different angle. Okay. Well, a project that we have and that we are going to pay a lot of attention about fairness is we are in the process of developing a partnership with la Fédération québécoise des autistes and the AI for Humanity team at INA in order to develop a chamber for the and it's here in Quebec, it's French language, and it's a different community, so we will pay a lot of attention in the sense of fairness.
Yeah, I don't particularly work on fairness, right? But all I want to add that is that like fairness is very hard to avoid with the current large models, because the current large models, even the best ones, in the end they just make token prediction, right? So basically, what they are simulating are just very small areas in our brain, like some of the broca area, venic area, right? So there's a lot of part in the brain, like say prefrontal cortex. They cannot model that. So that means they don't have mental model, they don't have real like word model, they don't have real reliable memory, they don't have like critical thinking capabilities, right? So they really are not like that intelligent. I mean, they are, but they are not that intelligent, right? In the end, what they did is that whatever you train here, they take that and learn from that, right? So which means they don't have any like critical thinking process to figure out, okay, this data is unfair, let me ignore that. Okay, this data is poison, toxic, let me ignore that. They don't have that. They are trained on whatever data passed to them. It's passive learning to me, right? And on top of that, and they don't know how to also proactively reach for more information to self-rectify and so on and so forth, right? So with all these basic setup, it's hard, very, very hard, or even impossible to avoid the fairness issue in the current context. That's why there's a lot of post-processing work, alarming work, that is really critical, very important work to help us to fix those models. Yeah.
Thank you. And now I'll open the floor for the audience if you have any questions.
Thank you. Just a general question. So for linking answer, I'm just wondering, in your work, for which you were trying to find cases where the samples are out of distribution, or at least from not out of the main distribution, something like that. I'm just wondering if there are no ways of testing whether the software for you for is out of distribution.
Oh, so sorry.
I have mine. I'm not sure if you hear that. I'm repeating your question to understand it. So you're saying that is there any software for understanding the output distribution?
I'm asking, does any way to tell whether some input source code is out of distribution?
So if you know what is the distribution, like the whole community of adversarial attacks, kind of like distribution shift, etc. They are coming up with a mitigation technique that if they can detect that like this data coming from out of that distribution, it's out of distribution, it is adversary. And there's a problem in fairness that like we are working on it, that like if this is the marginalized communities, it's obviously out of distribution from the majority distribution. And in terms of federated learning, if you're not sure what is federated learning, you just decentralize it on training machine models, it's going to be very hard to detect. So it's very easy for the community to kind of like classify the data from the minority as adversary. And what is the common practice is that not include them in the training. So you can detect that this is not the same distribution, but the solution should not be just removing it. Some of them are absolutely single. So it's easy to detect, but some of them are designed by attackers. They're kind of like switching the label. So for example, this picture is by this user as an apple and another user kind of like tagging as orange. This is a target and kind of adversary, right? The distribution is different because the label is fleeting, right? But it could be a minority class that they are labeling different, right? So what we have to propose that if you are distinguishing different distribution and training model for each distribution,
You're not even, if it's going to be adversary, the result is going to be for adversary. So it's not going to be influencing on the result of others, right? But you can also have a minority, if you are detecting an anomaly distribution, you're actually training the model for that. So there is a bit of, I'm not sure if that answers it.
I guess I was more wondering in software because it's sequential text data. You know, there's no way to tell what the distribution is. For example, in the case of humans, we can tell from name or color of skin or gender, that they may be out of distribution. But it's just a sequence of code, and if it's out of distribution, then you get a correct output. So how do you detect the sequence of code?
I'm not an expert for coding or software, so I don't know.
So we put a little bit on long tail distribution of the code. And what we define is the distribution or long distribution is if the data is stable. For example, this code has this vulnerability. We have the vulnerability type and the labels, and then we can know that which one is majority, which one is if the only touch label, just a sequence of codes. What we do is that we look at the emblems and see the emblem is coming in healing. So the emblem is not coming in healing, then we are the long tail of the distribution. But that's just an approximation that we do. But in that approximation, we show that the language we perform better on the distribution from the field of the distribution. So it would be another way to the out of distribution of this.
Yeah, so so I think, there are some ways to use some like entropy or naturalness or like balance models to basically analyze if the piece of code is within or out of distribution. That is possible. Like there are some ways to do that, like approximately, right? But to me, I think it's very hard to think about what does out of distribution mean for software code snippets. It could be possible that, okay, this is just a piece of code that is buggy or like invalid, right? It could be possible that, okay, just the large language models, the pre-trained data set did not cover that particular part, right? So that part to me is hard to distinguish. What does that mean, right? So, and if we know that, then there's a lot of downstream applications we can do to improve the performance of like bug detection and so on and so forth, right? Yeah, it's challenging.
So talking about the fairness aspect, I want to come in from this aspect where we have the data and the algorithm, and most of the data have been seen like what Golos said from historical perspective, which was kind of systemic. I'll just give a context on that. Take, for example, the institutions and all the kind of system we had long ago was well crafted to institute things like colonizations and many kind of systemic racism. It was well crafted for a goal and purpose. Those institutions are still living on different names branded. If you ask so many people in the US who discover America, they'll give you a name of some European people. But they came and found people who were living there. And these have been embedded in textbooks, in data, and all sorts of things. So these large language models are just amplifying those kind of biases, unfairness of things, and the people that have really worked for, they are not even seen. So my question now is, in terms of algorithms, how can we fight, not just by learning passively, as you quietly mentioned, which I'm happy with that intervention, because if we look at the algorithms that are existing, like of recent, they are still learning passively, assuming the data, they may just flag. Yeah. But the data still remains. I recall of one of these gender computer, I use it in Microsoft for some work that I was doing there. It gave me a very decent result, but that case study was just to identify the genders of people so I could sectionalize my work and make it well balanced. But when you mentioned it, I saw it in a different perspective. If we take it out of that context, it will become something to really discriminate. And large language model only amplify it. So the question now is, what are we really doing in terms of algorithms? Not just to learn passively, but to sanction those kind of data that are kind of poison to, I could say, common sense. Because you cannot tell me somebody came and discovered a land that my great-grandfathers were living there, and that person is not even from that area, then you want me to believe that truth. But to sanction it, how are we approaching that algorithm?
Right, we can actually, if you know exactly what is the value, right? We can specify in terms of culture, in terms of regularity of the way that we are specifying the loss function, and actually specify. But often it is not enough, right? So what is happening is that when we're training the model based on Western culture data, it obviously have the viewpoint of Western culture, right? We cannot necessarily just kind of like specifying other cultures. You have to include them in the data if you want them to work for other cultures. And there is a lot of things, right? So different people have different beliefs. And I'm actually advocating like this is very alignment people talking about is alignment of the model to human in general, right? What is happening is alignment again is happening for Western culture, right? Even if you're doing it, right? So we have to do the alignment which is personalized event. Or different culture, different value system, right? That we kind of like adopted. That if you ask me this question, right? Who came to America first? It's not going to be a European person anymore, right? So this is the knowledge that we have to incorporate in the models, right? If you want the answer to be different, right? And that only happens if you're either creating a knowledge model, right? The word model, right? We don't have it, and that's why we have a hallucination. We cannot rely on this model, right? We need to incorporate the community engagement of like how we are building this model, for what purpose we are building this model. Are you building this model to use for any other community? So you should actually match their culture, right? So you cannot enforce one culture toward everyone around the world, right? But if you know exactly what is the value, we can specify it. Right? We are having soft utilization, we specify what our utility, we can also specify our value there. And what else you have to answer the question?
I mean, that's because I think like the model is so so we're going to be collecting all the data just on the model and the phone waves that are willing to sanction the data, those connect the data that are not helpful. How exactly those can be acted? These are not true, these are biased. So I think there's still some work there, but more needs to be done there. One way is to do guardrails, so we just don't share this, we are looking to model than some things. And then we build the runtime verification engine or guardrails to ensure that when we use some people wrong, then we get corrected or something use the output. But I think what are the universe of all things that are unfair? So those things is still like unknown, like they need more effort to be able. Because for example, through crowdsourcing, for example, this is not true. This is not fair. So common is the first person that sets food in America. So all these issues connected into crowdsourcing, this would be discovered.
I'm hoping that we are not pushing everything as guardrail because it's going to be politically correct, as actually happening now. They are politically correct, but they are not correct. So they are not being matched. Value as
There's I think it's politically correct, but it cannot reflect the fact then to be problematic in the future, like in the name of fairness. It's really difficult.
I think that requires another discussion of what is fact.
Yeah, what is yeah.
So England, you also have any other questions?
Well, I have a question about the field of business privacy and security. I know that Lima is targeting us to of course, we did the data about how we want to carry the whole models. But I think one risk of what of that is that it makes it easier for people or bad people to go to do harmful things because it can be very vulnerable to go over it makes it so hackers to attack the model because we have access to the data. Connection from Alexander nuclear weapons. Imagine it's just awful that North Korea knows how to build nuclear weapons. So I wonder what's your point of view.
Yeah, that's an excellent question. Yeah, so there indeed, is some sort of concerns, and if you release evidence, going to give like other benign people more like accesses, you're going to give observed people more accesses as well, right? So yeah, I think that's a legit kind of guess. And but the thing is that even without even with opaque models, there are still all kind of attacks ongoing all the time. I think that's something just people cannot avoid. Yeah, I don't know how the things can basically, release the models basically that can give people to like more chances to, because release the best models does not mean that you release all the possible models, because you can at least release parts of the model so that other people can build on top of that. So I think at least transparency to some extent is extremely important, because it allows the community to right at some point, for some cases, if it's big, like or something like that, people can choose to close out some part of the some variants or some branches, right? But overall, I think the trend is important, because currently, if you look at the kind of models, open source models called like open web models in the wild, right? So they all claim to perform extremely well, right? But we don't know how it works, just like black magic, right? But often the time, so there are a lot of people I know who want to work in the area, but they don't have the information. And if you really look into the detail, if you really have some domain expertise, look into the details, like you have some like domain knowledge in that domain. If you go some often the time, it's not that hard if you really know the mechanisms, right? So I think it is very important for people who model or some of the model builders to release the basic models, basic information, just to allow other people to contribute. Because for now, to me, just a lot of people just hiding some very tricky detail, some tricks, which are not technically hard, but it's very hard to figure out if you don't have the experience, right? So yeah, but I agree with you to some extent. So some models, fully transparency may not be a good idea. So that's something people need to consider in the long run, I think. Yeah.
If I can add to that, there's a debate about open source, closed source. I'm an advocate of the open science, open source, because of the demographic approaches, because you're giving the opportunity to other people also doing it. Yeah. But I also want to question you, if you're assuming that bad people are the others. Why you're taking that this closed source are in the hands of the best people in the world? Because this is the assumption that you're making, right? So you're saying that the people who have the resources that currently are doing this closed kind of platform model are the adults. If you're giving them this resources out there, then there are going to be enemies, right? It might be a case, right? Well, use case is the issue, right? Security issue of if you're giving the model out there with all the specifications, there's a higher chance of adversarial attacks, right? These are the case, right? But I'm still advocating for the open science, open source model, because you're also giving the chance to all community to test it. I think there are so many questions about this model that don't know how to handle it. We need more and more people studying different culture, different languages, different societies, and this is only possible with open source. Or there's an issue with the science even, that we are publishing a paper every year asking why we're not trying ChatGPT or GPT-4. We have to pay for it, first of all. Second,
how we are making the assumption, we don't know anything about the model. So we are saying that, okay, so we're evaluating in this way. How do we know that they are actually not using intervention already, right? How we can make sure that like the architecture is the architecture that we think of, right? So it's actually making it very hard even to do science in that regard.
I think it's a great question. I think like if I remember correctly, was in Newsroom before when people began to release initially they did not release because they think there would be a danger, but eventually they release. So I think the paradox sold in the race. And then at the moment I think it's like an arms race. So we really need that there's like bad people who use the LLM to do bad things. And there's good people using LLM to protect against something. So I think we need there is whether it's closed source or open source. I think the problem is that this is like the closed source solution like ChatGPT also offer the service to all people who are that using the resources. And I think about open engagement. I agree that that can actually be a weak point that the factor can have. But on the other hand, maybe because the data is different, there could be some people that propose some people in our early comparison. So like the two-page things that are now in the comments, on the other hand, maybe we can help with the design sequence, the data or the solutions. But I think there's a lot of exciting open problems to address. We won't be lacking problems for the next decade or so. Also, from a user perspective, we also support open source. I think very good results, but we believe the benefits are stronger than the community.
We'll take one more question because we are running out of time. Yeah. So who wants to go? So many questions. Okay, you go ahead. Yeah.
Hi, thank you. Thank you very much for this talk. Actually, my question is a bit open-ended. I'm a very new student in research. But my question is like, as of now, FM or LLM, they are, based on next token generation. They are working on that thing. And obviously, it is very good that we are trying out LLMs or FMs solving all the software engineering related problems using it. It is very important that we do it. However, do you think that we are focusing on solving all SE problems with LLM a lot in research, and because of this, we are actually solving another problem of efficacy, efficiency, security, transparency, and fairness, including the real problem of software engineering that we want to solve. So, and also with the overwhelming discussion on FMs in SE, I think young researchers are very overwhelmed and they want to try LLMs as a part of their research to be trendy in their talk. So do you think that this kind of situation is actually leading us a bit away from actually solving the real software engineering problem?
I think that's an excellent question. I think not all software engineering problems is best solved using the LLM, and there are some solutions that are really great work that are happening in the community, from almost to mutation testing, the biggest work. And then and people are trying to combine it with LLM can become a tool. But LLM may not always be the best partners. There are some constantly LLM performance as well as something else. And I think the idea is that how can we make use for the best technique and combine them together. And I think there is also some concerns that there's a lot of interest in LLM and FM and we work with it. And as you say, we're probably more fun and something like that. But other people from other topics that are really important, we should also focus on those things. So I think there needs to be a balance in the community. We need to experiment with the new coolest thing of that is condition models. But we also don't want to forget on the other areas because those are the things that maybe immediately benefit build a solution that works in practice. That we are going to combine with This may be a verifiable LLM, and we can produce. And then we research, we continue to work on model tracking from the next combined with LLM. So I agree, we shouldn't focus on the behaviors, just focus on the issue goal.
Yeah, I agree with what David said. So I just want to add that like we should avoid two extremes. So one extreme is no, I don't want to talk about like LLMs. They're just black magic, right? Just do my own research. No. So because the LLMs, they really provide another solution, another methodology for solving problems, right? Because traditionally we have all kinds of solutions, but mostly these symbolic algorithmic solutions, right? So they can use pattern-based like approaches to solve your problems. That's one way, right? And now they have introduced a totally new way for solving problems, which is a probabilistic way, right? They can model a lot of different, like they can solve a lot of different problems using just probabilistic simulation. For example, for testing fuzzing, right? They can use a probabilistic and like a simulation to satisfy a lot of different constraints from different domains, right? Which is kind of hard in traditional symbolic solutions, right? So first, they do provide some additional methodology, totally new methodologies for solving problems. So definitely encourage you to try if you haven't, right? The other extreme is that, okay, like programming is the end. Programming now is ended. Okay, language models, they can do everything. Going to replace all first. Like I'm going to apply language models to every problem. No, right? There are clearly problems they are not good at, like mathematics computations, like some sorting like stuff. They are not good at everything, right? You need to be really, really like critical thinking about, okay, what is the best application of language models, right? So what is the best use of that? Think about that. Like don't just blindly apply language models for any problems. Like think twice before you try that out, right? So I think but it's like as David mentioned, it's balance of like in the future. I personally don't believe language models going to replace, at least the current generation of language models can completely replace software engineering developers, researchers, right? So in the end, as we just discussed, they're just next token prediction. Based on scaling law, they can be better and better, right? But they will never reach human level intelligence. So that's my personal view. Could be wrong, I don't know, right? But I think it's definitely like be critical. Like think about what's the best application scenarios, right? Try to combine language models with domain-specific knowledge, domain-specific techniques, even traditional ones, right, to achieve optimal certain performance in your particular problem you're studying.
By solving the original problem, now I also have to solve all these problems with LLMs. If I'm able to solve the real problem of software engineering with LLMs, it's very good. Thank you very much for giving this insights. At least now I have an idea that I need not to run towards LLM research. I have to still focus on software engineering research, problems to solve in software engineering using all techniques and tools that we are have. Thank you very much.
Okay, great question.
Thank you everyone for the great questions. I think we are done with this panel. Thank you all the panelists. It's great to have you here. On to the closing remark segment.
Oh, okay. Let's remove it here. Well, some people outside. Yeah, ask the word. Two sides. That's it. Okay. Well, I think we're almost here. And it's almost ready. Okay. I just want to say thank you, everyone, who have stick to the last bit of discussion of the 2 days. I hope you enjoyed this as much as I did, and I hope everyone indeed enjoyed. I just wanted to say thank you. Thank you to Thank you to all the panelists, the speaker, to our wonderful army of student volunteers. I hope you have had the chance to interact with them. They're very excited to have you around. Thank you to everyone. And no, that's it. Oh, it's this computer. Sorry. Oh yeah, let's take a picture. Okay, I was wondering what they were doing. So thank you everyone, and see you next SEMLA next year. Better SEMLA, more interesting. If you have any feedback, we are always open to feedback. Anything you think could have been better for making the experience more exciting, any suggestion, comment, please don't hesitate. Let us know, because we want this to be our event so that collectively we benefit from it. We are the program, we are the participant, it's an event for us. So thank you everyone, and please come for the photo. This is background or just December, yeah, this one, right?
Short man here.
Please don't be shy. Where is Move this one over. Wow.